Oh, okay.
And then this is his formula.
Maybe it was degrees Celsius.
Well, hopefully it's Fahrenheit.
Gravity changed so much with temperature.
What
am I seeing? Can you?
Dude, I don't even know, bro. He tried to say that these two formulas are the same. The first one and the second one.
Okay. Sounds like audio's fine. Audio's fine. Everything is fine. What was here? Oh my god. Okay, so you, Mr. Slave, can I know more about your theory? Sure. Let me give him a path. The New York. Alila lila de New York. Alala de New York. The New York. Alila la 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 la. I don't have audio, sorry. I also don't have a mic. La la la. LOL. So just watch my videos. Yeah, if you explain via text. Here's one paper. Here's another paper. Read the papers. Yeah. The question is, okay, we need to study some physics. Enough nonsense for one day. Oh my god. I mean, I don't know why talking VC would be better. I don't get it. I don't know what the heck this guy is talking about. He wants me to type my theory in text just for him. Let me see my theory, my gravitational theory. Why does the apple fall? So this is gravitational. Oh, somebody's already watching. I guess it's him. So, oh my god, what's the question? So anyways, I don't have a Google account, so I don't think you would be able to see my profile there. I don't care. What is this guy talking about? I really like to draw My Little Pony. The only shame in masturbation is the shame. Fazer. Oh my god. Fazer alguém. He's Portuguese. Pedir acesso de edição. Arquivo, editar, ver, ferramentas, ajuda, Fazer, in what language is fazer? Fazer is Portuguese, no? Os títulos que forem adicionados ao documento aparecerão. Yeah, this is Português. Aqui aparecerão. This is Português. Estrutura de tópicos. I don't know. It's fazer, I think fazer, pedir. Arquivo editar. I think this is Português. Let me see. Fala português. Fala português. What language? What are these? One mutual server. Oh, he's from Earth Awakening? Sim. Eu falo pouco. Eu sou fluente em português. Que legal. Já. Oh, não, isso aí. KKK. KKK is LOL. Tá. Como você aprendeu português? Eu. I don't remember enough Portuguese to even answer. How do I know Portuguese? I used to live. Yeah. I used to live in different places. Now es importante. Now es importante cuando tienes. I don't remember Portuguese. I don't remember my Portuguese. I will type in English. You answer in português. Tudo bom? Tudo bom, tudo bom. Tudo bem, tudo bem. Tudo bem. When will you be able to speak? This would be maybe a good opportunity for me to try and explain it in Portuguese, explain my theory in Portuguese. In Portuguese. Quando eu comprar microfone. So go buy one now. Quando eu comprar microfone. Bem, eu estou doente. Pois eu estou doente. Então eu não tenho força o suficiente para comprar. He doesn't have energy. Suficiente. I think suficiente is enough. Doente. What is that? That he's poor? What is doente? I need the translator. Oh my god. Sickness? Oh. Que mal. Em português. Em português. Okay. Eu estou doente. So that means he is sick. Então, eu não tenho força. Yeah, that's what I thought. He doesn't have force or suficiente. Oh, o what force for suficiente para. I don't know what is force. Força o suficiente. Suficiente. Sufficiente. What is sufficiente? Okay, whatever. Going to learn how to work. Donde vives? No, how do you say in Portuguese? Where do you live? Doente, eu estou mal, suei de ruim. Brasil. 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 Que legal. Completamente legal. KKK. Completamente. Brasil é muito ruim. Oh. Sim. Muito quente. Horrível. Completamente. Completamente. Onde você mora? Eu não. No. I don't disclose personal information. Where in Brazil do you live? São Paulo. Rio, probably Sao Paulo, like a lot of them live. Eu não compartilho informação pessoal. Oh my god. I wish I could talk to people in Portuguese. That would be awesome. He's a feminine femboy. That's so funny. All right. Let's see if there's anything happening.
Yeah, something tells me he's not a real engineer.
Let's see, you're playing Metal Shell Game Zero. Let's show how it works. 20,600 over 2 pi. Okay, so you just derive the radius value.
Tutorial?
Hey there, buddy.
Hey. Do you know the Schrödinger wave equation, wave function, whatever?
I know of it, but no, I've never done quantum mechanics.
Interesting. But you know physics. I mean, you know GR, right?
I know a little bit of physics, but no, I'm not a physicist by training by any stretch of the imagination. Never claimed to be.
Yeah.
I got a small question.
Yeah.
Can you define a mass?
Can I define mass?
Yeah.
So the purpose of definitions is actually very technical. The purpose is just to communicate thoughts.
Do you know what a yes or no question is?
I don't like your tone, so you need to be
Like,
nicer.
When a person asks you a question and you need to say yes or no, why do you like changing the subject and pulling the time?
Well, as I said, I don't like your tone, so you have to speak nicer. You have to be nicer. Don't be so
I
rude.
don't like your tone. So what?
So don't talk to me. If
So shut the fuck up.
I'll do whatever I want. If you want to talk to me, then you have to talk nice. Why are you so rude? Besides being gay, why are you so rude?
Big. Okay.
Yeah.
What
First
was
of all,
that
you
about,
call
Mr.
it-
Slave?
What?
What?
What was that about?
I'm assuming that he's gay if he's so belligerent.
Okay, yeah. Well, you're an asshole for trying to use that as an insult. So
No, I'm not
right
using
there, you're automatically on my shit list.
I'm not insulting.
Also, you're an asshole because you went on Earth Awakenings and you said this whole server is gay, and you said we're lying for hours and abusing you, and then you went on a huge rant, which we have a recording of, that you said that everyone here that tried to explain you stuff is gay. So, do you think we should talk nice to you?
Well, I don't leave you a choice. If you want to talk to me, then my condition is you have to be nice.
Okay, well, we don't want to talk to you. Go away.
Well, oh, so they muted me. Oh
You're gonna
my.
be such a fuckhead that you're gonna use that as an insult. Then you can go ahead and talk to somebody else. Okay?
No,
Wow.
like actually, you went today for like 5 hours explaining how globers are gay and how they want to be hetero, and was like one of
I mean,
the
that's
weirdest shit I.
That's some bottom tier shit flinging.
Why? Why would you be so weird about?
So this.
Anyway, let's go back to laughing at that gravity crap that J-Ro was pulling up.
Anyway,
Or was that what we were talking?
they're so upset. They're always belligerent. They never, especially this guy, misinformation agent. Let's see. Wait, what just happened? Oh, they booted me. Wait, did they boot me? Is it locked? Wow, talk about upset. Oh my god. Somebody's butt is hurting. Oh my god. Jesus. Talk about butt hurt. Husband's home. I can't talk. Maybe tonight. I'm not sure if he's going back out. Okay. So he attacks me. That guy attacks me like crazy. I just came in. He already is attacking me. And I just mentioned, well, you're gay, which he is. That's why he's so belligerent. They hate hetero. And that's it. That's the end of the world. The end of the world. I mean, they can attack me For literally days, that's fine. I just call them gay, which they are, not even as an insult, and they get butthurt. Wow. Eu gosto de pizza. Que você gosta de comer? I just ate. I actually love pizza too. Pizza is muito bom.
Well, that happens from one Gaussian surface to another. Two parallel coplanar surfaces is how that occurs. Like there's no replication of that of a center of a ball having that effect going out. Same as there's no replication of, you know, coming into a ball either in the globe model. But you can replicate the gradient, the vertical, meaning down and up actually are, they mean something. They're not all just random relative things. They actually are permanent physical.
Eu gosto de lasanha de micro-ondas. Micro-ondas? What is micro-ondas? Micro-ondas. Anyway, these people are just let me involve what's his name? This guy. Totoro. Wait, what just happened? Has anything changed? Let me see. Invite, copy, hide, mute. It's. I think it's a dead end. I mean, this server. I'm never going to survive on this server. Microwaves. Oh, ondas. Micro-ondas. Wow. Whoa.
Vacuum, I think it becomes ineffective. At least that's the stuff. That's what I looked up and found out, is that it doesn't seem to work in a vacuum very well. And yet we can pull
Yeah.
a vacuum and drop things just fine as if it's the same. So
Yeah, but were you assuming that I was saying that it was electrostatics just because I said the term Gaussian surface? 'Cause I did use that term, which does.
Anyway, why, wow, hello. Interessante como a linguagem funciona. Funcionam. Sim. Traços de linguagem. Traços, don't remember what is traços. Traços. What is traços? Traços. Okay, I gotta go study something. Let's go study something, because traces. Oh. All right. Let's continue with our lives, because we need to continue with our lives. Okay, I think we need to study some physics. We don't have a choice, as difficult as it is. And it's not that difficult. So we were here. No, we weren't. Where were we?
dx2 squared equal to dx plus dy.
Yeah, we were basically here. And so I came to the conclusion that he doesn't know these steps, because he usually does not skip steps, and he doesn't draw incorrectly. And in this case, where is his drawing? The 3D drawing. This is everything he did here is with mistakes. This is incorrect. The Y direction is incorrect. And then he didn't finish that, and he went to this, which is okay. And he didn't describe anything. And then he went to 2 dimensions, which is that doesn't make any sense. We don't need an explanation in 2 dimensions. And then this is a partial derivative, right? The derivative in the x direction. With respect to what? I mean, his notations are I'm not. I think that you can say phi x. You can't say d phi x. There's no such thing as d phi x. There's phi x, which means the derivative of phi in the x direction, a partial derivative of phi in the x direction. There's no d phi x. There's no such notation. Let me look up all the notations of partial derivatives. Partial derivative notation. There's a bunch of ways. You see, fx is df dx. You see, I told you, he got it wrong. You can't say dfx. There's no such thing. It doesn't make any sense. So he's making so many mistakes. That's an indication that his brain is not functioning because he doesn't know these steps. I'm not judging. I'm just saying. Just saying, as they say. Just saying. This is the first partial derivative. A mixed partial derivative. Second partial. Second partial. Mixed. Right, this is the same. This is fxy. This is fyx. So no wonder I got lost at this point, because he's lost at this point, and everybody gets lost in this point. Lenny Susskind got lost at this point. Lenny Susskind was all over the place with the full derivative and the partial derivative. They don't know what they're doing. They're completely confused with the math. They don't understand the math at this point, which is very simple. There's nothing complicated. This is just basically, you're taking a path on the top of a terrain. At the top of the topology, you have a path. It's a path in a topology. It's very simple to understand what it is geometrically, but they're having a hard time understanding it with mathematical notations. This makes no sense. This thing makes zero sense. This is completely incorrect. This is like write your name with 7 mistakes. Like try to spell your name while making 7 mistakes. Like nothing here makes sense. These dx's cancel out. So what you're saying is d phi x is d phi. That doesn't make any sense. And you can't tell me, well, this dx and this dx are different. Well, then if they're different, how are they different? Well, of course they are different, but I don't know. But you don't know. From here, you don't know. And this thing is completely messed up. I don't know where to begin explaining how many mistakes this guy is making. He's all over the place. And this is just 17 minutes in, and it all started here. His mistakes started here. Right before this, he was okay. I guess he didn't say anything before this. So as soon as he starts with the terrain. Okay, looks good. Looks like we're gonna, right? This makes perfect sense. No problem. And here is the problem. What is this? You already said this. This is phi. So what is this? Well, this is also y. All right, that doesn't make any sense. That doesn't make, and now you're saying that this hill, what I can't imagine this xy. Where is this xy and where is phi in this discussion? What is going on here? Who can understand this? This is a complete Looney Tune. This is complete nonsense. This is the most. What the heck is going on? This is like, what's going on? What is going on? See, the problem with the internet is forever. So this guy made a course 11 years ago, and his mistakes are going to be here forever until he takes this course down, which I'm assuming at one point he will, because it's too embarrassing, I think. Are they still, they still have me locked out. So, and no one is speaking on the server. Anyway. But this is absolutely incredible. This is absolutely incredible. Because I was getting lost in Lenny Susskind's course just at this point. It's like, you guys don't know the fundamentals. You guys don't know what you're doing, do you? What the heck is, what is this? It's such a simple thing. What you want to do is you want to have it. This is the XY plane. And this is the phi topology as defined for every independent coordinate. The X is independent. The Y is independent. That means you're free to define any X, and for any X, any Y. Pick an X and right, pick any X, and for that pick any Y, and you get a point. And for that point, there is a topology function phi that defines the height, the manifold. The phi is just the 3D manifold. It's defined over the X, Y, and the XY, not the XY plane, but it's defined. I guess it's a function of X and Y, independent X and Y. Okay, that's this. This is incorrect. So what you have to fix it. The Y has to be in this direction. I mean, I want to fix it so much. The Y has to be in this direction. But the Y should be here. This is the Y coordinate. This is X, Y, and phi. But phi is just Z. You can call it Z. You don't have to call it phi. You can call it phi. You can call it Z, whatever. Okay. So you want to define a location. This is the X. And this is, and parallel to this, you want to define here is Y. So this is Y, and this is X. And at X, Y, no, that's not true. I mean, if you want to say that there's a hill, then you have to define X and Y over here somewhere. So you would say X and Y. So for this point, the phi is this height. You could say the phi is this height, for example. That's what you want to say. Okay.
And that
I don't want to listen to what he says. It's not important. And here is the hill that we just discussed. So what he says is the hill. So we need to complete this line. Fine. And then he says, I can travel in, basically, I can travel in this direction, which is, I mean, irrelevant of this discussion. You could say maybe that this is the Y. I don't know what direction this is, but you can walk in this direction and you can walk in this direction. So in this direction, there's no, let's say this is just an arbitrary direction. You can walk in this arbitrary direction and you would very quickly realize it's a steep downhill, or you can walk in this direction and you would recognize that you're maintaining the height. Okay, so it depending on the direction you choose, the direction you choose to walk from any point, you're going to experience a different gradient. Okay. And this is a, I guess, a one-dimensional gradient, right? This is only, or two-dimensional gradient. There's, I mean, this is x and phi. I don't know why he's going to like x, see x and phi. Okay, so that's fine. D phi is equal to d phi dx. No, that's obviously nonsense. This is saying that d phi equals d phi. So this makes no sense. What do you want to say? I don't know what you want to say. Either say that phi or delta phi, delta x, and this is d phi dx. I mean, otherwise, what you're saying here is d phi equals d phi. You're not expressing anything. So d phi equals 1 over 10. Okay, that's the slope, and you multiply by 5. But 5 is not an infinitesimal amount. This is not what you're trying to say. Your answer is a non-infinitesimal amount. That's not a d phi. D phi goes to 0 by definition. So this this is, you're not abiding by the rules of math. Math has some rules. You might as well say that 2 equals 1 at this point. There are rules. D phi is an infinitesimal amount. You can't assign an actual value to d phi. And dx is 5. You can't, no, you could say it's delta. This is delta phi. This is d phi dx. That's fine, but this is delta. This is not. Anyway. And then what's the next thing? Now the next mistake. So d phi x, there's no such notation. Does not exist. I don't know what you mean to say here. I don't know what you mean to say. Because this is the partial. What you want to say is the partial of phi with respect to the partial of x. Okay, that's right. The partial of phi at some point xy. This is not just the partial of phi. So you take some point, right? That point that he mentioned before. I'm so bothered that they're allowed to attack me non-stop for days, and I just mention, I didn't even say you're so gay, or like you're upset that you're gay. I understand that you're upset that you're gay. You're upset that you're gay. That's my opinion. I'm not shaming you for being gay. The problem with the server is they're gonna get my account banned. They're gonna report me for attacking them for being gay. See, they're a protected group, so I'm better off staying away from these people. These people are very dangerous. They're not playing games. They will take down my server. That's the next thing. This is very dangerous. These people are very dangerous. They're not playing games. These people are not playing games. I need to be very careful with my next steps on Discord. Because they'll come after me, they'll come after my channel, they'll try to destroy me to Kingdom Come. So I have to be very, very careful with these people. Very careful. They're very dangerous. These are very dangerous people. Terrifying. Absolutely terrifying. See, you think you're going to study physics and you're going to spread the truth of physics. No, no, no. That's not how it's going to work. They will destroy you. Period. They will destroy you. Physics is just a tool for them. They use physics to destroy people. You cross their path incorrectly, they will destroy you. So you better watch out. Yeah, these people are terrible. Yeah. You see what they did to me in my first few days with them. Oh, timed out. You cannot chat, reply, react, or join 37 minutes. Channels during timeout. Timeout. You received a timeout in Globe Gangsters. Oh, interesting. Very interesting. Very interesting. Timeout. Wow. Very interesting. 37 minutes. So probably 1 hour. Very interesting. Very interesting. Let me just tell him, just so that, for the record, I did not say anything as a pejorative. Pejorative? How do you spell pejorative? Pejorative as a pejorative? If you took it as one, then that's a you problem. If you took it as an offense, then I'm sorry. That is not where it came from. I was just noting that he was being very rude, and I assumed, and I am developing a new theory that people who are so rude to me are so because of... Wait, what just happened? Oh, he's gone. He left. Let me try and... Don't forget Totoro is butthurt because I mopped the floor with his face. So my whole... let me see if it still remembers what I typed. So everything I wrote was forgotten. By the way, I did not mean to offend anyone. I did not use that term as a pejorative. I actually feel that people of that persuasion have something against people of my persuasion. That is just how I feel. I'm sorry if I hurt your feelings, but it did not come from any negative emotion. And you people have been abusing me for days. This guy specifically has been extremely abusive towards me for days. I just said something that I actually feel might be true, and your reaction is anyway. I don't want to say anything. It's better to slip under the radar. I'm just gonna lay low. So you shouldn't go to war. The only time to go to war is if you're sure you're gonna win. So I'm not gonna go to war. I'm not gonna react. I don't care. I'm not gonna be afraid. I'm not gonna worry that they destroy me. I don't care. It's fine. They want to destroy me. That's fine. I don't care. That's life. I'll continue. I'll go on living, and I'll continue enjoying my life. It's fine. Just remember what they did to what was the guy that they burned at the stake? Giovanni Geruno or something. And the fact that what they did to Galileo. So always remember, they're dangerous. Just stay low. It's not fair, but that's life. Life is not. It's not going to become fair today.
Vanishes.
Yeah, basically.
That's pretty wild.
Yeah, it's
Like
fun.
what?
to think
Like,
about.
have you heard the idea? Also, at the North Pole, there's like a huge maelstrom, like a huge vortex of some sort.
Yeah,
It may be like where the four rivers meet. If there is like, in terms of those Mercator maps, if they were accurate, like these talks about these 4 islands and 4 rivers, which would also make sense with the tide. That would play into the tide system and all the continents coming out in the different directions. But if all those rivers are going to something in the center, what is that going to? So yeah, and then what kind of vortex would that be? So this is pretty wild. But if you like, let's say with that type of idea.
All right, let's continue. This is fascinating. So he is completely wrong. I mean, if you need to confirm that he's wrong, just look at his notation. Look at what cancels out. I mean, dx is cancel out, and you're left with d phi x is equal to d phi, which is nonsense. There is no notation d phi x. There's no such thing. There's phi x or d phi dx, partial d phi dx. There's many notations. You can't say. I mean, you could theoretically take this mix notations. I think you're allowed to mix notations, but this already means d phi dx. But this is partial d phi dx. Now, It doesn't make any sense. So the d phi, this is d phi dx. So this would be the second derivative. This is the second derivative of d phi dx. And it's equal to the first derivative. But this is a full derivative. This is a partial derivative. This is a mixed partial full. I don't know. This means nothing. This is really, I'll tell you what he means to say. Okay, what does he mean to say? So what he means to say is, I think, let's see, let me think. I need to think. What does he mean to say? Jesus. Let me look back. Okay. So he did this, right? D phi dx and d phi dx. Okay. So what does he mean to say? He means that okay, remove this little x. So big d phi dx no, it's not equal to little d phi dx because, okay, look, there's two separate x's in this story. There is d phi dx, which is a partial d phi dx, which means x is independent variable. What is he trying to say? I'm honest, I'm trying to think. What is he trying to say? This is the d phi at some xy, independent xy, there is a gradient d phi in the direction of x. So this is the gradient in the direction of x of the topology of phi at xy, some xy, as he drew it. There's some gradient, and he's trying to walk a path. I don't think he already mentioned the direction, the directionality. Did he already? I think that, yeah, the next thing, this is so confusing. The next thing is to define this path. So I don't think he's saying anything. All he's saying is that there is a partial d phi, this is incorrect. There's just a partial d phi dx, which is just this. There is a partial d phi dx and a partial d phi dy that are based on independent x and y for all x and all y. That's all. There's some gradient in the x direction and the y direction of the phi topology function, which is also the z. There's no difference. That's one thing. The next thing he's going to do is define a vector. This is in xy. He's going to define a vector. He's going to project it, project the xy, right? The xy vector, project it onto the topology and say, okay, tell me the gradient in this direction. There's an xy, an arbitrary x and y direction. Tell me the topology. Given at that point, this point is xy, independent xy, some xy, right? This is xy are independent. There is a point xy that has a vector with value xy, some other xy. This is x1, y1, and this is point x2, y2. So this vector, what I call it S, call it R, whatever. So there is a vector, but it's in the xy plane. Now project it in your mind onto the topology, onto the phi function at xy, and tell me what is the gradient in this direction. Okay, so the gradient in this arbitrary direction, well, this vector, it's right to walk, right? Imagine you're walking at delta S. So this is delta S. And basically you're walking delta Y. So let's walk first delta X and delta Y. So as you walk along delta X, you're going to use the partial d phi dx times this dx. Now this dx has to do with this vector. So this is not the same dx as this dx. This is there is a dx that is a function of this vector, right? There is a dx and a dy, but if you change this to here, it's going to be a little different. It's going to be different dx and dy. So you want to take this dx and multiply it by the phi dx at that point to know the change of phi along this dx. And then you take this dy, which is, it's very confusing because it's the same x and y, but and it's dx and dy keep coming up again and again. But this is the partial dx that has to do with the independent variable. This dx dy are not independent. They depend on this s vector. This s vector gives us a dependent dx and dy. Anyway, that's the question. And he completely botched it up. So the x and dy is very nice. And then he said, well, this makes more sense. Now, this is correct. This is dx and this is dy. They're not partial because there is no function. We're not taking derivatives with respect to, there's no partial x and partial y in this story, not for now. Okay, and then what's the next step? Now he's saying ds squared is dx squared plus dy squared. And the vector ds is equal to dx plus dy. That's another notation. This is the size. This is correct, and this is correct. What this says is the vector, that these are vectors. That's fine. And what this says is just the scalars, just the sizes of the vectors. This is also correct. Now, again, he's going back to his incorrect notation. And he's saying that, so this is the partial of phi with respect to s. But what is s? S is not some variable. But what he wants to say is defy ds. I think you're allowed to say defy ds. Right now in your mind there is a ds, which is, this is ds, this is ds. So in our minds there is a ds and there is a defy ds. So in our minds, right, this is just a story. Mathematics is just a shorthand for a story about something else. It could be about a real life experience, or it could be about some geometry. So in this case, it's about a geometry. This is a shorthand of this geometry. So what is he trying to say here? He's trying to say that, right, let's walk in the xy plane along ds. But this is xy. You see, another mistake he made is he didn't say that this is x and this is y. It's right. It's impossible to know. But right, it says here dy and dx. So this is x and this is y. That's fine. And there is a phi that comes out of the screen. It's basically z. So as you're walking along ds, there is a phi that comes out of the screen. That as you're walking along ds, you're actually walking along phi or d phi. You're because let's say you can only walk on top of the hill. As far as your GPS, imagine GPS. As far as your GPS core, but GPS is three-dimensional. But let's say you only had a two-dimensional GPS, x and y. As far as your x and y is concerned, you're walking ds, which is dx and dy. But the only way you can traverse the x and dy is on the topology, on the mountain. You cannot walk inside the mountain at sea level, you can only walk on top of the topology. Let's say it's the Mount Everest topology. So as you're walking along the X, you're walking along Everest, which could be a mile high. This delta X could be huge. Well, it could never be a mile. It's always, everything here is infinitesimal, but it could be 1,000 times this dx. It could, right? There is a ratio. It could be that it's a ratio of 1,000 to 1. It could be a very, very, very steep wall that is 1,000 to 1. For every 1 meter, it goes up 1,000 meters along the dx. And maybe it's going down along the dy. 1 meter is 1,000 meters going down. This is some pinnacle. It could be. And when you travel ds, actually, the topology didn't change. Maybe so it could be such a strange case. But it's 1 meter along the x, it's 1 meter along the y. Let's see what's going on. How much more time? 17 more minutes. My God, they keep talking about the flat earth and the flat earth, and there's only one person on the server. There's going to be no one there, and I'm still blocked.
It's, something of a more luminous nature of topography. Either way, there does seem to be that topographical look to it in terms of the kind of shadow effect, and then what they call craters. But whatever that is, which there's a whole nother thing, which is called being a sacrificial anode, which is when you have an anode and a cathode, there's a type that's called a sacrificial anode, and actually pulls, it'll pull zinc and out of the material, and it looks like craters. So there's even a deeper thing that the sun and the moon could actually be in that type of engagement with the anode and cathode, and the moon is actually shaped because of the interaction with the sun. But and electrical arcing between the sun and the moon, perhaps during eclipses, that actually create that effect.
Yeah, very, very interesting. So, all right. So dx and dy are along the plane. But there is a d phi along the x, and there is a d phi along the dy. And there is a d phi along the ds, which is the combination, which is fine. So this is the relationship for the squares of the ds, for the vectors of the ds, and what's this? So this says that, now this goes to d phi. So this is d phi along the s. This is what, so he's not using the normal notation. What he's saying is d phi along the s. I'm just thinking, can you say that? I mean, there's standard notations. D phi along the s is equal to d phi along the x and d phi along the y. So the way to express this is, I mean, this is not normal. No one talks this way. No one writes math this way. So you should say that, well, you can't say, I don't know if you can say d phi ds. There's no s. I don't know what it would. You could say, because s, well, you didn't define s. What is s? So you could say that there is a path s that is a function of x and y, but not independent x and y, but rather x of t and y of t. So there, this is what's implied, that is the definition of a path. He never mentioned the path. I mean, he mentions it in passing, but there is a path in this discussion that is the s, not ds, the s. So S is a path. I mean, he never defined what is S and what's going on. So S is a function of X and Y, but X and Y are not independent. You can only plug in certain X's and Y's that are both dependent on some variable T. So for every T, there is one X and one Y that go together for that T. And for that X and that Y, when you plug them into the S or into the function S, you get a value S. Which is what? No, S is the function. S is a function. I need a pad. I need to write these things on a pad. Otherwise, I'm going to lose my mind. So S is a function of Y of T and X of T. For every T, you plug in T equals 1, T equals 2, T equals T. For every T, you have a function X. You get some value of X and some value of Y. Let's say for T equals 0, X equals 5, Y equals 17. So 5 and 17, that's a point. That's a point. So that's already S. So S is the collection of points such that it's composed of the X of T and Y of T for all T's. And you need to define this thing. So S is a path that is defined by, for each T, you have a function that gives you the value of X. So X equals X of T and Y equals Y of T. And those XYs, X of T, Y of T, for every T gives you an S, which is just a coordinate. S is just a collection of coordinates. X, Y, X, Y. For every T, you get an XY. T equals 1, you have one XY. T equals 2, you have another XY. T equals 3, you have another XY. And you have, so you get a path in the XY plane. You call that path S. That's the path S. So the path S, what about it? So you're saying as you walk along S, as you take a DS, as you take a DS, so defy DS, right? DS is in the XY plane, but you can project it to the topology, to the mountain. And now the difference in the mountain, in the terrain of the mountain, the height, and the function phi along ds is d phi ds. Now, is it partial d phi dx, or is it... So d phi ds, I wouldn't say is partial. Maybe it is. I don't know. D phi, so d phi is defined for x and y. S is defined also for a different set of, for, it sounds the same, x and y as well, but not independent x and y. But S is defined as a bunch of x and y coordinates. Anyway, he skipped like so much, and now I have to do so much completion. What he wants to say is, let's just say delta. We might as well use the delta notation. Delta phi delta s. By how much phi changes when we walk along delta s? Well, that's just delta phi delta x. If we walk, but this is the x of the s. This is not the x from before. This is not an independent x. You cannot, right? This is the x. This is the delta x that makes up that specific delta s. And this is delta phi delta y. By how much? This is the question. By how much does phi change as we walk along delta y at that particular point, x and y, that make up that point, S. I don't care what he says. So the next step is, so this was this. So now he says, so delta phi delta S is equal to partial delta phi delta S, delta x times dx. So this is, okay. Okay, so this is the partial, and I think the next line is the correct expression. Let's see. So d phi dx, this is the partial x, the independent x. Phi depends on x independently, an independent x, and phi depends on y independently for every, but this is in the y direction, in the x direction, at the point x and y, independent point x and y. Right? So the question is, the function phi at x and y, some x and y, independent, give me any x, any y, pick an x and y, okay? Yeah. So the phi at that point, what about it? By how much does it change that function at that point, meaning that height, that location? So phi at x and y, by how much does the height change as we walk along delta S? So I would say delta phi as a function of x and y divided by delta S d phi ds, delta phi delta S is equal to partial d phi dx, the gradient of the topology. Notice that this is a topology, right? Right, we're asking by how much does the topology change as we walk along delta S? Okay, it's a good question. The answer is, well, by how much does the topology change in the x direction? Multiply that by how much you walked. This is delta x. Delta x, which is a function of this delta S. I would say that this is delta phi delta S, and this is partial d phi dx times delta x. But delta x, that makes up delta S. So how could we ask, I mean, so this is delta x and this is delta y, this is fine. But the question is, what is this? This is by how much this changes as we walk along delta S. So this is d phi times delta S. This is what we're looking for. There's nothing, I mean, you can call this whatever you want. What are we looking for? We're looking for by how much phi changes when we walk along the S direction. But what is this S direction? What do we mean mathematically by S direction? How are we expressing this? Well, just call this X, Y, Z, call this A. This is the gradient in an arbitrary direction. Well, what is the name? The gradient in an arbitrary direction. Okay, got it. This is d phi ds. This is d phi ds. This is the derivative d phi ds. Now, this is a real number. This is not an infinitesimal, but this is infinitesimal. So this must be infinitesimal. Defy ds is not infinitesimal. Defy, you can't say defy divided by ds. You can't say, because defy divided by ds is a real number. It's not infinitesimal. It's a ratio of two infinitesimals. That's not an infinitesimal. It's some value. So defy, what would you call it? Defy, what would you call? Well, it's defy, that's for sure. It's defy, you can't say divided by ds. And you can't say defy multiplied by ds because that would be two infinitesimals. And here you only have one infinitesimal. So you'd be losing, it wouldn't make any sense. You're saying that an infinitesimal squared is equal to an infinitesimal. That's not possible. And we'll have to look at this again. La 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 la. Oh, it's still locked. 2 minutes. Yeah, I have to be very careful with these people. These people are not taking prisoners. They will destroy me.
Even the stars seem to, like, if the testimony is true that when you go up to a certain elevation or altitude that you can't see them anymore. You can only see them from a certain angle. That kind of leads to the idea that
into Jeremy's thing. That plays into the thing Jeremy was saying, where like those things when you're a kid, when you look at it at one angle and you see a dinosaur, and then you look another angle and you see a rabbit or whatever.
See, if you call a normal guy by that word, the G word, they don't get upset. Like, you call me the G word, I could care less. But you call them the G word, Jesus. They will come to get you. Oh my God, they will come to get you. Don't worry about it. Don't you worry about it. They will come to get you. I need to stay off this topic. This topic, they will destroy me.
Freely in space and can be seen, like the whole of it can be seen from any angle, but then every angle, like every part of it that makes it up contains the whole and the part simultaneously. So like the idea of stars, or even like the idea of the moon, like for example, the whole and the part. Here's an example of that with the moon, let's say. So with the female reproductive cycle, it seems connected to that lunar cycle. So it's like the whole and the part, like in that sense, where like the moon is the one, there's the one moon, but then all these different women, their cycles are all synced up with that, you know, with the moon in different ways. Now, sometimes I know they can be off in the modern era due to various different things, but nonetheless, the cycle is still the same as the lunar cycle, even if the woman is not quite with like new moon, full moon every time she has her period, like that part could be off, but it still is in the sync with that. So that's just like an example of a luminary that would have like a holographic quality in that sense of it, where the whole of the moon and the cycle of it, you know, seems to be contained in all of the parts because the women are in that cycle of the whole. They're all contained within it, and then all of those parts are also contained within the whole.
I sort of got it right. I think I got that from. You ever read that book, The Holographic Universe? It was pretty popular, maybe in the 90s.
Was that Michael Talbot?
My God. Okay, so what does this mean? I need. Well, this is. It's just defy. It's just defy. That's all it is. You could say that it's d phi in the direction of S. But why not say d phi ds and this would be ds dx? By how much does S change along the x? That doesn't make any sense. Does S change? ds dx, dx dt? I mean, I need him to teach me, and instead I have to teach him. What a disaster. Okay, this is where I stopped, basically. This is where... Okay, but basically what he's saying is, this is just a small question, right? We're walking dx as a function of s, right? There's a ds. This is the dx that makes up the ds, and this is the dy that makes up the ds. So we're walking along an arbitrary direction s, therefore it's the dx and dy that make up the ds. And at that point, there is some slope in the direction of x, some slope in the direction of y. So the total change in height that we'll experience while walking along the x direction, the y direction, that make up an arbitrary s direction is, well, what's the slope in the x times that ratio. This is a ratio relative to s or relative to y, right? These two numbers, dy and dx, they're important. There's a ratio between them. And that ratio defines the direction s. If dy is big and dx is small, let's say dx is close to 0 and dy is 1,000,000. So it's basically along the y direction. Right? So this is going to be very heavy. Whatever the slope, the slope in the y of phi in the y direction will dominate, and so on. Okay.
Derivative with respect to x, there are other derivatives. In this case, a derivative in respect to y. It's not the only derivative, so it's called a partial derivative, and it's indicated as a partial derivative by virtue of having a curly d. Now I want to pause for a while I do a nomenclature change, and I promise you it won't hurt. Up to now, I have been using the coordinates x and y. I am now going to change them. Wherever I have used x before, I'm going to call that x1. And wherever I have used y before, I'm going to call that x2. Why do I do that? Well, for 3 dimensions in space, we typically use x, y, and z as our coordinates. Suppose I needed another coordinate. What letter am I going to use? There isn't one after z. I could, of course, find another spare letter, but letters of the alphabet tend to be used for different purposes in physics, and it becomes very confusing. Whereas if I relabel these x1, x2, and x3, if I need another coordinate, it's a piece of cake. It's x4. Indeed, I can even have an x0, which I will actually use for a time coordinate. If I need further dimensions of space, I can have x4, x5, x6, and so on. There's no limit. So firstly, changing the coordinates into this system means I've got an unlimited number of coordinates if I need them, or dimensions of space. And secondly, it releases the y system, which I'm going to use for a different purpose a bit later on. So now I'm going to rewrite this equation here in my new coordinates, simply replacing x by x1 and y by x2. They're exactly the same, I just called them by different names. So if I do that, I will get that d phi, which is the overall change in height as far as my field is concerned, is going to be equal to the gradient, which is d phi by dx, and now that's dx1, times the distance I move, dx1, plus the gradient in the y direction, which is now the dx2 direction, times the distance I move in the x2 direction. And of course, I could add further terms, x3, x4, x5, as many as I need. I'm only going to work in 2 dimensions to keep it simple. And I think you'll see that this equation here can be simplified by saying that d phi is equal to the sum over n of the gradient d phi by the xn multiplied by the xn. When n is 1, you get that term there. When n is 2, you get this term here. And the sum term means you just add them together. So this is a very handy way of summarizing the change in the value of field according to all of these values. And you'll notice that n is the summation term.
What is important to remember is the story. The notation is very nice and everything is very nice, but there is a story behind this notation. There is a topology phi that is defined for all x's, for all partial x's, meaning all independent x's, x1, x2, x3, x4, for all x's, phi is defined independently. You can pick any one of these dimensions, any value, there is phi defined for that. That's one thing. But the question is, what we want to walk along a specific direction. And that direction is not mentioned here. It's the ratio between these dx's. So right, as we said before, that right, the second dimension, the dx2 compared to dx1. Dx2 could be 1,000,000. Dx1 could be 0. Let's say we're not walking along dx1. We're only walking along dx2. So dx1 is 0, dx2 is 1,000,000, or dx2 is 1. It doesn't matter. In that case, the dx1 will be 0, so the derivative along x1 direction will not matter. We will ignore it. And the value d phi will be dominated by the d phi in the dx2 direction, if the dx1 is 0. If this dx1 is 0. So this x defines basically a path, and there's no way around it. This is a path, and dx is a vector along the path, which is what a tangent is, right? We know that this is a derivative. A derivative is the slope at that point, which is just the direction, right? This is the direction of the path. Right, so we want to know by how much does the topology change. This is the curvature. I guess it's going to be the curvature of space-time. So the curvature of space-time, what is the curvature of space-time given a certain curvature of space-time? What is the curvature of space-time given a path in space-time or a vector at a location in space-time? So given a specific location and direction, what is the total curvature of space-time? Right? This is phi is the topology itself. Whoa, gamma, no hack.
Well, if it isn't Mr. Slave.
Welly, welly, welly. Did you see the movie? Welly, 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 welly.
No, where are you from?
If it isn't with Alex, I don't discuss any personal information.
All right. How about I tell you where I'm from, and then you can say where you're from.
I'm not going to say where I'm from. This is on a recorded call. We're being recorded.
Oh, okay.
This is transmitted in real time to all my followers.
You're obviously from Europe.
Let's not talk about it, please. It's recorded. I don't want to have to nuke this live.
Yeah.
How long?
Have you edited your paper yet?
No, I have not.
So you haven't.
Mhm.
You haven't made a new one or anything?
It's fixed. I mean, I was able to clean up all the noise that you people made. Did you make the noise? Was it you?
The noise?
The mess. The caca.
Oh, I mean, I was a part of it, but
it's fine.
I didn't add images.
It's fine. It's no big deal. I don't care. Look, I have to tell you. I mean, you guys are the most violent server there is in the world, and I think the reason is because you're all gay. I don't mean to hurt,
Really?
and I don't say that to hurt anyone's feelings, because I realize that it might be painful for you guys to hear or something. But I've never had such a terrible, painful couple of days in my life.
Really? We were that bad.
You are bad beyond bad. There's no words. I've been through bad. Trust me.
Wow.
Yeah, you guys are.
Was it traumatic? Is it
Yeah.
traumatic?
Yeah. This is. I mean, a normal person would have would have been like, it would have really hurt a normal person. This is. I was just listening today to why communism always kills millions of people. And then at one point they said that in Cambodia, they used to take, or in China, in Mao's China, I don't remember which, they used to have these sessions that they used to take a person and just yell at them and mock them for hours or days, just ridicule them in public for no reason. Like they would never know why did they do this to me. And this is basically what this server is. I mean, to me, I walk into the server and I get attacked. I walk back into the server, get attacked and banned and silenced. I go to other servers.
You were banned from Globe Gangsters?
I was banned for the past hour, and I was silenced multiple times and attacked endlessly. And there's certain people that are always very, very abusive.
You're Israeli.
No. I'm
That's yes.
I'm anti.
Why are you sighing? You're like, I'm anti.
I
We're gonna hear a rocket explode over your house, and that's gonna confirm my suspicion.
Yeah. Anyway, look, the point is that so my theory, so the only parameter in the equation that I can assign to this bizarre behavior is the way you are. There's something about you people that makes you so violent against,
We weren't violent.
You're out of your mind. You don't, like, if that is not violence, then fine, right? Then let's redefine every word in the dictionary while we're at it. Of course, look, you can say that's not violence. You can say whatever you want. You can say whatever. You can say 1 + 1 is 17.5 times 2. And it's 1 and it's 2 and there's no contradiction. And there is a contradiction, but it's not a contradiction. You can say whatever you want. I can't stop you. Or you can listen to what I'm telling you. You people inflict pain on me. And I don't know why. I'm here.
What did we do to you?
What are you talking about? For example, you denying that what I've been through is violent. That is violent.
What? Okay. All right.
Maybe you weren't there. I don't know.
I was there for the editing spree, but
that was funny. The first day was funny. The second day, I was worried that this fun at one point will become violent. I had this premonition. I said, something tells me this is going to turn. This is going to go very bad. I had this premonition. I said, I've never had so much fun. This doesn't make any sense. This is unstable. This is not maintainable. This will blow up. And I was, and I forgot about it. I forgot about my this intuition. And it got worse very quickly. It got terrible. and impossible, and just violent. And I look, for days I was trying to just talk about my physics, and all you people talked about was how terrible of a person I am. Look, there was one person, his name is Disinformation something. I mean, listen to how there's recordings, listen to how he talks to me. And he's always defended. It's like I'm always telling him, please stop, please stop. He's always defended by the group. So he's attacking me. Everyone is defending him. No one is asking him to relent, to, stop the attack. There's no reason to attack me. I'm never attacking anyone. I'm not here. This is not my business to attack anyone. I'm here for physics. I'm studying GR right now. That's what I'm doing. And, I'm here for the physics. I have an interesting physics theory. I could care less for anything else. I mean, I want to make good content, but anyway. So, and then there is Totoro.
Totoro is helpful.
Totoro is violent towards me. I had a debate with
Totoro. Violent towards you, Mr. Slave?
Well, right now you're nice. Look, one-on-one you're all nice. But in a group, you don't notice maybe how together, I don't know, but some of you are vile. Some of you are like I don't know what to say. If the word evil doesn't apply, then the word evil might as well not exist. You're evil. You're just evil. You're just evil people. I mean, you do nothing but try to inflict pain. You don't take a breather. You don't take a break. I came.
What can I do to make it up to you, Mr. Slave?
No, I don't need you to make up. I just need you to realize how I feel, that I'm here for physics, and I keep getting attacked. What's the point? Tell me the point. It's like one of those people that went through these communist accusation hours that they never knew why. No one told them why.
Let's talk about physics.
Oh, you know physics?
Newtonian, I guess. I don't know if GR or SR, but
so what's the point? Do you know quantum mechanics?
No, of course not.
Do you want me to teach you SR, GR, QM, QFT? Do you have questions? Do you care?
I want to talk about the derivation of 11 kilometer per second ether flow.
That's very simple.
Can you show me how you derived it?
Sure. Well, first I'll tell you the story. So, assuming Newtonian F equals ma and F equals gmm over r squared. So, you're fine with these two assumptions?
Yep.
Okay, so let's combine them. Right? We basically have, let's describe the problem. The problem is I want to have a test particle at infinity. I want to let go of this test particle at infinity. And I expect it to immediately start accelerating towards Earth. Let's say there's only Earth in the universe and this test particle. And I'm wondering, if I put it at infinity and let it go, then it's going to start drifting. We'll look at the equations, but we'll see. But I assume it's going to start drifting because gravity extends to infinity. So it's going to start drifting in the beginning very slowly, but then it's going to pick up pace. At the end, it's going to smash against the surface of the Earth. And I'm wondering at what velocity will it smash against the surface of the Earth? Now, this is actually similar to a black hole. In a black hole, we assume that velocity will be the speed of light. You could set the velocity to the speed of light and then ask what is the mass, or what should be the mass, or what, given the mass, what should be the radius, and you would get the Schwarzschild radius, which proves you don't need Schwarzschild, you don't need Einstein, you don't need GR for a black hole. But that's a different story. So, but that is what we're trying to answer. We're trying to answer if we take a test particle, and by the way, the test particle doesn't need to have mass, because according to Newton, F equals ma, which equals to gmm of r squared, the little m's cancel out. So it's A equals gm over r squared. That the test particle, which is massless, that we place at infinity, will accelerate regardless of its mass. What?
You need to take into account. You still do need to take into account the object. Like, I don't know why you're doing all this canceling out. What you could do is take the mass of the particle, take the mass of the Earth, the distance, and then just do time steps and update the force over time and update the acceleration over time, starting at an initial position, and then you would get a final velocity. Final velocity in theory would be infinite if you're doing Newtonian, and final velocity Einsteinian would be basically c.
I didn't get any of that. Wait, what do you mean you don't have to? What I said, the m's cancel out. It's not whether I like it or not. The m's cancel out. What do you mean you don't have to cancel them out? They cancel out whether I like it or not. I don't have a choice in the matter. Here, let's open a Blackboard. Okay, let me do a new one. So this is going to be the 11 meters per second derivation. Okay. Let me close this. What just happened? Let's try this again. Yeah, much better. Oh, got it. Okay, so how do we derive 11 meters per second? So F equals, can you see what I'm writing?
I'm going to it now. Yeah.
Okay. And F, this is F acceleration. This is Newton's second law. F acceleration. Can you see me?
Yep.
Okay. Let me try write acceleration. Looks like a 9. Like it's hopeless to write a little a. Let me try. Okay. And F due to gravity, the force of gravity. This is the force that will cause acceleration. Whatever force I apply to a mass will give me this acceleration. Okay. And the force of gravity is, it's actually negative, capital G, capital M, little m, test particle, over r squared, the distance between them squared. Okay. So if we take a test particle and we want whatever will cause the acceleration is the force of gravity, something like that. So ma, that force which causes acceleration, is negative g m over r squared. So what are we saying here? We're saying that there's two bodies, capital M and little m. There's a difference r squared between them, but big M is huge, so it's not moving anywhere. So the ma, the acceleration of the little mass, well, obviously it's due to this force. So this is the force, basically, that will cause this acceleration, right? Make sense?
What? So if you're, hold on, let's see. if you are you saying that when you cancel M and the M and the term that you have this term here.
I didn't cancel yet. I'm just this is F equals ma. So I have the force of gravity, the Newtonian universal force of gravity.
Yep.
And I'm applying it to a mass, and I expect to get an acceleration. And as we know, you take a test mass, you take a 1 kilo object, and you let it go, and you let it fall. Well, force of gravity will act on it and will cause it to accelerate. Actually, it will accelerate, we know at what? At g at the surface of the Earth. At r equals 6,000, I think 6,000 is the radius of the Earth. So it's if you plug in 6,000, you get g equals about 10. If you were to take the numbers. But so far so good, more or less. Are you comfortable? Look, all I'm saying is I have a big.
Do the part where you cancel it out. Get to that part.
So the canceling out. Well, this and this cancel out.
Yep.
Now you could say that that's illegal because m might be 0, and this is division by 0.
No. I have a better explanation.
Mm-hmm.
So this is what you're saying. Oh Jesus, that's a horrible I.
Yeah.
Equals negative g over 6,371 in the case of the Earth. And then 1, let's say, is 1 kilogram.
No, this is the mass of the Earth. This is big M.
Test particle. Yeah. You're ignoring that. Yep. Would that be? Is that true? Squared. Yeah.
But you have to plug in actual g, and you have to plug in the mass of the Earth. But this is not going to give you 11 kilometers a second. This is acceleration. This will give you 10. This will give you little g.
I know. But so is
you have to
this term? Yeah, I understand. Hold on, I have to see if this actually would give you 10 meters per second squared.
You're trying to plug in the numbers?
Yeah.
Tell me, what is g? I don't even know. What is g? And what is m?
6
what is r?
Something. 6.6743 times 10 to the negative 11.
Wait, it's 6.7?
Yep, times 10 to the negative 11.
Okay. What is capital M?
Mass of the Earth.
Yeah.
So the negative 11 times.
But what is M? Tell me M.
Yeah, mass of Earth is 5.97 times 10 to the 24.
5.8. 10 to the 24. And what is R?
6,371.
6,371, so it's 64. So I'm just doing 2 digits. 6,400, I'm assuming this is kilometers. What are the units of M? M.
Yeah, this is all in kilometers.
M is in kilograms.
Yep.
And G, what are the units of G? It's
kilograms per meter or something, I think.
What is it? I mean, I can figure it out. I can reverse engineer the equation.
Meters cubed, kilogram to the -1.
Wait, meters.
Time.
1 second. Meters
Here we go.
cubed.
Here's. I'll just.
Just tell me. You can't paste it. It's going to be difficult to paste it, but you want to paste it? What do you want to do?
Yeah, no, I'm not gonna paste it.
So just
times 10 to the -11 newtons times.
Wait, newtons. Yeah.
Man, you just looked. This is really bad.
What's bad?
Yeah. The big G. You're just gonna have to look it up for what it is.
Why? Why can't you tell me?
I am.
So newtons. What's that? What are the units? Just tell me the units.
Times square meter divided by.
Wait, Newton
kilogram.
meter squared.
Yep, over kilogram squared.
Okay. All right. So
This better give 9.1.
What?
9.8. At least 9 or yeah. This better give 9 something.
you did the calculation.
It was.
What are you doing?
I think this is 9.4 million.
Okay, that's not good. You should get 9.8, not million.
Because I don't think this derivation, or I don't think this math magic F equals ma equals force.
You don't think this is right? You think there's
Hold
a
on.
problem?
No, well, let me think about this, please.
Well, let's look at the units. Let's do dimension. This is called dimensional analysis. The first step is to do dimensional analysis. So what we're saying is A is meters per second squared. This is A. And A is equal to G. G is Newton meter squared per kilogram. So it's Newton meter squared per kilogram.
A is not G.
No, I didn't say A is G. A is G times M divided by R squared.
Okay, yeah.
This is G. These are the units of G. Then we have capital M is in kilograms, and then the units of R is meters, but it's both squared. So kilogram squared, meters squared. So meters square and meters square cancel out. Kilogram and kilogram square cancel out. So meters per second square ends up being kilogram Newton. So what is Newton? What is a Newton? I think a Newton is in units of MA. A Newton is force. Force is mass times acceleration. So Newton is kilogram meter per second square, because acceleration is meter per second per second.
Yep.
Something like that. Because velocity is meters per second and acceleration is per second. So it's meters per second per second. So Newton is kilogram meter per second per second. So Newton is kilogram per it's kilogram times meter. So we no, 1 second. So Newton, let's remove the Newton. Wait, so
don't you have to multiply by 0 though? Because
no, this is
mass.
Wait.
Mass equals 0.
No. No, this is just A. This is A. This is capital G. This is big M, and this is R. There's no little m in this equation. So
I know, but what I'm saying,
wait, let me just finish the dimensional analysis. So so Newton, we can drop out Newton. Instead of saying Newton, we can say, and Newton is in the units of MA, it's kilogram meter per second square. So let me do, it's kilogram meter per second square. Now let's look at that dimensional. Could you move your mouse? Okay. So we have meter here and meter here. We have second square here and second square here. But we're left with kilogram and kilo. So we have kilogram squared left over. That's not good. So the dimensional analysis is, this was wrong. This was not squared. This is m and this is r squared. This was never, so we're still left with this kilo. So we have to undo everything. Okay. So there's none of this. This is, okay, this is, again, this is acceleration is equal to big G, this is big M, and this is R squared. Okay, so let's start over. So you could say immediately M from here and M from here, kilogram here and kilogram here, meter here and meter here, and a Newton we said is in the right, it's F equals ma. Newton is F. So the Newton is basically in the units of kilogram meter per second squared. So instead of a Newton, we'll say kilogram meter per second squared. So second squared and second squared, meter and meter. We're still left with a kilogram with an undefined kilogram. This kilogram went away because of this kilogram. So something is wrong with the units of G that you gave me. You said Newton meter squared over kilogram. That's not possible.
kilogram squared, yeah.
Kilogram squared?
Yeah.
Okay, okay. So kilogram was squared, and that explains how this so everything is fine.
Yep.
Okay. So the units are good. Dimensional analysis works out. The next step. So that's A. That's the definition of A. Okay, which means that if you have planet Earth alone in the universe and you put a test particle at infinity, it doesn't matter what the test particle is, whether it's massless or not, it's going to start accelerating according to this equation. A equals gm over r squared, where this is r, we have g, and this is capital M. So gm over r squared defines A. As r goes to infinity, A goes to 0. So in the beginning, the acceleration is 0. But there is no infinity. We cannot place it at infinities for math. So math is nice, but in reality, there is no infinity. Anyway, let's now let's place it at infinity and let it go and see at what speed does it impact Earth. So A equals gm over r squared, or negative, it doesn't matter. Given that, how do you figure out what the speed will be? So the way to do it is you need to figure out, well, you need, I would say, the velocity equation. You need from A to derive the velocity. Or maybe we can integrate, well, okay, let's see. We can integrate A, we can say, okay, let's say the following. Given A as a function, right? This is A as a function of R. For every R, there is some acceleration. So what we would like to do, right? This is the diagram. We want, right? In the beginning, there is some dr, there is some delta r. Over delta r, we're going to experience some delta v, some a. There's going to be some a, which is some delta v over delta r. So I think we want to integrate, right, which is basically a at r.
Is the change in position over the change in velocity.
This is the change in velocity at r. The change in velocity as a function of r. So what we would like to do is, let's take a little dr, multiply, right? A, well, how do we get, right? We want to know at what velocity does it impact Earth. So right, so what we want to do is we want to say, okay, there's going to be some delta v over this delta r, and then there's going to be another delta r, another delta r, and then over this delta r, there's going to be another delta v, a different delta v, which is a at r, but this is a different r because r changed from here to here. So it's not the same delta v, but it's the same delta r. So we would like to multiply this delta r. No, we want to add this delta v plus this delta v plus all the delta. We want to integrate all the delta v's. We want to.
I know
what?
I said I know what integration is. Yeah.
Oh, that's good. We want to integrate all the delta v's, and that should give us the v final, the v on impact. It's going to be the integration of all the little delta v's. All right, what is the definition of delta v? So is it a times dr? Is it true to say, is it correct to say the delta v is equal to a, or okay, little delta v at, let's just say at r, because there's different delta v's. Delta v is basically a function that changes with respect to r. So delta v at r, is it true to say that it's equal to a at r, some acceleration at r, times delta r? Does that make sense?
Well, linearly, what a would be, a is delta v over delta r. Well, no.
A is delta v over delta t.
Yeah.
But it's not. A is delta v. Yeah. A is delta v over delta t. And delta
oh, no,
t.
but we're putting it in terms of delta r. Yeah.
Right. But the definition of A is delta V delta. That's just the definition of A. What Newton gave us is A defined as such. We can't
I
change.
know, or-
Right.
Yeah.
So
What I'm saying is
Mhm.
you can define it as a. You make A some function of radius to velocity. Or yeah.
anyway, so what I did is I converted what I did at this point. I don't know if it's possible to resolve it. I don't know if you can go directly, if you can integrate AdR. Does that make any sense? A times dr. No, it doesn't mean anything. A times r. Some right, there's some acceleration, a few meters per second. If you multiply that by meters, that's meaningless. This doesn't mean anything. So this is useless.
Are you trying to find the integral of A?
Well, I'd like to do this. I want to integrate all the delta V's. So I
Well,
need
You need to know the change of acceleration in terms of
the change of I need the changes in
yes, we need to know the change in acceleration to know the total change in velocity.
I just need all the delta V's. Each delta V as a function of R. Oh, it's just A at R.
Yeah, it's just A is 6,371. Yeah.
No. What? No, we don't know.
It's just R
No.
being 1,371. Yeah.
What? What are you saying?
R being the radius of the Earth.
No, infinity. R is infinity. We are letting go of a particle at infinity, and we want to let it go and see how it flows and accelerates and impacts Earth at 11 kilometers a second.
All right. Yeah. So the bound of this function would be infinity to 6,371.
Yes, that's true. But we first need to develop the actual integral. So this is incorrect. There's no meaning to this. We don't want to take the A's and multiply them by dR's. We want the dt's, because A is dv dt. We want the dv's, so we want dv dt times. Anyway, this is a dead end. The way this is structured, we can't move on. I don't think so. Delta V at R is A, unless I'm wrong.
No, that seems
No. And there's another problem. This is an infinitesimal amount, and this is a finite amount. So this is not even equal. So you need to. This needs to be.
Well, R.
What we're saying is, we're saying this is. What? This is correct. dv dr is equal to A, but now the units are incorrect. Because velocity is dx dt, and acceleration is dx. I mean, it's the second derivative. It's anyway. The units are m meters per second squared, and this is meters per second per meters. The dimension.
No, you're overthinking. Like
what?
This is equivalent. The change of velocity at some point.
This is not a change of velocity. This is
the change in velocity of a function of R. So what is the change of velocity? Delta V.
You can't. But this is infinitesimal. You can't have an infinitesimal and a finite amount. That's impossible. Acceleration is some number. At every
I know.
What?
I said I understand that. Yeah.
So
Yep.
this is simply incorrect. This mathematically is a dead end. Anyway, this is a dead end. So what I did at this point was I derived velocity from acceleration. I want the velocity from the acceleration, which is not.
Okay, which is where you cancel out the m's.
Which is what?
Which is where you cancel out the m's by f or a equaling.
What did you say?
What? I said, is this where you cancel out the m's?
We already did. We're way after canceling. We cancel out the m's at the top. We have a. We want now to derive.
Where
Look,
did you get 11?
we're trying to derive it. Look, I can just pull up my notes and read from my notes. Do you want to do that?
All right, let's do it. Yeah.
Let's do that. Okay. So let me pull up another one. I'll use my note. I mean, we're doing it slowly. I thought maybe I can do it a different way this time. All right. So derive.
This derivation don't make sense, Mr. Slave.
Yeah, I'm sorry. Kilometer.
Right.
Okay, let's try this again. This time, let's use the cheat code. All right, my notes. All right, the notes.
All right, this is something you should make. If you want to make a paper, you shouldn't do the rubber ducky stuff. You should do a mathematical, you should write a paper that deals with the derivation of this, detail the impact of the derivation, and then that would be a good paper. I would support that.
There's many papers. I need to write many papers. This is one of them. Yeah, but the rubber ducky is the most.
This is the paper.
No,
this is the.
No. The rubber ducky. No, the rubber ducky is the more is where everything begins. I'm sorry. The rubber ducky is. Do you understand the rubber ducky?
Yes, this is your time dilation thing. Yep.
No, time dilation is dialect already proved time dilation. No, the rubber ducky is the second postulate, the proof of the second postulate that the speed of light is a constant if you assume ether. Ether gives you a constant speed of light. That's the most foundational paper. Everything sits on that. Everything else is negligible compared to that because
I think we should talk about this in in Globe Gangsters.
We should talk about it? Like
in Globe Gangsters, yeah. There's some other people in there.
So you don't want to do the derivation? You want to talk?
Wait, no. What? Well, I think we should do the hold on. Let's see if they want to. I will tame them. Okay, if they start bullying you, I'll get them under control. How about that?
Okay. Let's go.
All right, unmute Mr. Slave. I brought him over here. Omnivore, come on.
Well, Gamma, why would you do that?
He's my best friend now. I don't know what you're talking about.
Why is he blocked?
What? Oh, yeah.
Why is he muted?
He's unmuted now.
Okay, what did he do?
I didn't mute him. So, Mr. Slave, I don't know what got you muted. I don't know if it was just the standard, nonsense, but don't say anything.
Yeah. I'm not gonna say anything.
Okay.
Was he saying creepy things?
I don't know.
I'm not gonna say anything. I realize this is everyone is on edge. I'm not gonna say anything. Everything's fine.
I was just thinking about
that's good.
Like the furry porn. I know you weren't the guy doing that, but
I realize everybody is on edge. No problem.
Okay. All right.
Okay. Hey, Gamma, I have a question for you.
We're here for Mr. Slave.
It doesn't.
Go ahead.
Okay.
Well, I think. Can we not have Mr. Could there be like one day that's Mr. Slave free?
I brought him over here. I was talking to him on a server.
Oh, I see. I thought
Yeah.
we could have Mr. Slave free Thursday or something like. But I'll take that up with the management.
Yeah. I was talking to him about his derivation of 11 kilometer per second ether.
I like how you brought him in here like a slave too.
I
it's like-
did.
Hey, so
I
come on, I'll just ask you a quick question, because a personal question, and then I'll shut up. Okay?
Yep.
Then you
yep.
can interrogate Mr. Slave. Did you say you were 19?
Yep.
Yeah, I'm thinking about bringing my son into this channel, but he's 16, and you guys have to maybe keep the furry thing away from the channel.
That
16. I was younger when I was in school. He'll be fine. I'm sure he has thick skin, just like his dad.
Well, he does. But I'd like him to hang out with you a little bit.
With me.
Yeah, maybe you can. Am I your daddy? Yeah, I think I'm your daddy. You could become his older brother.
Oh yeah. I would be down for that. I would like to meet your son. That would be cool.
Yeah. All right. Yeah, all right. Maybe I'll bring him in tomorrow.
Nice. He'll become a flat Earth debate champion.
Oh, he already is. He used to debate Bev.
Oh my God.
But he has like a little slideshow, I think, that proves the globe. He came up with himself. So maybe I'll have him present it tomorrow. How about that?
that'd be
I
good.
think good. That would be good.
All right. I'll let you guys talk to Mr. Slave. I know you guys are hungry for some fresh content.
All right. Stream the whiteboard, Mr. Slade. Boot it up. Come on.
Yeah, let's start over. So, whiteboard. All right. So this is going to be 11 kilometer per second derivation. Okay. Let me just, that's better. Oh, come on. All right. Anyway, okay, let me take me notes. So according to me notes, we're starting from A equals GM over R squared. So
yep.
A equals GM over R squared. Okay, that's the first step. So A is defined as dv dt. Okay. And so now dv dt is equal to GM over R squared. Okay. Now, dv dt, well, you could view, right? So let me just say first. So dv dt, we can multiply by 1, which is dr by dr, and express dv dt in this way. Right? We're allowed to, and we can discuss what is dr, what is r, but let's just say that this is still equal to GM over R squared. So what is R? So we have a point mass.
I can't wait to see until 11 comes out of this.
Oh, okay. So we have the point mass, which is, for example, Earth, and we have a test particle, doesn't matter what its mass is, could be massless, and there is an r distance between them. And at any point, there is acceleration as a function of r, and r is a function of r, but r is a function of t, right? Given if we're starting a clock, t equals 1 second, 2 seconds. For every t, there is an r, and for every r, there is an a. And dv dt is just a.
Yep.
So what you're saying is that there is a dv dr. There is a change in velocity relative to a change in r. For every change in r, or you could say there's a delta v for delta r. So for any delta r, there is a delta v.
I think the answer you're looking for is 11.
Yeah, exactly. Anyway, so there is a dv dr and there is dr dt, and given some r as a function of t. Anyway, so we're good to go. The next step is to notice that dr dt is v, is the velocity. That's
Change in position over the change of time is indeed velocity. I agree.
Yeah. So dv dr times velocity is equal to gm or gm over r squared. That doesn't change. Okay. And the next step is to say is to multiply both sides by dr. So let's say this is gm over r squared. And the next step is
I'm not looking at it. What are you guys calculating?
we want to show that a test particle that you drop at 0 velocity at infinity away from Earth, Earth being the only planet in the universe, you let it go, you let a test particle go at infinity, and it's going to start accelerating, it's going to start drifting slowly towards Earth. By the way, it could be a massless test particle. It doesn't matter if it has mass or doesn't have mass, which already indicates that that is the flow of the ether. So any test particle...
No, it doesn't. It doesn't at all.
All right, so delta v over delta r times v, that's just v times v, which is a.
No. So
it's v squared. V squared equals what? Delta v over delta r times v. Delta v over delta r equals
it doesn't.
Change of velocity over change in position.
Yeah, but that's meaningless. We don't care about that. So the next step is to say.
Okay, that's not time. Okay, never mind. I'm stupid. Sorry.
The next step is to bring this to here, and to bring this to
please
here.
Change delta r to delta x. What are you doing? That's gonna mess me up.
Oh, I'm sorry. Well, it's too late now.
That's fine. I'm just complaining.
Okay. So we're going to bring the dv over to here, and we're going to bring the dr over to here. So we're going to say that v dv is equal to gm over r squared times dr. And the next step would be to integrate. So VdV, let's integrate VdV from the velocity equals 0 at infinity to the velocity equals the final velocity on impact, right? We want to see how this particle accelerates until it impacts on the surface of the Earth. So
we need to integrate GM over r squared.
Let me just say
delta
that.
r.
Let me just say that this is V final. We're looking for V final. V initial is equal to 0. So V initial is 0. The V final is VF. So this is the integration on this side. The integration on this side, well, R, we're integrating this with respect to R. So R is infinity. And R here is the same as this R. It's the surface of the Earth. It's the radius of the Earth, which we all know is a sphere.
Wow, I haven't heard that said in a long time.
I just want to make sure you know I'm on board. I'm on board with the sphere. That the sphere we don't have a disagreement about the sphere. Okay. Anyway, the next step is to actually integrate. So the integral of v dv is just obviously v. So this is v integrated from 0 to vf. And I can't, let me minimize this a little bit. Okay. And it's equal to, well, the integral of gm over r squared is just gm over r. Let's check it. So this is just gm over r. We'll soon, I'll check it in a second. From r equals, we said infinity, to r equals the radius of the sphere Earth. So is gm over r, is this truly the integral of gm over r squared? Well, let's take the derivative of gm over r and we'll see. So the derivative, right, this is -1. This is gm r to the -1, which means we bring the -1 over and this becomes a -2. So it's correct. Everything's fine.
Whoa. Hold your horses, pal.
Yeah.
GM is a quantity. It's a constant.
Yeah.
The derivative of G is 0.
The derivative GM are constant, but R is the variable. So you
Yep, but G, so then it would just be R.
No, this is R to the -1. So GM R to the -1. So GM R to the -1. We want to do dr of this.
Yeah, but the derivative of GM is 0.
No. There's no such thing.
All right. What is the derivative? What is the derivative of 6?
No.
Hold on. No.
This
Mr.
comes.
Slade. The derivative, or GM, is a finite quantity. It is a constant.
Yeah.
The derivative of a constant is 0.
Yeah, but this is a factor. This is a multiple. This is a slope. GM is the slope of the function. So it's a constant slope. You're looking for the slope. This is part of the slope. You can't ignore a coefficient of the slope. This creates a slope. This is part of your slope. You can't say it's 0.
There is no change in. There's no if you do a graph of just GM, you're going to get 0. There's no change in GM.
Yeah. Well, there's no change in GM relative to R because GM is not a function of R. GM is a straight line, but that's not our function.
So what is the derivative of a straight line?
Here, look, it's not a straight line. This is 1 over R squared. No, this is 1 over X.
Yep.
So this, right? But if you have a factor, if you have 7 over X, then it's different. It's this. It's something bigger. It's always bigger. It's 7 times bigger everywhere. It's a different slope. It's a different function. This is the GM. You take the coefficient, you take it out of the derivative. You don't care about it. It comes out. That's the way you do derivatives. You can go back to doing differential calculus. This is like first week or first month, whatever. The slope, right? Okay. So all we're doing is we're taking the derivative of r to the -1, which means it's negative r to the -2. Well, that's exactly it. Here is r to the right. It's 1 over r. It's just 1 over. It's 1 over x squared. 1 over x squared is right. The integral of 1 over x squared is 1 over x. Anyway, so this is the equation. This is the correct equation so far. Are we on board?
Yes.
All right. So let's plug in. So VF minus 0 is just VF. So VF, the V final, is equal to. So GM, if we plug in R, we get.
The reason I said it was 0 is because this is like taking the derivative of GM over R is quotient rule. You're going to get derivative of G minus G over R squared is what the function would be, I think, for the derivative of
exactly.
Yeah.
There it is. That's the original GM over R squared. Exactly. You said it.
Yeah. Yeah.
So everything works out so far. All right. So V final. So if we plug in the integral endpoints, so V final minus 0 is just V final is equal to GM over R. We plug in R. That's just GM over R. And at infinity, GM over infinity is 0. So it's just GM over R. And if you plug in the numbers, you should get 11 kilometers per second. So we have G, we have M, we have R. But we know what is GM over R squared. We already know that's 10. GM over R squared is 10, so it's just GM. It's the same, it's the 10, but we multiply by R. So it's 10 times 6,000 kilometers. 10 times 6,000 is 60,000 kilometers per second. But it's divided by 2 because we had a 2 GM. So it's 30,000. What was there a 2? No, there was no 2. Anyway, let's do this. Maybe I'm wrong. Maybe it's not 11 kilometers a second. So what is GM over R? Is this correct? Should be. Is it GM over
R? Quotient rule, yeah, right.
So is this correct? Something.
There's the omnivore.
No. Something is wrong.
I agree. It's not 11. Oh my god.
No. Something is wrong. 1 second. Oh. The integral, this is v dv. This is not the integral of v. Jesus Christ. The integral of v dv is v squared over 2. Right? The integral of v dv, right? This is v to the 1. The integral, right? It's It's v squared over 2. The derivative of v is 1. This is not 1. This is v. It can't be the same. So the derivative, so this is v squared over 2, because the derivative of v squared over 2 is v. So it's v squared over 2. So therefore v is equal to, so we need to multiply by 2 and take the square root. Right? Because when we plug in now, this just ends up, right, 0. So this is just v final. So v final squared over 2 is equal to this thing. So v final is 2gm over r squared.
Well, it would be
the
2 would be over the 2 would be over the whole function, not just gm, or the 2 would be over the whole term.
No, you multiply by 2 and then you take the square root.
Yeah, I'm saying that the 2 wouldn't be just gm. It would be over the whole term.
The 2 isn't over the gm over the whole term. What do you mean?
No, it would be over the whole term, not just gm.
What do you mean? What? I don't understand. What? I have
the whole term, meaning it would be 2 times gm over r.
That's what I have. Square root.
Okay, yeah, okay. It looks like it's just in the numerator.
So
never mind.
There is a 2 here, and there is a square root. Here. Okay, clearer. So now let's plug in the numbers. We know gm over r squared is 10. So 10, if we multiply by 6,000 is 60,000, divided by 2 is 30,000, and what's the square root of 20,000? So 25,000 is 5,000. So it's still not 11 kilometers. Okay.
Oh.
So let me see, v squared, because my notes are for a black hole. My notes are not for the impact. The impact I did online. So 2gm over r. Okay, let's just plug in the numbers. You have a calculator? I'll give you the numbers.
Yeah, I'll plug in into Desmos.
So all our numbers are on the other server. So I barely remember. I don't remember the numbers.
Bacon, is this adding up to you?
What do you mean adding up?
All this derivation work?
He doesn't know this. He can't just look at it and tell. Gm over r squared, I think, is 10, right? We multiply by r, so it's 6,500. So it's 65,000. Times 2. It's 120,000. What's the square root of 120,000? Yeah, that's 11, exactly. Because 11 times 11 is 121. So it's exactly 11 kilometers a second. Everything works out. Did you understand the derivation?
Yes.
But did you understand the 11 kilometers a second?
I do now, yes.
Look, this is and Professor Kim Jong-un, whatever his name was,
what?
K-pop, Professor K-pop's Park.
Okay. You scared me for a second.
So Professor Park was like, for me, Park is like a North Korean name. So Professor Parks, he said, as soon as I said 11, he said, "Are you sure it's 11, not 11.2, the escape velocity from Earth?" So I said, "Oh, so that's that's why it's 11." This is the escape velocity in reverse. This is the escape velocity played in reverse. The escape velocity is
Well, yeah, escape velocity is what is it?
11.
No, this might. The equation for escape velocity is also extremely similar to this. Hold on.
No, this is the escape velocity. Because what you're saying
Is it
is
the same as like okay. Okay, I know velocity is
No.
root GM over R.
No. This is the equation. Now just look at the diagram. Just play this diagram in reverse. So instead of V final, call it V initial and reverse the direction. And you're going to throw a particle away from Earth, and at infinity, it will achieve 0 velocity. That's the definition of escape velocity. And it's 11 kilometers. So, and then when I said it, he said it's 11.2 because he probably knows it because there's other ways to derive it. I'm sure you can use energy. Usually energy is easier to derive than F equals ma. I'm sure that there's easier ways to derive it. Anyway, so that's the answer. There's your 11 kilometers a second like you wanted. Are you happy?
I am very happy.
Do you see how... do you feel that this is the ether, or do you not see that this is the ether? Right?
I think everything just it travels through a vacuum, bro.
But look at this. Listen to what this says. This says, look at this. This says you place a particle of 0 mass at infinity, and instantaneously it starts accelerating. How does it do that?
Yep.
How?
It just does.
No, you have to come up with a mechanical explanation. You can't just... This is not a magical universe. There's no unicorns. There's no Jesus and gods and goblins. You have to explain this mechanically. Instantaneously, it starts drifting as if you placed it in a river that is flowing. Well,
all right. So then what caused the ether?
No, that's fine. I mean, look, the ether is just a mechanical explanation. We can discuss what causes the ether. The ether spontaneously self-replicates, and we can talk about other things we know about the ether, but there has to be, in order for us to have a mechanical explanation for the phenomenon of gravity, we need a mechanism. You can't just say that's just the way it is. I mean, you could, but then you don't have a theory of gravity.
What about the space-time stuff I keep hearing about?
That's just a description. Because when I spoke to the professor, I asked him, so he said, mass curves space. I said, why? Why does mass curve space? He said, I don't know. I said, okay, then you don't have a theory of gravity. You just have a description of gravity. The same as Newton. All you have is F equals gmm over r squared. You have a description. That's very nice. But that's not a theory. A theory is a mechanical explanation, a mechanical simulation, contraption, some mechanical cause and effect, a simple cause and effect that
sure, but why I mean, why would we think it's I mean, so how do you distinguish ether from space-time?
Look, the definition, first of all, this has nothing to do with time. Time is, for me, nonsensical.
But okay.
I don't have
people
space.
People get super hung up
Mhm.
on the name that Einstein chose for it.
Einstein didn't choose it. This is Minkowski. This is the Minkowski tool.
Yes.
Yeah,
Yes.
it's just a tool. That's like getting hung up.
So
Yeah. Mm-hmm.
So you know, there is obviously a time-like dimension to our experience.
Of course, I'm not
Right?
denying.
If I draw a Minkowski diagram and something is stable, you could still depict it as moving on the time axis.
But I don't.
And
Wait, no. Listen.
and it
I'm not. No. But I'm not drawing right now anything. I'm looking at the universe, and I see a particle accelerating. I want to explain it. I don't care about Minkowski. I care about the particle, and I'm wondering what is pushing. Something is pushing, right? It's just like Einstein. He wrote 3 papers in 1905. One of them was the Brownian motion, and he said, well, the mustard particle or whatever, the seed, something is bouncing around under a microscope. Well, there must be molecules bouncing around causing this. Well, no one saw a molecule, but Einstein said, well, that's the only explanation. You could have said, well, it's just space. It's just water. You could say whatever you want. But it makes there is a mechanical explanation that you're skipping over for no reason.
well, I'm not skipping over it for no reason.
Okay.
I'm asking what your ether hypothesis or ether explanation gets me.
Gravity.
If I can say it's space time or
No.
Space time gets me gravity.
No. Space-time and those words are very nice as a description. I asked him, what causes the curvature? Why does mass curve space-time? Whatever that means. I don't care what it means. You like using those terms. Enjoy. What causes? What is the cause of the curvature? In my universe, yeah. Mm-hmm.
So let's say that I say what causes it, ether. Let's just say that
That's fine.
I'm gonna
That's fine.
say that ether causes it.
You
what,
can always.
What does that?
That's like asking. Look, that's like asking you. That's fine. You can ask, but my ether gives you the constant speed of light. My ether gives you. My ether gives you. My ether gives you gravity. It gives you 2 things: a mechanism for gravity and a mechanism for special relativity. You don't have a mechanism for either. For you, it's just you just have a
that may be true, but I don't necessarily, why would I think that your explanation for it is correct?
What's the alternative?
It's something we haven't figured out yet. So in your one of the things that I understood you to say was that you don't think there's any particles. It's all waves.
Yeah, that comes out of the ether. Yeah, the ether.
So that means that you think that sometimes waves behave exactly like particles, or something else.
Waves. Look, an electron in my universe can only be a wave.
Yeah.
Because of the ether. But there's other reasons it can only be a wave, because an electron can decay into other particles, and other particles can decay into electrons. These things are unstable. They cannot be particles because they they switch. How can you switch from one particle to another? Suddenly you have a particle that has a gluon.
That's like saying how can a human corpse decay into proteins, right?
No.
How would you explain that?
No. Look, an electron. Sometimes you have an electron decay into photons or something that have no mass. Where did a mass go to? Right?
So I'm not sure about that.
It went into energy.
Exactly.
I mean,
exactly. So there's no mass. That's my point. There's no particle. That's exactly my point. It's all energy. There is no mass.
But
look, mass. Do you know? Have you ever heard of that?
No. Mass and energy are equivalent. They're not. Energy isn't mass. Just how mass isn't energy. They're they're equivalencies, right?
No. Mass Mass is just a form of energy. What is mass? Mass is just an illusion. Mass is just the Higgs interacting with a particle. So a particle bounces back and forth within the Higgs. That gives the illusion of mass, of inertia, of moving slower than light. It's just an illusion.
Well, like I said, I'm not sure what it gets me, but
What do you mean?
I mean, I don't know what the, if I say, okay, it's, I'm going to ascribe all of this to the ether. I'm not sure what.
I'm giving you. Look, okay. You don't have a reason, a mechanical explanation for SR nor for GR. Ether gives you both. Done. What else? I'm giving you two. I'm giving you two incredible reasons. Each on its own is incredible. A mechanical reason for SR is unbelievable, and a mechanical reason for GR is incredible. I'm giving you both, and they are the same, and it's the same for quantum mechanics. I'm giving you everything, and dark energy. I'm giving you so many things. I'm unifying all of physics, and you're saying, yeah, I'm happy with physics not cooperating. It's like,
no. That's you're okay. So you're misunderstanding that. When saying that there's no such thing as particles, everything is a wave. To me, seems like ignoring a lot of observable information. Or
like what?
It means that you're Compton scattering. Of course.
Okay, look, with all due respect, it does, like, for me, Compton scattering is explained easily by waves. So
but nobody agrees with you, though.
I don't care. I'm not here for anybody. I'm here for me.
No,
So
the science doesn't agree with you.
I don't care. Science is me.
If you're gonna be science compliant, then
I don't care. I don't care to be science compliant. It's me. I'm curious about this universe. I'm trying to make sense of this universe. You're welcome to come along with me on my ride. You also welcome to invite me to your ride. I'm happy either way. I've been going on rides with everyone that invited me, and I became disillusioned. No one explained SR mechanically. No one explained GR mechanically. No one explained quantum mechanics at all. It was a nightmare. Physics was a complete nightmare. Okay, 3 months ago, for some bizarre reason, when I decided to take a plunge into physics, because I got tired of people telling me about the probabilistic universe, I got tired of that, and I said, okay, enough of that. I'm going to redefine physics how I want it, because I see that I'm getting nowhere letting other people define physics. That's getting me nowhere. So I'm going to redefine physics. From now on, physics is 100% mechanical. No more quantum nonsense, no more SR nonsense, no more GR, no more nonsense. It's going to be 100% mechanical. I'm not giving me a break. I'm going to figure this universe out mechanically, because apparently no one else can. So it's up to me. I'll get the job done or I won't, but I'm going to try. That was 3 months ago. Very quickly I figured it out. It was actually very easy and done.
Yeah.
So this is my science.
Except for the fact that there's a lot of observable behavior that I don't think it explains.
Yeah, not yet. I still have kinks. I still have kinks in the fabric that I need to straighten out. I still don't know exactly what's going on with the collapse of the wave in quantum mechanics. I still don't know exactly with the Stern-Gerlach. I still don't know. There's a few basically within quantum mechanics. I'm a little bit. I need to figure things out. The wave equation, I pretty much understand it 100%. It's 100% wave equation, no problem at all, or almost. Like I listen to physicists talk about the wave equation, and I think I'm talking to a mental asylum. It's like I don't know what these people are talking about, they need to come to me. I'll explain it to them. It's really very straightforward. Really no issue. There are issues, but that's not one of them.
Okay.
So look, I look, 3 months ago, I didn't know anything about the ether. I didn't think the ether is going to become so important in how I'm going to figure out this universe. I had no idea. It's all recorded. You can go back to the original videos from 3 months ago. I had no idea what's going on. I didn't know. I was walking into physics completely blindfold with basically zero given. I didn't know what's going on. And I just, I started from, I was watching Veritasium's video, Something Strange Happens When You Follow Einstein's Math. My intuition was, he's wrong. He doesn't understand. No one understands. I'm tired of people misunderstanding black holes. Black holes seem to be, to me, much simpler than what people are saying about them. Let me start from there. I started from that. I made hours and hours and hours of videos reviewing Veritasium. And then one day I said, you know what, let me take a break. Let me write down the equations, which is what we did right now, these equations. Let me write down these equations. Let me derive a black hole from Newton's because I know it should be possible. And I did. And as I did, out popped the ether. The ether came out of Newton's equations. The ether comes out when you really think from Newton into a black hole. You see the ether flowing into the black hole at the speed of light. It just, everything fits. Everything becomes mechanical. And then I worked backwards and, I noticed that SR seems to come out and time dilation and gravitational time dilation. Gravitational time dilation comes right away, comes at you whether you like it or not. So GR itself, with the curvature of spacetime, comes out directly from assuming the ether. All of physics comes out of the ether. All of physics, everything. Basically, maybe I'm wrong. Maybe I'm getting something wrong. But for now, my intuition is, without checking too much, all of physics seems to come out of the ether assumption. And it's all mechanical. A baby can understand it. Honestly, a baby can understand it. You can laugh at that statement as much as you want. A baby can. If I show a baby a movie of how the ether causes gravitational time dilation, a baby will understand it. It's trivial. Do you understand? Look, I don't have an agenda. I honestly don't like. Are you there?
I'm here.
Look, I don't have an agenda. It's not like you can.
I don't think you have an agenda.
Yeah, I could care
think
less.
that you legitimately believe that you're the greatest thinker that mankind has ever seen.
No, stop it. I don't care.
Well, that is in fact what you're. If you don't think that, then
I don't care.
Not?
I don't care. I
Yes,
don't care.
Well, that's fine.
I'm not judging. I'm not judging me. Positive.
Are you aware that this is not the first time that somebody has come to the same conclusions that you have?
Like I've done my due diligence. I didn't see anyone on the internet say anything resembling what I'm saying. I don't know what you're talking about.
I'm talking about people who ride into practicing physicists and say, I've got a theory of everything.
I didn't do that. I didn't do that.
I know. Well, you are effectively.
What? I'm effectively what? I'm not doing that. I don't care.
Effectively doing the same thing. Yeah.
I don't look. If a physicist wants to talk to me and listen to me and have this discussion, he, she, they are welcome. And if they don't want to, they're also welcome. I write to people on YouTube who are practicing YouTube creators, and I ask them if they want to have a collaboration. That's all. And I've done that less than 10 times, I think, by now. I don't write to practicing physicists. I didn't write to a single practicing physicist. So I'm not, but I'm still working on my theory. I'm still studying, right now I'm studying GR. I'm trying to make sense of GR because I don't know GR yet. I'm beginning to understand it. Maybe I'll see the GR contradicts my theory and I'm wrong. But for now, that doesn't seem possible because GR just assumes gravity and I'm giving gravity. I'm also assuming gravity. I don't see where a conflict can arise. But who knows? I don't know. But look, you can attack my theory. So there's no point in attacking why I'm doing it or should I do it or
I'm not. It's not. I don't think you have an agenda. I'm not attacking why you're doing it.
I'm just curious.
I'm telling you that you have that the pattern that you are
I don't
experiencing
care.
here
I don't care.
is a repeating pattern.
I don't care. I'm just curious. I'm just curious about this universe. I've given scientists my entire lifetime to figure it out. They haven't done it. So before I die, I decided to give it a shot. And it happens to be trivial. For me, it was trivial to come up with this solution.
Yep.
So you can take it or leave it. It's up to you. I'm giving you a gift. You like it, enjoy it. You don't like it, you don't have to take it. I'm not going to force you. I'm just providing it. I would have loved if I heard somebody, if like before 3 months ago, I heard somebody explain this theory, I would have enjoyed it. I would have said, "Oh, that explains a lot."
Yeah.
That's it. If you feel it explains, enjoy it. If you feel it doesn't explain, throw it to the garbage. It's for you. It's a gift. You like it,
Okay.
take it. You don't like it, don't take it. It's supposed to.
Okay.
It's supposed to look. It's for me. For me, I'm happy with it. Finally, I have a mechanical explanation for SR, for GR, for quantum mechanics. Everything works together. Simply mechanically. I don't need any advanced math for anything. I mean, the advanced math might be nice for SR, for GR, for quantum mechanics. There's no contradiction. But at least now I have a foundation, one mechanical foundation for everything. So you can use all the most advanced stuff, the most advanced math tools in the world to continue, but I'm giving you the foundation. I'm giving you a simple mechanical foundation on which to build. Enjoy or don't enjoy. It's up to you.
Okay. All right.
That's all I'm saying. So.
Yep. I gotcha.
Yeah, that's. I'd be happy if you would keep asking me questions and ask me, well, but what about GR? What about the Apple? Like Professor Parks, he said, well, explain to me exactly how do you decouple the electron from the ether? That was a good question. Exactly explain to me the mechanism by which the electron is experiencing gravity. Why is the apple falling? Those were good questions. I wish I would have more questions like Professor Parks. Unfortunately, by far most of the discussion is you're not the first, you're not the second, you're not the third, you're not the fourth, you're not the fifth. Instead of, let's explain to me how the electron gains mass. Explain to me what is mass. Explain to me how the ether contains the Higgs. Explain to me how the Higgs boson comes out of the ether. Ask me questions, not are you aware of the fact you're not the first? I don't care. I care about the boson. I care about.
That's not what I meant. Is that you're not the first? That's not what I meant by that. Do you know what I meant by that?
It doesn't matter, honestly.
Well,
Ask
okay.
me.
Okay. Well,
Let's talk about the Higgs boson.
all I'm saying is that you're not understanding. You're not understanding
It's
what I
not-
said there.
it's
I wasn't
fine.
trying to imply that somebody else has done this work that you.
It's fine. Oh, it's fine either way. I don't care. I'm not here for me. I'm not here for me. Why do you keep talking about me? I want to talk about the Higgs boson. I want to talk about the Higgs mechanism. I want to talk about the ether.
Right, I understand that. I don't have too much to talk about that with you.
Why?
Well, I mean, what would we talk about?
Exactly what my discussion with Professor Park was. He asked me actual questions, technical questions. How does the apple?
So did I.
What?
So did I.
So that's those are the kind of questions I'm interested in. Those are questions that interest me.
Yeah, but are you interested in? I have something that I know you're going to be interested in, Mr. Slave.
I'm here.
All right, let me just share my screen real quick.
Mm-hmm.
The interesting part about today, Sea Lion, is Mr. Slave wants something interesting, and I'm here.
Oh, excellent. Well, now you can ask him some good questions.
I'm gonna run get a bottle of water. Give me count to 10. I'll be right back.
Perfect. That's an answer every flat earther gives me when they hear that I'm here.
You guys see my screen?
Yeah. Is this a book you're writing?
This is by the Flat Earth University guy.
Really?
Yep.
That's based.
I can't even read it. I'm laughing so. Haunted by the spirits of her unborn children, Alara returns to her hometown, only to be confronted by her past decisions.
Why do they kind of look like Casper the Friendly Ghost?
They do kind of look like.
All
Through a
right.
journey of self-discovery, aided by ancient rituals and the very river she once feared, Alara seeks redemption and a path to healing. Act 1. Alara returns to her hometown after years of being away, having run from her past. She inherits her grandmother's house by the River of Regret. The town folks whisper about her, remembering the girl who drowned her future in the river. Alara begins to see the ghostly figures of babies around her. Wait, did she drown her baby in the river, or is this like an abortion fanfic?
Abortion fanfic. Wait, have you seen the Zootopia abortion comic?
No.
Okay, that's you need to look at that one after this.
So this is another book that this guy wrote.
You mean AI?
Yes. Yeah, naturally.
Do you think that guy is imposed AI garb onto himself? And
No,
he's not
he's
really a pilot?
clearly really. This is a real photo of him, and he's really a pilot. And that's
He has a sharp
that's a pilot
jawline.
uniform too. What the fuck kind of uniform even is that?
I think that those are the bad guys from the Top Gun movie.
Kriegsmarine naval
Oh
uniform.
my God! Pilot's journey to flat Earth.
Yeah, this guy's everything. He's a
Oh,
pilot.
Terry.
he's
But
a
why do you guys?
astronomer.
Why are you guys so curious about flat earthers? I'm so.
Are you on a Mac?
No.
Yeah.
Oh gosh.
Oh my god.
You're one of those people.
Yeah. Oh my god.
Totoro, did you see this? Dr.
Stephen
Alonso.
Alonso.
Another book.
Stephen Alonso, the man.
You know what the worst thing about Mac
Totoro,
is?
wait. What kind of pilot's uniform is this?
I'm telling you, it's the bad guys from Top Gun.
Why is it on a beach?
From Wish.com.
Eli, I'm going to ask you a question. I hope it doesn't make it feel like I'm picking on you.
Okay, go for it, Lil.
When they announce a new iPhone, do you rush out to get that iPhone, or do you keep your iPhone that you've had that works just fine?
Oh yeah, no, I'm not. I had my last iPhone. I got my last iPhone in 2019, and
So that's the iPhone 14, right?
no, I was
iPhone
using the 6S up until 2 years ago, and then I have the Pro Max 13.
Okay, so you're still a couple generations behind then, because aren't they don't they have 17 now?
Oh, something like that, maybe. Yeah.
16 is the newest one.
15. 16 is the operating
I thought
system.
they're up to 17.
They're up to
I don't know.
16.
Okay, I'm lost. Anyway, does anyone here for me?
Oh, hold on though, because Totoro hasn't seen this one either.
Okay.
This is another work by Dr. Alonso, and it's
Good,
it's some kind of abortion haunting fanfic.
Okay. I came in here to watch what Sea Lion was sharing.
Yeah, well, here it is, ladies and gentlemen.
Hey, quit stealing the lines of Jin, okay?
Yeah. It is what it is.
Ladies and gentlemen, I think we're here for Miss Slave.
Mr. Slave.
Mr. Slave.
Mr. Slave.
You gotta ask him questions. Leo, you have to ask him questions about his aether theory. He has some good questions.
What theory?
Ether.
Whatever theory he just mentioned, could you tell me about that?
Sure.
Oh, aether.
Yeah.
Okay.
So, so I believe that the universe is filled with a fluid that the ancients until 1905 used to call ether. And everything we know is like all the elementary particles. Those are just waves in the ether. So they're not waves in the quantum field, but rather they're waves in the quantum ether. And the ether is a real thing. The field is not a mathematical. The quantum particles are not particles in a mathematical field or in a vacuum. They are particles in an actual fluid. They are waves in an actual fluid. Now, this fluid is not just for the elementary waves, the elementary wave particles. It's also, it creates gravity as it flows into the earth. It drags me and you and apples into the earth. And that is what we experience as gravity. And because this fluid fills the universe, light,
Can you pause for a minute? I can ask a clarifying question.
Sure.
When you say fluid, I think of like oil or gas or water or anything like that. What do you mean by fluid?
Yeah, like water. This universe, right now we are immersed in this water.
And then how does it cause gravity?
It's flowing through us right now at about 11 kilometers a second towards the center of the earth. And we're being sucked into the center of the earth. We're being sucked.
So,
and,
all right. So if it's fluid, usually like in water, it'd be a little harder in oil. But in water, you can swim upwards. Can we swim upwards through the fluid?
Yes, that is what we're doing right now. The fluid is pouring down on our heads.
No. I don't think you understand the question. If I'm in a swimming pool and I jump into the deep end, now I'm under the water, right? And I swim up out of the water. Can I stand on the earth and swim up out of, well, technically it wouldn't be out of the ether, but can I swim up through the atmosphere of the earth, through this fluid?
Well, right now, that's what you're doing. This fluid is flowing down 11 kilometers a second on your head.
But I'm not swimming upwards, though.
Well, you are right now swimming upwards because the electrons in your body are waving through this fluid upwards. So all of you is waving through this fluid right now upwards. And
when you say waving, are you like saying like a sine wave that's going from my toes to my head?
No.
And out the top?
it's every elementary particle. Like every electron in every atom in your body is a wave in the ether. It's a wave of ether.
Pause. Ozzy Brad is here. Are you related to Ozzy Jesus? Sorry for that interruption. I don't think he's going to answer. Go ahead. Swimming through ether.
So every particle in your body is a wave. Every electron is a wave. It's a wave of ether. There's only ether in this universe. There's nothing else. Everything you see in the universe is some sort of a wave in the ether, right? Everything you see is some sort of elementary particle in the in the quantum field theory. So those particles are not particles. Obviously, they are waves. They are waves in the ether. They're waves of ether. It's the ether waving. You are waving in the ether. Right now, you're waving upstream as the ether is flowing down and is sucking you down towards the earth. You're exerting force in order to not fall to the floor. And you're experiencing gravity. That gravity mechanically is just the flow of the ether through you.
I'm really trying to pay attention, but I have no idea what the heck you're talking about, to be honest.
Well, let me ask you a question. So why does the apple fall from the tree and accelerate towards the ground?
I thought the phrase was the apple doesn't fall far from the tree.
Nevertheless, but it falls.
What causes the apple to fall from the tree? It gets dense enough that the leaf or branch or just twig holding it can't hold it anymore, and gravity pulls it towards the center of the earth.
Right.
As far as I can understand, I'm not 100% certain that's correct, but that's the way I understand it. And if I'm incorrect on that, anyone else in this room can correct me.
No.
I think you should reformulate the question better to why does this shit fall from the butt?
Totoro, please be nice. Anyway, so I don't disagree with you that there is gravity. I am not disagreeing. I'm completely mainstream. I'm on board with all of mainstream physics through and through. I don't have anything against anything in any physics textbook. I'm just
except for Einstein after 1919, correct?
Except for Compton scattering, except for wave particle duality, except for double slit experiment.
Except for gravity smashing things into a sphere.
No. I don't have anything against any of the things you just said. I don't deny Compton scattering as an experiment that was conducted.
Do you deny that gravity?
He's not a flat earther, Lale.
Oh, okay. Well, I'm still going to ask. Do you think gravity is the cause of things forming into a sphere?
Yeah. I mean, I agree with mainstream science. Whatever mainstream science says. As far as I know, the way I don't remember Carl Sagan, I don't remember who I heard why all the planets are spherical. It's because of gravity. Yeah, sure.
Pretty sure it was clear before Carl Sagan, but yeah.
I heard it from Carl Sagan. I never heard it from anyone else.
Sure, cool.
Did the apple fall far from the tree before Sagan?
No, that never happened.
No,
before Carl Sagan, gravity wasn't sure it was gravity to begin with. It was like confused, and then Carl Sagan came. And
wait, hold on. Was Newton before Carl Sagan?
No,
dude, you're just a little bit too obviously trolly.
I'm not trolly. I mean, he's asking trolling questions. He started being trolly. That's not my fault.
I'm not trolling. I'm asking you. I can't really. I don't know you well enough to know if you're just joking around or you're serious.
Well, you started
And plus
talking.
I have autism, so it's hard for me to tell sometimes.
Well, you started asking, "Does the apple fall far?" So that's a troll.
Well, that kind of was a troll, and I'm glad you picked up on that. But no, I mean, obviously, the reason I asked that question is the apple's not going to fall sideways.
I don't.
Right? It falls pretty much straight down.
Yeah, I don't disagree with mainstream physics. How many times do I need to say that? I agree with everything mainstream physics. I agree with you about literally everything you know about physics. I don't even know what you know. If you're mainstream, if you're vanilla physics, I'm vanilla physics.
I'm OG. I'm OG physics. I'm not vanilla.
I don't even know what that would mean, but whatever. Look, I'm like Neil deGrasse Tyson. Everything he says, I agree. Einstein, everything, I agree. Whatever everyone says, I agree.
Do you agree with them just because they say it, or do you have a reason for agreeing?
I trust the science. I'm completely vanilla, mainstream. Trust the science. Stay home. Stay safe.
Cool. Hey, to Toro, how do you feel about being completely vanilla science?
I prefer chocolate.
That's what I figured. You're one of those people.
Yeah,
you like retail, not vanilla.
I was into
Yeah.
Millie Vanilla Silence until the lip sync thing.
I like chocolate science.
Chocolate. I like mulatto science.
Nevertheless, so I don't. Whatever Neil deGrasse Tyson says, I say. I don't know any physics. Until 3 months ago, I didn't know any physics. 3 months ago, I started like. I can echo. I can hear myself echoing. Anyway,
Wait, you said Niels deGrasse. Are you like an automaton of Niels deGrasse Tyson?
no, I'm just a guy that 3 months ago got tired of debating people and hearing the nonsense about quantum mechanics being probabilistic and the wave equation describing the universe and multiverse, and I just got tired of that.
Oh, well, I thought that was part of vanilla, this quote unquote vanilla physics.
Yep, that's very vanilla.
Well, so yeah, so me and vanilla physics are no longer so vanilla. So we started like.
Okay, good. So you lied about that.
You change your Facebook status with physics. It's complicated.
Yeah. Anyway,
I only disagree with 1% of vanilla physics.
Yeah, basically. Look, I agree at least with Newton. Like the apple falls. That's all I need. We don't need to talk about anything else right now. So the apple falls. We agree about.
Did it fall before Newton, or did it not fall before Newton?
I think it fell. It fell before.
Oh, cool.
Yeah.
I agree. That's pretty vanilla.
Yeah. Anyway, so you start from apples falling, and you ask, why do apples fall? Assuming apples fall, assuming vanilla physics says apple falls.
So you asked me why do apples fall from the tree?
Yeah, why do they?
I just told you earlier. Weren't you listening? I mean, it's pretty vanilla. It's pretty vanilla physics, if you will.
No, but no one ever answered. In vanilla physics, there is no answer. No one answers why there is gravity. The question is, why is there gravity?
Well, Sea Lion, I'm going to phone a friend. Sea Lion Prime, are you still there?
I don't see him. Oh, yeah, but he's...
Yeah, I'm here.
All right. In vanilla physics, what is the cause of gravity?
Beyond
remember,
the curvature of space-time?
Remember, this is vanilla physics, not non-vanilla.
Oh, you mean without Einstein?
I don't know. It's however you determine what vanilla means.
I mean, I'd say that GR is vanilla.
Yeah, that's
Okay.
fine. So, but GR and Newton is the same as Newton. It's not a mechanical explanation why there's gravity.
I just realized if you agree with Niels deGrasse Tyson, that's after Einstein. So, I mean, kind of that wouldn't be vanilla physics.
It doesn't matter vanilla, schmanilla, vanilla.
what year did vanilla physics start?
It doesn't matter. I'm just saying, assuming there's gravity, I'm just not a flat earther. That's all what I mean. I'm not a flat earther. I don't believe in any. I'm not a conspiracy theorist. I don't believe in any conspiracy theory.
What led you to believe in ethers? Since Michelson and Morley's experiment, they and many experiments like it since then have falsified ether.
That's a good
So
question.
what allows you to believe in the ether?
That's a good question. So I just look. I was looking at Newtonian gravity, and Newtonian gravity, when you look at it, to me it looks like ether. And when ether popped out, so everything began one day. I decided to change the definition of science, and I said, okay, no more probability, schmobability, only mechanical. Either I figure out this universe mechanically, or I keep looking, I keep searching. I'm not going to accept any more nonsensical answers about wave functions collapsing and parallel universes and nonsense. I don't understand it, and I'm not going to accept any more explanations I don't understand. I'm going to come up with.
But if someone were to claim that's part of vanilla physics, how would you respond?
So I don't care. Honestly, I don't care about vanilla physics. I'm just saying, in general, I start from my given is vanilla physics. However, if I have a problem with vanilla physics, then I'll tell you I disagree with vanilla physics on this topic. Like, like if I feel that maybe some people misunderstand the wave equation, I think I have a different understanding, then I'll tell you my feeling about it. If I feel I don't know, like stuff like that, like it's no big. I don't have anything big to say. Like I don't disagree with GRSR quantum mechanics. There's nothing I disagree with anyone. Like I don't think you can find something I disagree with anyone about in physics, in vanilla physics. But in general, when I listen to physicists and they say this universe is even weirder than we thought it could be, that's garbage. If you're getting paid to explain to me the universe and your answer is I don't understand, then give me the money back and go find another job. You're not doing your job. Your job is to explain to me the universe. If you can't, then don't take the salary. Why are you taking a salary?
Okay, go with me here. When they say the universe is weirder than we thought, what do you think the context of that phrase means?
It means, I'll tell you what I think it means. It means they need to give back their salaries and go get another job. That's what it means to me.
I mean in the context of the universe itself, what does it mean when someone says it's weirder than we think?
I don't know. I don't care. I don't want to hear those words. You're getting paid to give me an explanation. Give me the explanation and get out of my life. Don't waste my time. Honestly.
So if someone has an explanation for a thing, but they don't have a complete understanding of that thing, like 100%, is it their 28% that they know good enough?
Yes. Even 1%, even 0.5%, even 1,000,000% is good. But as soon as you tell me this is unknowable, then put down your pen and paper, clock out. Enough. You don't belong. You're in the wrong job. If you think this universe cannot be understood, then go home. This is the wrong job for you. I'm not paying your salary. And don't waste my time.
I agree. Everyone that doesn't understand vanilla physics, put down your pen and go home.
What? No. If you tell me that the universe is fuzzy at the quantum scale, then go home. If you tell me...
But what if it's warm?
What?
What if it's warm, so you feel the warm and fuzzies?
Yeah, that's fine.
What do you think about that one?
No, that's fine. That's fine. Warm and fuzzy is good. It's good. Look, anyway.
That's pretty vanilla physics, I would say. I mean, we could phone a friend and ask them.
Who's the phone? You can't reuse the same friend.
We can use whatever friend you want. Oh, they have to be the vanilla friend, though.
Yeah. Look, anyway.
Does Omnivore count as a vanilla friend?
Sure.
Yeah, pretty boring, really.
Omnivore? I know. Yeah. I know you're omnivore and you're boring. You probably eat meat and vegetables, I would guess. But are they vanilla vegetables?
Broccoli's pretty vanilla. So
okay,
yes.
Cool. Okay, so is the warm fuzzy universe part of OG vanilla physics?
Look, what I'm saying is, I'm tired of people telling me that the universe cannot be understood at this level or at that level. The universe is weirder than we thought it could be. You're not getting paid to tell me that you don't understand. You're getting paid to tell me what you understand. If you don't understand something, don't waste my time. Come back when you do understand. Until you understand, don't waste anybody's time, especially not mine.
I guess I need to know the context they're using that phrase in, because if someone just tells me, if a random person tells me scientist X says the universe is weirder than we thought, I have no context for what that means. They have to have some type of meaning behind it, right?
Look,
and in my
if you've never,
in my opinion, go ahead.
It doesn't really matter. I don't want to waste time. If you've never heard anyone say this, if it doesn't bother you, then let's not. I don't want to waste anyone's time, mine included. So,
well, the good news is I'm here. I'm good at wasting people's time.
Why would you be proud of that?
Well, I mean, if no one else is going to waste time, why can't I?
You can, but look.
Oh, perfect. That's why I'm here.
So look.
I'm a vanilla waste timer.
Look, with all due respect, I'm curious about the universe, and it's okay to take a break and get back to work. And I was in the middle of a course in GR. I'm studying GR. I don't know GR. I want to know GR. So I don't want to. I've been on this server for a couple of days. Most of which have been.
Might I recommend going to Grand Rapids, Michigan? That's pretty GR to me.
Why is Grand? Okay.
Because it's GR. No.
Anyway, look, I don't want to waste time. Please, let's not waste time. Let's be.
Well, why don't you get back to your course then?
Why don't I go back to my course?
You know, I'm not actually wasting time because people invited me to talk to you, and I may be annoying to them and may be annoying to you, but they invited me to talk to you.
But let's be productive members of society.
What is a productive member of vanilla society?
Wait a minute. Do I have to be productive too?
No, it's your server. You can do whatever you want.
It's not his server. What do you mean your server?
You're borrowing a space on Discord server.
Look. What's your point? What do you want to do? You want to waste time? That's all? You don't want to have a productive conversation?
Are you religious?
I am religious when it comes to wasting my time. My time is holy of holies. I have very little of it.
Well, great. If you're religious and wasting your time, I'm perfect for you then.
Okay, can we take a break from wasting time and not waste time for a little bit?
Well, if you don't want to be religious, tell me you don't want to be religious and I won't waste time.
What are you talking about? Okay, look, if you don't, then I don't know what to do with you. Look, do you have?
All right, I'm going to put myself on the chopping block. From my religious perspective, I think the Spirit of the Lord fills the immensity of space. It is just so fine, refined, and pure that that science cannot measure that.
I don't care. Let's talk about.
I just told you my vanilla thought about the universe.
I don't care about
and
your
stuff. Does travel through it.
I don't care about.
Sea Lion Prime, thank you, but I don't need hailing.
Okay,
I'm not that pure.
All right. Okay. Do you want to talk about my ether theory or not? I don't like. Let's.
I thought we already talked about it. Is this from vanilla physics or non-vanilla physics?
My theory is
spicy physics.
My theory.
Oh, yeah, that's the best. What type of spice? Like super like 4 million on the Scoville scale, or less spicy?
Ghost pepper physics.
My theory of ether is completely vanilla. It sits beneath all of vanilla physics. Vanilla physics is based on my ether theory. My ether theory is the ground floor. And physics.
Wait,
physics? Mm-hmm.
Would Witsa agree with your ether theory? Or could he explain it to me better than you can?
Who?
Witsa.
Who?
Oh my gosh, I can't believe you don't know who that is.
Who?
I know you're not a flat earther, but you're in this realm. You should know who that is.
Geta?
Witsit gets it.
Witsit.
Never heard.
Witsit.
Never heard of him.
He's a big time flurf.
Never. I don't know any.
He hangs out in Earth Awakens.
Come on, Omni. Mr. Slave is not a flurf.
No, he's not.
He's a vanilla physics ether boy.
I understand. Yeah.
What's an ether boy?
It's a term for
Someone who hasn't grown up yet.
the ether cosmology guys.
There's, but
someone who's a baby, kind of not. He's past the baby stage of ether. He's more of like an adolescent. He's not quite an adult in ether yet.
Well,
am I catching on to you, Mr. Slave? There.
The ether boys is a term for the Shane, Alan, Toby, and weirdly Riggs continuum of flat earthers who believe in the electric universe and ether.
Right.
So why aren't you on ether cosmology right now? They would be, I'm sure, stoked to talk to you about ether.
They kicked him.
Anyway, I'm not a flat.
I'm just trying to measure the level of your etherness. Like, are you like a baby level, an adolescent, teenage, or an adult level in this ether theory?
He's over 9,000.
But I have nothing to do with flat earthers.
That's pretty spicy. I know. I'm not saying you are.
No, but from what I just understood about the spectrum of the flat earthers, they're all, I mean, the spectrum of the ether boys, they're all flat earthers.
Well, yeah. I mean, they're kind of explaining ether the same way you do. We're not saying you're a flat earther, but you explain it kind of the same way they do.
How's that possible? How can a flat earther explain ether the way I do? How is that possible?
Because the way you're explaining it, I've heard from flat earthers pretty much the same thing.
How? I'm a vanilla physicist. How? It doesn't fit. I believe in SRGR and quantum mechanics. As my ether is the foundation of SRGR and QFT. What are you talking about? How are they related to me?
Information.
What?
They steal information and rewrite it as their own, sort of.
I have nothing to do with them. I don't know anything about them. I don't want to know anything about them. Do you want to talk about my ether theory as the foundation for SRGR and QFT?
Yes, but only if it's vanilla.
Yes, it's vanilla.
All this vanilla talk makes me want to get ice cream.
Get ice cream. So you don't want to talk about physics? You just want to talk about nonsense?
I mean, you're kind of speaking nonsense, but No offense.
Yeah, bye. Okay. No offense, no offense. Go to hell. No offense. Don't waste my time. That's all they got. Waste of time, waste of time, waste hours and hours and hours of waste of time. Okay. All right. Very interesting. So, so this notation now becomes much more understandable than last time around. Very good.
You have to do this for all values of n. Here, I'm only having 2 dimensions, but however many dimensions you have, you need that number of terms. And I'm going to call that equation number, I hope you can see that, let's just write that again, equation number 1. And I'll put a box around it, so that when we refer to it later...
I'm going to just text. What's his name? Let me just go back.
I was here, Lael. I was trying to stay awake. Thank you. Yes.
You're welcome. What do you think of vanilla physics?
I think that
Mr. Slade is back.
Yeah, I just, if I may just make one short announcement. Everyone, please don't waste my time. Please, like, don't invite me.
Nobody cares.
Don't waste your vanilla time or your regular time.
Just don't waste my time, please. I'm not asking
Vanilla
for much.
time or chocolate time?
I was thinking maybe we need some of that mint chocolate with the little chocolate chips in the
Oh,
mint
that's
flavor.
really good. That's my favorite.
That's
ice
the
cream
best.
dressing.
mint and chocolate have no business being together at all.
Yeah, they do.
No, they don't. It's like fucking eating toothpaste, bro. No
Exactly.
thanks.
Thank you. Yeah. Go gargle
Vanilla
some.
toothpaste or non-vanilla toothpaste?
Thank goodness Lael's here with the vanilla jokes.
Look, all
Well,
I'm,
You
I'm
should
kind
keep,
of not
you
joking.
should
I'm not
keep saying
joking around because I mean, Mr. Slave is all over the vanilla physics.
look.
Yeah, why don't you ask him how vanilla it is, and then that way y'all can have a conversation about it, and that way you don't have to just keep.
He already
mentioning
did.
it, you know?
He believes everything any physicist says just because they say it.
Look,
Because it's vanilla.
all I'm saying is,
Or no. Ask him about his ether. Sorry, it's ether.
look, all I'm saying is, please don't invite me to conversations that are a waste of my time. Please, I'm not asking for much. Just don't invite me. I'm not interested.
How
Can I ask
know
you, you
conversation
think
with
the globe Earth is surrounded by ether?
I think the universe is immersed in ether, and the Earth is immersed in ether. The sun, all the galaxies. The ether is the ocean, is a very deep ocean in which all the galaxies that we see, they're just basically, you could say, floating in this ether.
That Earth's still a ball? Like,
Yeah.
and space
I'm a
is
normal. I believe in physics. I'm a normal physics guy. I never heard of flat Earth until I came into this space. I don't care about flat Earth. I don't care about cults, religions. I'm a normal person. I don't know what you guys keep on and on and on about nonsense. Like,
So can I ask, do you believe electromagnetism instead of gravity? Is that a part of the ether?
no. Electromagnetism is a wave in the ether. Gravity is the flow of ether. It happens to be that ether is the same mechanism for both gravity and quantum physics and quantum mechanics, and quantum particles and quantum waves are light, which is EM, which is electromagnetism. So it's all so the ether gives you everything. The ether gives you special relativity, general relativity, and quantum mechanics.
So, may I ask you a question? Are you confused now more than when you first asked the question?
Yes.
So,
Sorry.
so ask me. You're welcome to ask me more questions. I don't want to confuse you. I'm here to answer questions. So, trouble about
It's okay. I'm not an expert in space.
Oh,
And all the stuff.
you're only here to
about.
answer specific questions, Mr. Slade.
So trouble about. Can I ask you a question?
Yes.
Do you know why the apple falls from the tree?
Well, gravity, I'm told.
Right, but what causes gravity? Gravity is just the name. Gravity is just the name for the phenomenon that we notice that apples.
Who cares what causes gravity for this discussion?
Right. So
I mean, it's heavier than everything around it, so it's going to go down.
I know the answer. The answer is ether.
Ding, ding, ding.
Yeah, except you've never shown any evidence of this ether other than to.
No evidence required. You only need an answer. That's all you need.
The answer is in the evidence.
Oh, it's ether. Gravity, ether. Electromagnetics, ether. Speed of light, ether. It's magic shit. It does amazing stuff for flat earthers. Whatever they need to do. Whatever they.
He's not a flat earther. He believes in vanilla physics.
Oh, okay, whatever he is, he's a conspiracy Feels theorist. triggered
already. Unbelievable. Who knew?
He might as well be a flat earther.
That's a little unfair.
You know what? I think we should set up a debate between Mr. Slave and Pete Shea.
Oh, no. So,
See who confuses who first.
I think Pete failed the don't Discord drunk test.
But that's not the point of this debate. The point of this debate would be who confuses who first.
You know, Mr. Slave, if you really had this theory of everything, you should write it up because you'd be like more renowned than Einstein.
From what I understand of Mr. Slave, he's not in this for fame. Am I reading you there correct, Mr. Slave?
Look, guys, ether. You believe him or not?
Ether or.
I mean, it's really cool. I mean, people have been searching for a theory of everything for 60 years now, 70 years. I mean, supposedly the string theory guys have gotten close, but they have no evidence either. So, I mean, why not? We'll just call it ether and everything works.
So, hey, NORAD.
Yes, it's a very complicated word. Yes.
So if I'm staying at the center of the North Pole, I assume you agree
You're
that
freezing
the
your ass
equator.
off. Oh, sorry.
Well, I'm just go with me here. I assume that you believe that the Earth has an equator, right?
Parts. No. It has the most accurate, actually, in relation to a geographic coordinate system. Like a geographic coordinate system, you would never use to make actual, like, metric measurements. They would never make sense. I know. Well, it's a complicated issue. It's like you need to have very deep knowledge of GIS. Like this was something I struggled. You don't. I mean, I can point you to literature and maybe some videos if you'd like.
Okay, so you just claimed that you can't make a you can't like measure distances, or you wouldn't make measurements on a geographical coordinate system.
Yes.
But
Yes.
if you
They would be
you
off.
decided to do that, you could just use the Haversine function and you would get distance accurately.
So you wouldn't be using a geographic coordinate system.
You would. You'd use the longitude and latitude. You'd use the longitude and latitude of the geographic coordinate system. I just I don't understand what the because it's clearly if you were to use the projected one that you wouldn't be able to use that for accurate distances. You could
Okay,
at like
so
extremely close range.
okay, let me ask you this. Do you know what like the WGS 84, for example? Do you know this coordinate system?
Yeah.
WGS 84.
Yep.
Yep. Is that a geographic or a projected coordinate system?
We just went over that. You said it was a geographic one.
Well, I'm asking you.
Yeah,
I
but you
could be
asked me
wrong.
before, and then you told me it was a geographic coordinate system.
Yeah, I'm
Using
testing
longitude and
you.
latitude.
I'm testing your
We already
understanding.
went over this. You already
Okay,
said to
sure.
me before after
Sure.
you've asked me this question.
Okay, so UTM. Do you know what that is?
Yeah,
UTM.
that's another one. Yeah,
Universal Transverse Mercator.
that was
It
a
is a
projection.
projection of the WGS 84. It's a projection. Do you understand?
Yeah.
Do you know what UTM is?
You just said it.
Bro, you gotta like keep on going. Just like make your
No,
point.
but really, no. I explained it in words, but in actuality, what is UTM?
Universe Transverse Mercator. It's a
Yeah.
projection of GS 84. Now, just make your point, man.
Okay.
Rolling the
So. Okay. So. If I have a map, for example, right, and I've got.
Well, I mean, I did too, but you came in here after me.
Yeah, and you called me out, right? You called me out specifically.
Yeah, I wanted to ask you a question because I looked at your moniker and it says you're a flat earther, and I didn't want to. I didn't
choose. I didn't
straw
choose.
man
That was
your
already
position.
pre-set up. Yeah, that was already
He
pre-set up when I
is
joined
he
the
is
server.
100% a flat earther. He's just the flat earther kind that calls it a globe.
Well, that wouldn't be a flat earther, would it, Omnivore?
No. It turns out it's actually a thing.
Yeah, turns out you're lying.
It's a pretty
turns
stupid
out
thing.
you're lying because I'm not a flat earther.
Do you think that all plumb lines are parallel?
No, but I promise you, you can tell me more about flat Earth than I can tell you about it. I promise you that.
Yeah, I can.
Yeah. So what does that make you, a flat earther?
No.
So you're a flat earther then.
Because I know that I know that.
So based off of your logic, because you know more about this fake subject, that makes you the flat earther, not me.
No,
correct?
that's not my logic.
Oh, okay. So it's a goalpost moving logic that you have.
It's not no, neither that. What
Right.
it is
Say
that
no.
I know.
What's going on? Mm-hmm.
Third, hope everybody's having a fantastic week. I'm in going to see doctor's mode and prep for the surgery that I'm having on my shoulder next week. I spent most of the day today at the hospital just doing all kinds of procedure stuff. God, hospitals are very, very good at wasting one's time. But anyway, I'm not excited about the surgery, but I'm excited about getting my shoulder fixed and being able to go back to full mobility and pushing weights and all the fun stuff, all the exercise fun stuff that I can do once the shoulder's fixed. All right, let's see. Today we're going to talk about, I'm going to give you an update on what's going on in Israel, Lebanon, a bunch of stuff about the expected retaliation, Israel's expected retaliation. We call it a retaliation. I don't know. The tit for tat against Iran, where that stands. We'll talk about the port strike, breaking news just like 5 minutes ago. The strike is off, but we'll talk about that. Floods in North Carolina. You've seen some of the pictures. Pretty dramatic. And then there's the January 6th. Jack Smith report that came out yesterday, a month before the election. Interesting timing, but also interesting content. Really interesting content. Anyway, that's where we are. That's what we're going to be covering. We should, and of course, a reminder: you can shape the direction of the show by asking questions. The more questions, the better. The more using Super Chat going on in Israel, and there's of course a lot going on. And you can ask questions. So let's start off right off the bat with what is going on in Israel, and there's of course a lot going on. Everybody is still waiting to see what will be Israel's response. I mean, I find this way of fighting a war, I don't know, pathetic and ridiculous and a little suicidal. If you can be a little suicidal, can you be a little, I don't know. It's just insane, and it really is driving me crazy. You know, what is the point? What is the point? Clearly, Israel and the Iranians have been in a war now for years, many years. You know, they keep having ceasefires, they keep stopping, and Iran has used proxies. Israel has fought much of the war covertly, but now twice Iran has launched hundreds of missiles towards Israel, which if they had been allowed to just land, it would have caused hundreds, if not thousands, of casualties. I just don't understand it. This is exactly the point. Maybe this was the point a year ago, or 2, or 5, or 10, to end this. It's not an issue of retaliation. It's not an issue of you kick me in the shins, I'll kick you in the knee, and then you can kick me in the thigh, and I can kick you in the balls. No, this is a bullet to the head. This is war, and war needs to be ended quickly, thoroughly, systematically. So no matter what Israel does in the days to come, it could be weeks, I don't know what they're thinking, it's not going to be enough. It's not going to be justified. Israel needs to unleash hell on Iran. It needs to destroy as much of its nuclear capability as Israel can, assuming Israel can't get everywhere because of the depth at which some of these facilities are at. Fine, leave them, take out everything else. Israel needs to destroy, again, to the extent that it's capable, the ballistic missile launching capabilities of the Iranians. It needs to destroy as much of the Revolutionary Guard as it can from the air. And it needs to completely debilitate the Iranian economy by taking out as many power plants, bridges, and of course, the oil fields and oil facilities in Iran. And it needs to do all that yesterday. And every day it waits is less effective. Every day it waits, more international pressure against it doing anything will accumulate. The more it waits, the more hesitant it looks, the weaker it looks, and so on. It's bizarre that Israel did not have a detailed, systematic plan on exactly how to respond to the latest ballistic missile launch. Of course, they shouldn't have needed to wait to respond. Now, the only excuse I can think for Israel right now is, the only excuse I can think. So they had the plans. They should have had the plans. They knew exactly what they needed to do. They know where they send their planes. They know what the targets are. I don't know why the night the missiles rained in on Israel, the planes went in the air and on the way to Tehran and on the way to executing the mission. Now, there are a few possible explanations here. 3 of them. Only one good one. One, Biden really squeezed the Israelis. Really squeezed them. We'll get to Biden, back to Biden in a little bit. But really, I don't know, threatened them with no more munitions. Something devastating that they just couldn't, ignore. 2, probably the likeliest. This is consistent with their pattern with Bibi Netanyahu, just hesitating and waiting and chewing and talking and discussing and debating and asking Americans over and over again, are you sure what you want? How do you do it? For a long time before new, dramatic, significant action is taken. The third option, which is the best option in the sense that it explains this without making Israel and Americans look like complete losers, is the possibility that Israel just has higher priorities right now. That is, its airplanes, it has limited capacity in terms of Air Force and intelligence and reconnaissance and everything else. It is right now engaged in 2 ground wars, one in Gaza and one in South Lebanon. And it is engaged in, bombing campaigns, so that is Air Force activity, both in Gaza and in South Lebanon. And importantly, it's engaged in, Air Force activity, significant Air Force activity, all over Lebanon, including Syria. There have been a number of bombings in the Damascus area. And then for the first time, really interesting, they bombed a part of a naval base in Syria, in the northwest of Syria on the Mediterranean. A base that is mostly dedicated to Russian troops, facilities, equipment, and navy, jointly operated with the Syrians, but a very, very heavy Russian presence. Now, Israel did not attack that part of the port. They attacked the part of the port that had Hezbollah and its allies' presence. But wow, Israel got very close to a significant Russian presence in Syria. I mean, one of the reasons Russia intervened in the Syrian civil war and intervened on the side of Bashar al-Assad was in order to preserve its base in Syria, which is its base in the Mediterranean, which allows it to project some naval power, not that it has much, but whatever naval power it has, into the Mediterranean in Syria. Well, Israel attacked part of that port. Again, not the part run by the Russians, but that's about as close as Israel's bombed, a Russian facility. And then finally, and this is, Israel has been pounding, just pounding, southeast Beirut, whether it's the area around the airport or whether it's the Shiite neighborhoods, the neighborhoods dominated by the Shiites and Hezbollah, all over the southwest. They are telling the buildings that they're going to bomb to evacuate, and then they're going in and destroying those buildings. In the most meaningful attack in Beirut, I mean, they didn't attack all over Beirut, primarily in the south, in the Hezbollah areas, but in the most meaningful attack in Beirut this evening, Israeli airplanes hit 3 high-rise buildings with a bunker underneath them, at least the size and the depth of the bunker in which they killed Nasrallah. It's hard to tell how many bombs Israel leveled at this place in order to completely and utterly destroy it. We're talking about an incredibly deep bunker. They probably used something like 80 bombs to destroy 80 from airplanes to destroy the bunker Nasrallah was in. They're probably using something similar tonight. Now, we'll get to why they're doing that in a minute. But you can imagine that with that kind of focus for the Air Force, that kind of focus of using heavy bombs, the Air Force is just too busy right now to start another front in Iran, to travel 1,000 miles to Iran and execute missions over there. And even if they do that, it's going to be very hard to execute on the kind of intensity that they're doing in Beirut right now. There's 80 bombs. I mean, they can do that relatively easy here because there's no air defense systems, or there won't be any over Iran either, really, to speak of. But more importantly is, Lebanon is like a 5-minute flight from Israel. It's just right there. Iran is a significant flight. It's not easy. It's going to require refueling, but it's more than that. It's going to require these bombs to come back and load up on bombs and fly out again. So it's way harder, way harder. And maybe they're just waiting until, in a sense, they're finished with Beirut. They're finished with the big assignments in Lebanon before they take on a riskier, trickier, more difficult, logistically and in every other sense, assignment over Iran. So, again, hard to tell exactly what is causing the delay in Israel, but I suspect it is just they're busy. And Israel has, unlike America, which has really, for all intents and purposes, at least, with the exception if they go to war with China, but at least in every other region, for all intents and purposes, the United States has no limitation on resources. It has enough fighters, enough bombs, enough aircraft carriers, enough Air Force bases in the Middle East to be able to pound Iran into dust fairly quickly with very little logistical challenges. Israel cannot do that. It is very, very difficult for Israel to do it. Henry says, will Israel warn Iran beforehand? Well, it already has, right? Israel's already told them we're going after these targets. Israel's already said, I mean, we know that Israel will tell the Americans, partially because the Americans will know anyway, because it's crossing kind of American-controlled airspace, Saudi airspace, Iraqi airspace, where America has a presence. And as soon as Israel tells the Americans, the Americans will tell the Iranians will leak it in a second, right? So Iranians will know when it's coming. One question is, why is Israel trying to destroy this underground bunker? It's already killed Nasrallah. What's it trying to do? Well, the belief is right now, and again, I don't have all the data, I don't have all the information, but at least from sources that I am reading, that I am hearing from, there's every reason to believe that in this bunker, in this very deep bunker, sits the new Secretary General of Hezbollah, Hashim Salifaddin. So Israel is basically trying to liquidate the new head of Hezbollah like a day after he was appointed. And I think that will send an incredibly powerful message. You appoint them, we knock them off. You appoint them, we destroy them. And if we need to drop 80 bombs in order to get deep into your bunkers, we will. And we know where you are. You cannot hide from us. But you think your bunkers are secure. You think you don't have spies. But we know everything about you. We're tracking everything you're doing. We have, obviously, Israel has spies in high places, but it also has the kind of electronics surveillance where it knows where they are. Now, it is a little bit bewildering, and this is typical Israeli, right, that they let the residents of the buildings know to evacuate. How do they know that this guy didn't evacuate when the building's evacuated? You think he would. Maybe they were waiting for him outside. I don't know. I mean, you don't usually let them know when you've got a high-value target to destroy. So it'll be interesting to find out if at the end of the day they really do get Salifaddin, who I hope they do. I hope he dies another slow, agonizing death at the depth of the bunker. But we won't know probably until later tonight, unless it's breaking news, or maybe even only tomorrow. But that is assumed to be the target of the comments attack. Let's see. What else do we want to say here about what's going on? Yeah, I mean, what is there to say about the Biden administration? I mean, they are such cowards. They are so just disgusting. So here's Biden today getting on a helicopter, G7 something meeting, and he's asked, "Will you support Israel attacking the Iranian nuclear facilities?" And Biden, instead of ignoring it or not answering or being vague and ambiguous, which is what you do if you're a second-rate politician, he comes out and says, "The answer is no." No, he will not support Israel attacking Iran's nuclear facilities. He says all 7 of us, G7 nations, agree that they have a right to respond, but they should respond proportionally. Now, what does responding proportionally mean? Well, they launched 180 ballistic missiles, and only, let's say, 20 landed, and they didn't kill anybody. So you should, since you have a 100% hit rate, you should only launch 20 missiles, and you shouldn't kill anybody, or maybe only kill one person. That's proportionality. I mean, this should make your blood boil. This is Christian turn the other cheek. This is love your enemy. This is it is just the most horrific way of dealing with an enemy possible. And why not take out the nuclear sites? Why not? because Iran will be upset if they do. I mean, by some rumors, the administration, I think Biden actually said that it was okay to strike the oil fields, the oil facilities, but not the nuclear sites. Doesn't make any sense to me. By the way, oil today, because he said that a barrel of oil today went up 5% in the markets in anticipation that Israel will actually do that because Biden's encouraging them to. But why do that and not the nuclear? What is the logic there? This guy is bonkers. I mean, first of all, I don't know who knows who's running American foreign policy because clearly not Biden. He's just not there enough. Just watching on television, answering these questions. But how could this be the pressure America's putting in Israel? And how can 180 ballistic missiles after last time they launched 300 and Israel launched 2? How is this possible? I mean, this administration is, when it comes to foreign policy, with the exception of Ukraine, the most cowardice, pathetic, administration I've seen. It is just being absurd and ridiculous. And there's no reason to think Kamala is going to be any better. Indeed, there's every reason to believe she might be even worse. I mean, don't bomb the nuclear facility. And be proportional. The point in war, good versus evil, is for the good to be disproportional. For the good to basically annihilate. I mean, destroy. I don't mean annihilate the people. Destroy the regime of the evil as quickly, as effectively as possible. And Iran is just ready for this because the people don't want this regime. And the only reason it's not happening is because the Biden administration and the G7 nations and the West more broadly are unbelievable, unequivocal, pathetic, altruistic cowards. Cowards. And the people who suffer are the Israelis and the Iranians. And the rest of the West will suffer too in the future. You could argue they already are with the Muslims, the Muslims within their countries. The tougher Israel is, the more unequivocal its victory is, the more pacified the Muslims in Europe will be. God, I mean, this is so anti-American. It's so non-American. It's so, French. Let's just surrender. That's what Israel should do. Israel should just surrender. To win, but why even bother? It's wrong to win. It's immoral to win. It's not practical to win, according to the pragmatists. So why Israel should just surrender? Yeah. By the way, Iran has another 3,000 ballistic missiles. It launched 180. Has 3,000 left. A good target would be. Those ballistic missiles, destroy as many as you can. A lot of them are deep in the mountain, but they can get a lot of the launches. They can also start hitting the missiles before they're launched in a preemptive way. Instead of waiting for the missiles to be in the air, Israel could probably destroy them on the ground. But they have to get away from this Christian ethics in order to do that. They have to get away from the Biden administration ethics. So you might be saying to yourself, yeah, Iran, look, I mean, this is an argument to vote for Trump. And maybe it is. Trump is about as horrible. No, he is the most horrible presidential candidate in history. But look, in Israel, Iran, this looks good. So Trump took a question from the press about Iran in Milwaukee. I don't know if it was today or yesterday. Maybe it was yesterday. And his answer is so disgusting that he just proves over and over again, even when he has the opportunity on a particular issue to stand out and to clearly differentiate himself, he is such a disgusting human being that he just cannot. So, and a reporter asks him, and look, I listened to this because I didn't really believe what I read. I actually had to listen to the actual comments. And, I could play it for you. Should I play it for you? Let me do this. Let me put it up on screen so nobody can accuse me of misrepresenting what Donald Trump is actually saying. Let's do live here while we're at it. Let's do an actual capture of this. All right? Why is this not working? Oh, I blocked it. All right. Give me a second. There it is. Right there. Yeah, can't really make it bigger. No, won't go bigger. Got there. We're going to press play. Okay, so this is him answering a question.
Had launched ballistic missiles in 2020 on U.S. forces in Iraq, leaving more than 100 U.S. soldiers injured.
So, first of all, injured. What does injured mean? Injured means you mean because they had a headache, because the bombs never hit the fort. So,
can you believe that? So, did you guys hear that? Somebody says increase the volume. I don't know if you could hear that. I mean, the disrespect Trump has for his soldiers, for the people who are fighting. What do you mean injuries? They got headaches? Because bombs never hit. I mean, again, proportionality. They didn't hit, so I didn't respond. What if they had hit? I mean, this guy is just he's a disgusting human being. He is an idiot because even a disgusting human being should realize that that's just so unbelievably stupid to say. And of course he goes on to say, well, I cut off their funding and they didn't have any money. And he even there lies. He says, I got out of the thing a week after I was inaugurated, which is not true. It took until 2018 for that to happen, so about a year plus before he got out of the Iranian deal. And Biden, took away the sanctions. because that's true. But can you imagine the commander-in-chief saying, "Oh, those ones seriously injuries, they just got headaches. So I didn't respond. I didn't attack you on because they just got a headache, and that's not a big deal. Let's not get too excited about a headache." Okay, which one of these monitors is somebody in the picture? Shouldn't be in the picture. That's better. And it's just, I mean, there's no point in commenting on it because what can you say? He said it. He said it. So, look, when it came to Iran, Trump getting out of the nuclear deal was a good thing. Trump putting sanctions on Iran was a good thing. Trump ordering the execution of Soleimani, the head of the Iranian Revolutionary Guard, was a good thing, the Islamic Revolutionary Guard. But that's about it, and it's all pretty lame. Given how many attacks the U.S. suffered from Iranian-linked groups, given the continued development of nuclear weapons and Trump's and others' commitment that they would never get any, given headaches that our troops suffered from bombardment, of course the United States should have hit them hard. I mean, Trump was a wimp when it came to Iran. And the killing of Soleimani was like a one-off, so you could trek around and say, I got Soleimani. I mean, just like Israel's discovery, you can't just eliminate one guy and anything happens. I mean, if you want to eliminate the leadership, then you have to do it the way Israel's doing it. You have to eliminate the entire leadership, including the guy who was number 2 now becomes number 1 within less than a week of killing number 1. By the way, you notice that in Nasrallah, that Hezbollah has not had a funeral for Nasrallah. I mean, this was supposed to be the funeral of the century, given how important Nasrallah was. And there's been no funeral, no big thing, no big event. Because of what is going on, because the leadership is afraid to stick their nose out of a bunker because they might lose the nose, and the rest of the with it. So anyway,
that's funny.
I wish, I have wishes that we had an option to the cowardly, pathetic, immoral, foreign policy of Biden. But the reality is that, maybe on some narrow issue, Trump might be better, but on broadly, he's just a nut. And he's a disgusting human being who does not deserve to be president. So, let's see. I mean, the crater that the Israelis have created at this complex bunker is truly amazing. It does sound like several officers of the Quds Force of the Islamic Revolutionary Guard, that's from Iran, are believed to have been eliminated by tonight's Israel airstrike on the Hezbollah bunker in South Beirut, which contained a meeting being held with the new Secretary General of Hezbollah, Hashim Salafuddin, and several other senior Hezbollah leaders. So Then not only did they get rid of Salafuddin, and not only did they get rid of a number of Hezbollah leaders, they also got rid of a number of the Iranian Islamic Revolutionary Guard agents who were there to coordinate with Hezbollah. So Israel is just doing a systematic job right now of, just wiping these people out and cleaning house. But the horrible thing is it's getting minimal support from the U.S. One more thing, before we move to another topic, to basically the VP debates, I think we should always, I try when I talk about war always to do this because I think it's important to remember that there is a real cost. I mean, a necessary cost, but a real cost to this war. Whether it's necessary or not is a question. But yesterday, or this morning, I can't remember when it was, Israel announced that 8 soldiers were killed in South Lebanon, basically in the same operation. They were ambushed within a house that they were clearing in a southern Lebanese village. I think they took another casualty today. So another casualty today, so that's 9. When I noted this, noted this when we talked about some of the casualties in Gaza. 3 of the 9 were officers. I mean, not the most junior officers, fairly senior officers. I don't know how to compare, ranks to kind of an American rank force, but 3 of the 9 were officers. All of them were young kids. And I couldn't help when I read about these kids dying. And look, I've talked about this before. The Israeli soldiers are unbelievably brave and unbelievably courageous, and they're doing an amazing job. But I kept thinking when I read about the 8 who were ambushed, that if Israel were willing to just flatten these villages, I mean, to turn them into parking lots, then they wouldn't be ambushes. And indeed, Hezbollah would not be able to hide within the buildings. And there would be a lot fewer of the Hezbollahs. They would be wiped out with them, and maybe some of the tunnels that are in these homes and some of the munitions that in these homes would also blow up and explode and leave them poor. It seems to me that Israel has already asked the civilian population of southern Lebanon to evacuate, and hundreds of thousands of them have evacuated. They're gone. I don't understand. Why not just flatten these buildings? Why let young kids go in there? Some of these buildings will be trapped. Some of them, they are ambushes. Some of them have tunnels where the terrorists can jump out of the tunnel. It just seems like if it wasn't for kind of just war theory, proportionality, the whole ridiculous notion of fighting a war in sacrificial fashion, that Israel could do the job it needs to do in South Lebanon with a lot less casualties. I mean, the whole area of South Lebanon should be carpet bombed. Again, they've asked the civilian population to evacuate. Just flatten the place. There's still going to be difficult battles because it is hilly. There are valleys, there are ravines, there are tunnels, there are all kinds of things. It's not going to be easy, but at least take out the simple stuff. But this is Israel fighting, based on the Christian standards of turning the other cheek and being nice to your enemies, something that's learned from America. One of the reasons America has not won a war since World War II. And it is executing on that strategy, and it is suffering the casualties. And the people who suffer the casualties are not the philosophy professors and the academics who come up with these moral codes and moral ideas. And there's a specific Israeli intellectual who was involved in writing the manual for the Israeli military force that I'm thinking of. He's not going to suffer. His kids might. His grandkids might. He won't. Israel can still win, but young kids will die for no reason. But anyway, I want to always remind us that while we celebrate Israel's victories when they happen, they are happening at the same time. There are real casualties here.
All right. Let's get back to this guy. All right, so this is very straightforward.
You'll be able to spot it. Now here comes the general problem with relativity, be it special relativity or general relativity. Any rules that you come up with must be independent of the frame of reference that you're using to make the observation. In my videos on special relativity, which I will refer to during the course of this presentation, we show that different observers measure different distances and different times depending on their relative velocity. That was called length contraction and time dilation. So if you want to have something that is going to be universally true, you have to make sure that it is true in all reference frames. So when I took my field, where I was standing on the hills, and I put myself at position P, I set a coordinate system, which I call the XY coordinate system, but subsequently renamed X1, X2, and I said that was my map reference, X1 and X2, define my position. But somebody else could come along and create another set of coordinates, which we will call Y1 and Y2. And now P, of course, I haven't changed my position. I'm still standing on the hill at position P. But as far as the Y frame of reference is,
So this is difficult to understand, but this is the coordinate system where the terrain is.
concerned, the coordinates are quite different. Y1 and Y2 are quite different from X1 and X2, even though I'm at the same place. And you'll notice.
But it doesn't have to be that Y1, Y2 is at 0, 0. It could be completely somewhere else. Like the 0, 0, the origin of Y could be somewhere in the space of X. So why don't you assume that it's the two coordinate system are completely decoupled?
Is that if I want to
Why are you coupling them at the origins?
express Y1 in terms of X coordinates, I have to express it both in terms of an X1 coordinate and an X2 coordinate. In other words,
This is the Y1 expressed in terms of X. So all the Y's need to be like, what's the point? What kind of conversion are you looking for?
Y1 position for my point P.
So P is expressed in Y and is expressed in X, but now you're saying that the expression in Y can be expressed in X.
Is actually made up of an X1 and an X2. So the question then that
So you can express the Y's as X's.
we have to come up with is if I know all the gradients, which remember we described as d phi by dxn, in the X frame of reference, how can we find all the gradients in the Y frame of reference? And more to the point, how can we relate the two? And for this we...
Okay, so you want to be coordinate independent. So you need to be able to convert from X to Y, from Y to X. So given X, you want Y. So given a function phi in the X coordinate system, what's the conversion to Y? So, right, so you take P, that's a good idea. You start with a P and you map. So the coordinate, why do you care? You want, so given phi at X. So for example, right, this is X and this is X. This is X1, X2. This is Y1, Y2. You want to have a conversion from X to Y. So given X, given a function X, phi of X, let's see what he says.
Can we find all the gradients in the Y frame of reference? And more to the point, how can we relate the two? And for this, we use what's called the chain rule. We say that d phi by dy, and I'm going to pick the Y1 coordinate. You could pick Y2, but I'm just going to pick Y1. That is equal, now according to the chain rule, that's equal to d phi by the x1.
But you have to explain. What do you mean? So you're saying d phi by dy of n, let's say 1, is d phi dx, but you have to explain why you're doing this.
Set of coordinates, which we will call Y1 and Y2. And now P, of course, I haven't changed my position. I'm still standing on the hill at position P. But as far as the Y frame of reference is concerned, the coordinates are quite different. Y1 and Y2 are quite different from X1 and X2, even though I'm at the same place. And you'll notice that if I want to express Y1 in terms of X coordinates, I have to express it both in terms of an X1 coordinate and an X2 coordinate. In other words, the Y1 position for my point P is actually made up of an X1 and an X2. So the question then that we have to come...
So given X, you want Y in terms of X? I don't understand what you're trying to accomplish. What is given and what are you looking for? Given phi in terms of x, you want phi in terms of y. So point P, and x is here, and y is here. So what I can but really what he's saying, give me y in terms of x. He's not saying give me x in terms of y. He's saying give me the conversion to y, but give it to me in x. He's never going to say it in terms of y.
Start with is if I know all the gradients, which remember we described as d phi by dxn, in the x frame of reference, how can we find all the gradients in the y frame of reference? And more to the point, how can we relate the two? And for this, we use what's called the chain rule. We say that d phi by dy, and I'm going to pick the y.
Okay, let's see.
One coordinates. You could pick y2, but I'm just going to pick y1. That is equal. Now, according to the chain rule, that's equal to d phi by dx1 times dx1 by dy1 plus d phi by dx2 times dx2 by dy1. So you notice we're only ever sticking to the y1 coordinate, but we sum over the x2 coordinates. Because remember I said that in order to identify the y1 coordinate, you need to know all of the other x coordinates.
Let's see. So d phi, give me the gradient of phi in the y1 direction. Well, we know it in the x direction. So here's the phi in the x1 direction. Here's in the x2 direction. And the x1 direction is related to the y1 direction like so. So you're saying that x can be expressed as a function of y. x1. This is d phi dx2. And this is dx2 How does d phi changes in the dy1 direction? Right, so really, since d phi is a function, right, all you know is the dx's. That's not true. You know two things. Given that you know d phi dx, but you also know dx dy. Don't say that you only know d phi dx. You also know dx dy, obviously. You know the relationship between x and y. That's why they have the same zero, zero, what do you call it? Origin. Because we're only looking for gradients. We're only looking for gradients. So d phi, so how does d phi change in the y1 direction? Well, all you know is d phi dx, all the d phi dy1, right? So the question is, by how much does the height of the terrain changes as I go along an arbitrary y1, the coordinate axis y1? Well, I don't know. I do know all I know is how phi changes when I walk along x1, and I multiply that by how much x1 changes as I walk along y1, because I'm walking along y1. So basically, d phi dy1, right? By how much does d phi change as I walk along dy1? Well, as I walk along dy1, I'm actually walking along x1 and x2. If we look back at the map, right, you're asking, this is incorrect. It's nothing to do with P. You need to show the map. You need to show phi. This is nice, but show us phi. Where's phi? Right? D phi dy1, right? There's some terrain. Show us the terrain, right? There's only one terrain in two coordinate system. It shouldn't be difficult to show a terrain in two coordinate system. And now you're asking, how does the terrain change at a point with respect to, or at a point when we walk along y1? Y1 is this direction. So I walk along y1. So you're saying, okay, as I go from P in the direction of y1, the terrain changes somehow. How does the terrain change? Well, I don't know, but I do know how the terrain changes when I walk along x1. I walk along x1 and I walk along x2 and so on. I combine all those changes. Okay, but as I walk along x1, you can see that I'm walking along y1 a little bit. There's a projection, right? x1, when I project it to y1, that's by how much. Right? As I'm walking along, this is the dx1 dy1. By how much am I walking along y1 when I walk along x1? So what is dy dx or dy1 dx1? Right? I walk along, when I walk, I'm walking along y1. Given that I'm walking along y1, what does that entail? That entails, well, I only know the function as expressed as x and x. I can only walk along x1 and x2. But you want me to walk along y1. Well, y1 is projected onto x1 and it's projected onto x2. So by how much does phi change as I walk along y1? Well, you need to imagine that in order to walk along y1, I'm walking along x1 and x2. There's some relationship between x1 and x2. So I need to add walking along x1 and walking along x2. Now walking along x1, anyway, this is coordinate transformation. I mean, when I look at the equation is simple. This is the chain rule. But this is because we define x1. x1 is a function of y1 and later we'll see y2. We don't care about that x1 is a function of y2 because we're not changing y2. The change in y2 is 0 when we're only walking along y1. Just wanted to tell him. His name is Lowell. Laeld.
And there are people fighting and dying and being injured and which is horrific. These are young kids. All right. Let us change pace and move on to the vice presidential debates. I didn't watch the whole thing. I have low tolerance for watching politicians. I read part of it and I've watched clips of it. But there are a few things that stand out, that I think are quite memorable, if you will. First, they behave like adults. When Trump gets on a stage, the behavior and rhetoric and intellect of everybody up on stage, their level drops by, 40 IQ points or something. Or maybe IQ is not the right way to think about it. It drops in terms of maturity. Everybody becomes dumber. Everybody becomes childish. Everybody becomes emotional. And you don't have a choice, because if you don't, then you get just steamrolled by Trump. And they're all middle schoolers at best, 5-year-olds at worst. Trump and Waltz were adults at least. They talked about issues. They were mostly calm, thoughtful. Well, let's not exaggerate, but calm, completed sentences, had something to say about issues. So, there's no question that it would be an improvement if this was the way debates were handled, and it's meaningful, and will be.
Before Trump, it was only Democrats who used to attack Republicans. So finally, somebody standing up to Democrats. I don't know if I would behave that way, but, he's standing up. I don't know. Maybe it's good, maybe it's bad. It's just a fact. You never complain when the Democrats attack Republicans. But you only complain when Republicans attack back, and then you call it childish.
Interesting to see in a post-Trump era, whenever that happens, who knows when, if things change at the presidential level, or if Trump has established a new normal in American politics. Let's hope not. So that's one. Second, the debate showed, I think unequivocally, that Vance is everything I've always said he is. He's super smart. He can be articulate. He's sharp and quick. He might be the most dangerous politician in America. So, he's slick and sharp and quick. No question about it. Waltz is just a buffoon. Not an idiotic buffoon, right? But he's just not. He doesn't have it. He's just not as smart as Vance. Vance can run circles around him. Vance was confident and good at, not answering certain questions and ignoring them and weaving. And I think he came across well. I think if this is how he presented himself more often, he would be quite popular, which is what makes him so scary. I also think that what this vice presidential debate clarified, because Vance does a better job presenting Trump's ideas than Trump. So you actually get Trump's ideas with clarity and with a certain confidence and certainty, and without the hyperbole and the emotionalism and the freaking out and the craziness. You just get the ideas. So what you got was calamity around the fact that there is nobody in the American landscape right now, political landscape, who is even resembles an advocate of even a little bit of more free markets. I mean, Vance gave a convincing statist case for government intervention in the economy. He's done that throughout the campaign. He is as statist as Kamala is. He is as interventionist as Kamala is, if his interventions are going to be different. And it is a, he made it very clear that the Republican Party no longer is pro-markets. The Republican Party is no longer pro-trade. The Republican Party is no longer, has any even semblance of, even a little bit of capitalism. The Republican Party now is committed fully to the same kind of fascist socialist program as the Democrats are, with different coloring. And then on the foreign policy side, to Vance's credit, he takes a Trump line, let Israel do what Israel wants to do, we'll support it. But then when it comes to Ukraine, he takes Putin's side, which is the same. Of course, there was only one foreign policy question the entire night, and it was only about Israel. So we didn't really get them discussing Ukraine, which they should have. It would have been good. So it was, vice presidential debates don't really matter. Given that Vance has very, very high negative ratings, I'm sure this helped him at least somewhat, somewhere. But it doesn't matter. The reality right now is that this race is tied. It's a coin flip. It's going to depend on voter turnout in 7 swing states. You really start having to think about, and I know this is going to be very unpopular, but you really have to start thinking about, does the electoral college really make sense? That's a debate for another time. But
1 second, let me go get some carrots.
seven swing states will determine this election. If you live in New York or California, or Illinois, or a lot of other states, like 43 other states, your vote is probably not going to matter at all, one way or the other. So you've got basically a race in 7 states where the polling, basically all the polling is within the margin of error. Even in North Carolina, which would be a Republican state, it's within the margin of error. And it's truly, it truly is that these are the 2 candidates. One of them will be president. Nothing we can do about that. And one of them will be president, and that will be determined by a few voters in a few states. Something weird about it. Anyway, Vance is articulate and smart, but still has horrible ideas. And is, as we know, because he flip-flopped on those ideas, is quite a power luster. And he and Josh Hawley, I still say, I've said this for now 2 years, are the most dangerous politicians in America. They are super dangerous. They're super statists. And they would grow the state, and they would grow the power of the state on the right. And even though they might have some good ideas, Vance, about Israel, I'm not sure what Hawley's views on Israel are. The rest is so bad, it doesn't really matter that he's good on certain things. I mean, Hawley is much worse than Trump because Hawley is more radical than Trump on the issues. More radically bad than Trump on the issues. And much, much, much smarter and more competent than Trump in terms of bringing his ideas to fruition. All right, VP candidates, God help us. Somebody help us, thank God, it's not going to help us. All right, let's see. Yes, I was going to talk about a strike going into the after 3 days of strike and the shutting down of shipping on the east coast of the United States and the crippling of the U.S. economy. And what are we going to do here in Puerto Rico? We get all our goods by boat from ports on the east coast. Not only do we have to deal with the Jones Act, now we have a strike. Oh my God! And I was going to talk about just the evil, slimy, power-lusting, disgusting nature of Harold Daggett, who is like the chief negotiator for the International Longshoremen's Association, who I've watched a number of videos with, and just how, just the hatred of technology, the dishonesty, the power lust that he has, the willingness to cripple the U.S. economy for another few percentages of raise, just awful. I mean, he basically said, look, we're going to go on strike, and in the beginning nobody will care, but after maybe after a week, guys who sell cars can't sell cars because cars are not coming, no more cars. They're not coming in, they're not coming off ships. They might be out in the harbor, not coming off ships, and they start getting laid off. And the third week, he says, malls are closing down, can't get the goods from China, they can't sell clothes, they can't do this. And he says, look, everything in the United States comes on ship. We got you by the balls in a sense. So they all go out of business, and the construction workers get laid off because the materials aren't coming in, steel's not coming in, lumber's not coming in. They all lose their jobs. And he's saying this with kind of a relish. I have so much power over you. I can control you. And this is why unions never have any power, kind of power that they have, because these people are really powerless and evil bastards. Biden, before an election, is not going to implement Taft-Hartley, Taft-Hartley, which basically forces them, force the union members back to work because he's not going to piss union workers off before an election. Kamala Harris announced that she supports the workers in the strike, and that all happened today. And then this evening, like 3 minutes before the show started, I get a story from the Wall Street Journal that the strike is ended. Basically, they're cutting a deal with the ship owners and the port owners and whoever, and the longshoremen are going to get a 62% pay raise over the next 6 years. It's a pretty good pay raise, guys. Pretty good pay raise over the next 6 years. So not as high as longshoremen wanted. They wanted 70-something%, but not as low as originally the employers wanted, which was close to 50%. They got 60-something%. And they're going to go back to work, and then they're going to start negotiating about all the other terms of the new contract, including what I think is much more important than much more important than wages, and that is tech. That is, will they allow new tech into the ports, or will we be Luddites? And God, I mean, the stupidity of it is unbelievable. Just to give you an example, in Sweden, like socialist Sweden, Sweden is very heavily unionized. But the difference is, for whatever historical reason is, that the unions in Sweden are much more, they know economics. They understand that if you ban technology, productivity goes down and they suffer. I don't know why Swedish unions are more economically literate than American unions are. So if you ask a union leader in Sweden, are you afraid of new technology? This is from New York Times story. They will answer, no, I'm afraid of old technology. This is for the Swedish Minister for Employment and Integration. The jobs, quote, the jobs disappear. This is when you bring in new technology. The jobs disappear. And then we train people for new jobs. We won't protect jobs, but we will protect workers. Now, you can imagine a union having that mentality. We'll raise dues, we'll do all this, and we'll invest heavily in job training. And when you lose a job because of technology, and you will, we are committed to helping you train for your next job. Now, wouldn't that be just a beautiful thing if that happened? Now, I'm curious. Maybe I'll have to ask somebody. Maybe Johan Norberg, who's in Sweden. I'll have to ask somebody how the unions developed such a much healthier mentality in Sweden than they have in the United States. I just don't know. But here, we hate technology. We will cripple the country. We will destroy everything because we hate technology. And in Sweden, the mentality is no. We love technology. We hate old technology. We want new technology because they know that as you bring in new technology, wages go up because productivity goes up, and it's opportunity to get retrained for the new technology. And they know that the new technology is going to take over anyway. That if not here, then overseas, and then you can't compete anymore. It truly is stunning how anti-life, anti-human these leftist unions are, and how disgusting it is that so many within this administration are supportive of it. All right, let's see. Yeah, so 62% over 6 years, automation to be decided in the future. All right, what do we want to say? Post-strike floods. I mean, not a lot to say here, but you've seen the floods in North Carolina, pretty devastating. Just amazing. The power's gone out. Dams have collapsed. Flooding everywhere. People have been killed, and it really has devastated the Appalachians, Southern Appalachians, and other parts of North Carolina. It's sad to see the destruction. Of course, it's because we lived in an industrial society that uses carbon fuels that makes it possible for us to survive such storms, and the casualties do not be dramatically worse. But it is still pretty amazing, kind of the devastation it can hit. One of the things I've heard is that most of the dams in the United States now are on average, I think dams in the United States on average 60 years old. They were built to last for 50 years. One of the things that is true in the U.S. and by the way, they just decommissioned a huge dam in the West. One of the really interesting things, because of the environmentalists, we have not invested in those dams. We have not made them stronger. We have not rebuilt them. We just don't do those kind of projects anymore. We don't rebuild. We don't maintain our infrastructure. We don't build new dams. So as the infrastructure collapses, the cause is not climate change. The cause is not some global warming or whatever. The cause is our unwillingness, inability to invest in beefing up and in replacing the infrastructure that we have. California is basically decommissioning all their dams. Again, this is, by the way, electricity. This is clean energy, hydroelectric energy, clean energy. But the environmentalists insist that it does environmental damage. So they're willing to let the earth warm, according to their theory. But the other kind of environmental damage doesn't get treated. So whatever. It balances out. It's just terrible. You'll see the left blaming these floods on climate change. I've seen many floods in my many years. I don't. Maybe there is climate change, and maybe the floods are going to happen in different places. Maybe it's raining more in some places and less in other places. Maybe the hurricanes are pivoting in a different direction. Because I don't know. I don't think anybody knows really. But I mean, there's been flooding forever, and there will probably always be flooding. Or at least there won't always be flooding because we should develop a technology that stops this and limits this. And maybe even a technology that manages to disrupt hurricanes so that they get less powerful, or maybe a technology that steers the hurricanes in a different direction. But the other story here, it's an interesting story, is that most people in North Carolina don't have flood insurance. And again, it's a complicated economic story as to why, but it has everything to do with the fact that the government has basically taken over a monopoly position of flood insurance. Because if you price flood insurance appropriately, then, and if FEMA didn't exist and there was no federal government assistance programs, then flood insurance would be fairly expensive because the risks are high, particularly in certain areas. But there would be competition, there'd be a number of flood insurance companies, and people would either buy them, and if they didn't buy them, they'd be wiped out, and they'd suffer the consequence. But the reality is that people who don't have insurance get bailed out by FEMA. So insurance companies find themselves in a situation where they can't sell flood insurance because nobody will buy it because they figure they'll be bailed out by FEMA. And certainly not for a price that is the market price for the insurance. That is adjusted for the risk involved. So private insurance companies leave the market. Economists jump on this, statist economists, and call this a market failure. And the government steps in to provide flood insurance. But people still don't want to buy it because why buy flood insurance when the government's going to bail me out even if I don't buy the flood insurance? Same thing, by the way, about earthquake insurance in California. There used to be, decades ago, you could buy earthquake insurance in the private markets. The risk for earthquakes has not gone up. But basically, all private insurance companies have left the market because everybody realizes in California that if there's an earthquake, FEMA will step in, the government will step in and bail everybody out. So why bother with insurance? As everybody left, the state of California entered the market and undercut whatever private insurance was left, so the rest of them left. And that's happened with flood insurance. Only the government supplies it. Nobody buys it. So FEMA is going to have to bail everybody out. It truly is economics 101. It's incentives, pricing, supply and demand. Nobody cares. They keep making the same mistake over and over again. Doesn't seem to matter. All right, that's the flood. Do you have anything else to say about the flood? No. Okay, so final story is so Jack Smith, the special prosecutor in the two Trump cases, in the document case and in the January 6th case, today filed a 180-page brief describing all of Trump's sins related to January 6th in an effort to make the argument that this is what do you call it? This whole case does not fall under the immunity because it's not part of his what you would consider his job as president, and that this should proceed to trial. Now, Jack Smith knows that if Trump wins, this case is dead. He's fired, and the case is dead. So, and he knows that if Trump loses, he can file the case then. So, there's no question in my mind that he submitted this 180-page dossier today, a month before the election, in order to remind the world of January 6th, in the hope that it would sway some voters. He would hope. So it is political. I think that's pretty clear. And I can't blame him, but it is political. But what the dossier actually says is factual. I don't think that's, that questionable in terms of what it actually says. And it's pretty damning. It basically shows Trump not caring, not doing anything to prevent the riot, not doing anything to try to protect the people who are in harm's way. When he's told that, Pence has to hide, is hiding, he goes, so what? He doesn't really care. He tweets at some point, right? Attacking Pence in the midst of the riot. He tweets from his own phone while he's alone. Nobody's around him. Personal tweet about how Pence is a coward for not doing his bidding, not doing Trump's bidding, in trying to, I don't know if overturn the election, but at least throw the election into complete mayhem. Everybody around him told him he lost the election. Everybody around him told him there was zero evidence that there was enough cheating to change the result. It didn't matter to him one bit. At some point, he is said to have told Ivanka and Jared Kushner, quote, "It doesn't matter if you won or lost the election. You still have to fight like hell." What the hell is that? They just invented stuff. A lot of these numbers that you know about non-citizen voting or this voting or that voting, just made up out of thin air, and they admit it. Right? So the whole thing. Right? He's making fun of Sidney Powell while she's representing him, and he's encouraging her to go out and continue the conspiracy theory BS. It's just, there's a call to Steve Bannon the day before January 6th, and talking about all hell breaking loose on January 6th. So, and then there's a bunch of forensic evidence that they would show in trial. So, this is to remind us that the President of the United States, whether he intended for a riot to happen or not, was quite happy that it happened, did nothing in his responsibility as commander-in-chief to stop it, to prevent it, that he relished it, celebrated it while it was happening, and put as much pressure as he could on the vice president to do something unconstitutional. And for 2 months, worked to pretend and to undermine the election, making it upset and causing a big chunk of the American people to believe that the election was rigged and could be rigged in the future. Which who knows what consequences for the future of this country. This is a man who should not be president. Put aside the issue, this issue, that issue. He does not deserve to be president. He's not qualified to be president. He is a danger to the constitutional nature of this republic, to the extent that we still are a republic. And Jack Smith did a little bit to remind us of that today by releasing the report. All right, I think that is the news for today, October 3rd. I've got some other items. We've got the first female president in Mexico crazy leftist, really, really dangerous woman with a lot of power because she has a supermajority in the Senate in Mexico. That's not good. Plus, she's committed to appeasing the cartels. What else do we have? One of the, yeah, I mean, real estate is still in trouble. Just a note that the Chrysler Building, the iconic Chrysler Building in New York, right, is there's one company that owns the land, and then the building is owned by a second company, and they lease the land from the landowner. Well, the company that owns the building is basically in default. They have not paid their rent for the land, and the company that owns the land is taking possession of the building. Just a little sense of kind of the real estate challenges that are happening in New York. On the other hand, new buildings in New York, the new office buildings that have gone up in New York, really high quality, state of the art office buildings, are full capacity. It's the older buildings that are going to be challenged to get the rent, challenged to get the occupancy, and it'll be really interesting to see what is going to happen to iconic buildings like the Chrysler Building as this real estate crisis continues, commercial real estate crisis continues in the United States. All right, we can close this window. Let's see. And says, wait till you see Harris in action. Yeah, I mean, I'm not looking forward to seeing Harris in action. She's a disaster. But yeah, she's in terms of character, in terms of disregard for the institutions of the American government and the system and election.
All right.
This can be summarized as defy by dy.
Mm-hmm. So how does defy change along the y1? So as I walk along y1, I'm walking along x1, x2. But the walking along x1 is a projection from y1. Same for x2. Like, what is the speed of walking through in the x1 direction when I walk in the y1 direction? And what is the change in phi as I walk in the x1? Okay, we'll come back to this. He's going to do y2.
And now I'm going to call this dyn because it could be any, it could be 1 or 2 in my two.
Okay, this is straightforward. And so this is just going to be n. And define the x1 dyn. But you want in any of the y's, like this is y2 now. This is y2, or this is n, this is n, this is n.
Two-dimensional system, and that's going to be the sum over m of defy by dxm times dxm by dyn. Now let's just look at this.
Defy dxm over m. Basically, it's the sum of these things. Defy dxm. Usually you don't say m, but fine. This is the counter.
And compare it to this. What I've done is I put the general value of n in for y. Here I just had y1, but it could have been y2. You have to pick which one you want. It's either 1 or it's 2. But m is a summation term. You sum over m. When m is 1, you get that term. When m is 2, you get that term. And this is going to be equation number 2, and I'll put a box around that as well. But let me just repeat and emphasize. N is the value you choose. It's either y1 or it's y2. You make the choice. But m is a summation term. You have to sum over all the values of x just to get one of the values with respect to.
You want to walk in the y1 direction. But the y1 direction exists in all the x's. So you have to take all the rates of change of x's with respect to the y's as you take the phi with respect to. So by how much does phi change as I walk in the y1? Well, when you walk in the y1, you're walking in the x1 somewhat. This is the somewhat. Is this always lesson 1? Oh no.
Why? Now I want to introduce you to the concept of tensors. We mentioned that when we looked at the Einstein field equations. There were several tensors. What is a tensor? Well, let me start off by talking about a scalar. A scalar is something that has magnitude but no direction. Temperature would be a good example of a scalar. It just has a value, 32 degrees centigrade. A scalar is what's called a tensor of rank 0. Now consider a vector. A vector, of course, has magnitude and direction. So it has a length and it has a direction, which is often described as the angle to one of the axes, in this case, to the x-axis. And a vector is described as a tensor.
A vector, magnitude and direction, it's a tensor of rank 1. This is a vector. It has a magnitude and direction. This is a tensor of rank 1.
Of rank 1. And how does a vector transform? Well, we can use equation 1 that we derived earlier, and which is showing on the screen, so you recognize it, and we just make a slight adjustment to it, so that instead of phi and...
It says equation 1, and he's showing 2 equations, or 1.5. Where's the number 1? So this is a transformation of a vector? So, by how much does the phi change? As I walk along, this is the total differential. By how much does the phi change as I walk along an arbitrary direction? And the arbitrary direction is defined by these dx's. These dx's, dx1 might be big, dx2 might be small. So this is the vector in which I'm going. And this is the terrain. So this is the change in the x1 direction. Well, but how much am I walking in the x1 direction? This is just the gradient. This is the walking. In the y direction, this might be the gradient, but or in the x2 direction, this is how much I'm walking. So what is the gradient? Well, you need to multiply it by how much I'm walking relative to dx1. Maybe dx2 is much bigger. So this was defined relative to an arbitrary vector that is defined by dxn. So dxn is the vector. We never noticed it. Dxn are the components of the vector. You can express this as a vector, maybe.
dx, we replace it by the vectors themselves. So we would simply say that the vector in the y frame of reference
What y? What?
and with the coordinate n, which we choose, is equal to the sum over m, where n is now the summation term, of the, as it were, gradient, which is dy n over dxn, where m is the summation term, times the vector in the x frame of reference, m. So that is the way in which we, and I shall call that equation number 3.
So what did he use? What's going on?
N over dxn, where m is the summation term, times the vector in the x frame of reference, m.
What's going on?
Case to the x-axis. And a vector is described as a tensor of rank 1. And how does a vector transform? Well, we can use equation 1 that we derived earlier, and which is showing on the screen, so you recognize it, and we just make a slight adjustment to it, so that instead of dphi and dx, we replace it by the vectors themselves. So we would simply say that the vector in the y frame of reference, and with the coordinate n, which we choose, is equal to the sum over m, where m is now the summation term, of the, as it were, gradient, which is dy n over dxn, where m is the summation term, times the vector in the x frame of reference, m.
What's going on? What? What's going on?
Over dxn, where m is the summation term, times the vector in the x frame of reference.
So this is defined in an arbitrary direction, like a vector. And this is the vector. Oh, you're treating phi. There's no phi, there's y. He's treating y instead of phi. So this is Sam. This is the gradient of y. The vector in the x coordinates, component m. The vector in the y coordinate system, direction n, dimension n. It's not showing the graph, the geometry. This is fake. my God, the server is full. Wow. This guy NASA Shell, the most bitter person, one of the most bitter persons I've ever seen in my life.
She is so much better than Trump. On issues, she's worse on several issues. But Trump is bad on the issues too. So it's not like Trump is this laissez-faire capitalist great guy on the issues, and it's just his character that I hate. He's terrible on the issues, and he would devastate the U.S. economy if he executed on his plan. I think his economic plan is dramatically worse than Harris's. Advance.
No, Trump wants to free at least the energy markets. Trump has Vinesh Ramaswamy, Vivek with him, and he has Elon Musk. Vivek is pretty good.
Reasserted his commitment to that plan in the VP. All right, everybody. Thank you. We are a little behind on the super chat, so just a reminder to ask questions. Remember, that's right. You can do stickers, which say, yeah. I mean, a reminder to everybody that they can support the show monthly on Patreon, or please just remind you of John Bobbin, who's been in business, HILIFE, where he took all the information out there from Tia and who you on scholarships for the Ironman conference in New York. Go up there, apply for the scholarship. I'm really hoping that you guys will come failure to. Like we're still evolving, but we're going to do an event in Tokyo. We're going to celebrate the state, and we're going to have an op coming to, which I keep promising to advertise. I keep forgetting. The 6th of November in. Yeah. So Porto Alegre. I've described this in great detail in the case of BB and how this works in TVs. So appreciate it if some of you would come in and like telling Israel, they'll do what's necessary, just win the stupid thing. We'll give you less money if you take longer to win it. The faster you win it, the more money we'll give you. If they had an approach around winning, then and they didn't handcuff Israel and Ukraine constantly, then these wars would be over and they would stop costing American taxpayers money. But you have to remember that these wars are, to a large extent, helping America defend itself. That is their vital, crucial, fundamental interest of Americans here. And that if you look at the deficits, if you look at the amount of money the United States spends, what is it, $3-4 trillion? A budget deficit of $1 trillion? Then all the aid to Ukraine and all the aid to Israel is a drop in the bucket as compared to $1 trillion. It's not even significant. It's not, 10% of $1 trillion is $100 billion. And, we're talking about less than $100 billion, so less than 10% of the deficit. Much less than, the entire spending. I'm not even sure because I don't know. We spent $60 billion on Ukraine, but over what period of time? And it's all weapons, and most of it is not really spending, so it doesn't go to the deficit because a lot of it is just transporting them equipment that we are not using and will never use. So it's not even coming off of. It's not even adding to the debt. It's not even a government expenditure, really. Anyway, so I think it's a bogus argument. I think if those populists express any concern about budget deficit, government spending, government deficit spending, if they were willing to consider reforming Social Security and Medicaid, if they were willing to talk about cutting welfare and cutting subsidies and cutting central planning on the economy, if they considered moving this economy to more freedom, then I take them seriously on Ukraine and Israel. But as it is, they want to increase spending in every area possible. They want to increase the deficit in every single area possible, except money to Ukraine and Israel. And that suggests to me that it's motivated by something very different, and it's primarily motivated by ignorance and stupidity and a disregard to American interests, and with a little bit of a hint of just hating anything foreign, anything outside the United States. So they're just not being honest about caring about government spending. And by the way, they shouldn't want to get money from the government. So complain about how little Americans get. Americans shouldn't get anything. The government is not there to hand out stuff to Americans or anybody else. America's there. The government is there to defend America. And if Israel and Ukraine are necessary for the defense of America, which I think to a large extent they are, then, but it's not there to provide relief from hurricanes and welfare and Social Security and medicine and all this other stuff to Americans. It's not there. It's not the purpose of the government. And when populists understand that, then they'll start whining about Social Security and Medicare, which is where the real problem is, not aid to Ukraine and Israel. Michael says, what is so wholesome about flyover country, middle America? I find it very lifeless and depressing. LA and New York City is where all the life is. Yeah, I'm not excited about flyover country. It's not. I would never want to live there. It's not interesting. But look, different people have different priorities in life. It's certainly peaceful. And it's some people love farming and some people like the lack of excitement. But it's not where where the world has changed. It's not where production happens unless you're in one of the cities in flyover country. Cities are where civilization advances.
So I'm trying to see what he's doing here. So this is the vector in y given a vector in x. And this is the y to the x. This is just a coordinate transformation. And this is the vector. This is the component of the vector. Okay, so you want the vector in y, expressed in y, a certain dimension. Okay, so that dimension, or that dimension of y, that dimension, of y, it's a certain axis. So you want to walk along that. I want that. I want a certain component. I want that component of the vector. I want to build the vector. So instead of define, you're saying vector. This is fine. The topology how does the topology change? In an arbitrary direction given these components of this arbitrary direction. It's very strange when we derive this, he didn't derive it for a coordinate transformation. He's using it for a coordinate transformation. This is not the change. You could view a vector as a change. Right, this is a change in the terrain because It's a change in a function. And he's saying you can view the coordinate y as a function of x. Let's ignore this equation. Maybe we can just figure this out. So, given given a vector in the x dimensions, so we go through all of these dimensions in the x, all the x coordinates. For each x coordinate that makes up the vector, so what do? We want to convert it to a vector in the y coordinate system. Okay. Well, so each y dimension has a ratio changes as you walk along each x dimension. But we're talking about we only want a certain y dimension. Given a certain y dimension, right? We don't want the whole vector. We're taking a vector in x, we want to convert it to a vector in y, but we only want to get the component of y, of the vector in the y space, but only the n component. So we only care for the n dimension of the y coordinate system. So as we move along each of the x's, it changes the y in a certain way. We walk along x1 and the yn changes. We walk along x2, y2 changes. So we take the gradient of the n y to the x1 and we'll multiply it by x1. And there's a certain gradient of the y I just wish he had a diagram for this. This is just a coordinate transformation of a vector. Okay.
M. So that is the way in which we, and I shall call that equation number 3. That's the way vectors transform. We're using equation 1 that we derived and modifying it slightly, that the vector in the, or rather the nth coordinate of the vector in the y frame of reference is equal to the sum of this gradient term times the mth, where m is summed, of course, coordinate in the x frame of reference. And you have to sum over.
Interesting. He calls it frame of reference. Wow. That's very good. So you want a generalized coordinate system. So you can generalize an event.
These terms in order to get the nth coordinate in the y frame of reference. The tensors that we will be interested in are tensors of rank 2. And what a tensor of rank 2 is a combination of vectors where there is a fixed relationship between the two. So let's just think of some system which has a combination of vectors. Let's take a very simple one. Let's put a block on the floor, and we're going to apply a force to it in order to move the block a certain distance, x, in this direction. And the work done will be the force times the distance. But of course, we can't just take the force. We have to take the component of the force that is moving in the direction we want to go. So if that angle is alpha, then the component of the force acting in the direction of movement is F cosine alpha. So the work done will be the component of the force that's in the direction we want to move times the distance we travel. And you can think of F and X as being vectors. X has a magnitude and a direction. The direction is in the X direction. F has a component that has a magnitude and a direction. The component, at least, of force in the X direction. It has magnitude and direction. So we've got essentially something which combines two vectors. Now, the question is, suppose the force is in that direction. Then the angle alpha will be 90 degrees. And the cosine of alpha is 0. And therefore, the work done will be 0 because, of course, the block won't move. If you're pushing down on the block, you're not going to get it to move in the X direction. And here's the thing, that it doesn't matter what frame of reference you apply to this system. Whatever frame of reference you apply, that block will not move. The value of the work done will be 0 in all frames of reference. And that's the value of a tensor. A tensor is the relationship between two vectors. And if the tensor has a value of 0 in one frame of reference, it must have a value of 0 in all frames of reference. If that block doesn't move, it doesn't move. It doesn't matter what frame of reference you apply to observe it, it doesn't move. Tensors, therefore, are fixed relationships between two vectors in such a way that if that relationship equals 0 in one frame of reference, it equals 0 in all frames of reference. And that is why tensors are so important in Einstein field equations. So let's consider a combination of vectors. Doesn't matter what it is for these purposes. We're going to take vector A, and we're going to take the nth coordinate of that vector. Remember, there are dimensions in space. I am actually using only 2 dimensions for this simplistic analysis, so n is either 1 or 2. You choose which one you want it to be. And we take another vector b, and we'll take the nth coordinate. That can be 1 or 2, you choose. And we say that the combination of the two becomes a tensor.
1 second. Let me go get a toothpick.
Of rank 2, which we indicate by saying that it has those two coordinates, m, or two indices, m and n, equals the vector A with the coordinate or the dimension m, and vector B with the nth dimension. So obviously, if I'm talking about two-dimensional space where m can be either 1 or 2 and n can be 1 or 2, then T are equations. So let's consider a combination of vectors. Doesn't matter what it is for these purposes. We're going to take vector A, and we're going to take the nth coordinate of that vector. Remember, there are dimensions in space. I am actually using only 2 dimensions for this simplistic analysis, so n is either 1 or 2. You choose which one you want it to be. And we take another vector b, and we'll take the nth coordinate. That can be 1 or 2, you choose. And we say that the combination of the two becomes a tensor of rank 2, which we indicate by saying that it has those two coordinates, m, or two indices, m and n, equals the vector A with the coordinate or the dimension m, and vector b with the nth dimension. So obviously, if I'm talking about two-dimensional space where m can be either 1 or 2 and n can be 1 or 2, then T and n, there can be 4 versions of that tensor, where m and n each have values 1 and 2. If you've got 3 dimensions of space, m and n can each have values 1 to 3, and so T and n has 9 different versions. If there are 4 dimensions of space-time, 1 time, 3 dimensions, T and n will have 16 different values. Well, now I'm going to use equation 3 that we derived earlier, and which should be showing on the screen, to take the vectors A and B, and to ordinate their characteristics, the indicate one is. So in one frame of reference.
This is the most confusing thing I've ever seen in my entire life. The problem with the way he's teaching is that there's no purpose. I mean, Einstein didn't just come up with ideas. I mean, there is a purpose to this. No one is explaining the purpose. Like, where are we going with this? What's the purpose of this? Like, you're walking me through the dark forest to the end of the street, go back, go there, but why? What's the motivation for this weird game?
It equals 0 in all frames of reference, and that is why tensors are so important in Einstein field equations. So let's consider a combination of vectors.
So tensors are Lorentz invariant. They don't change due to a transformation of coordinates. of frame of reference. So they are true forces.
Doesn't matter what it is for these purposes. We're going to take vector A and we're going to take the nth coordinate of that vector. Remember, there are dimensions in space. I am actually using only 2 dimensions for this simplistic analysis. So m is either 1 or 2. You choose which one you want it to be. And we take another vector B and we'll take the nth coordinate. That can be 1 or 2. You choose. And we say that the combination of the two becomes a tensor.
Is this in the same space? Vector A and B are in the same space? He didn't say.
In Einstein field equations. So let's consider a combination of vectors. Doesn't matter what it is for these purposes. We're going to take vector A and we're going to take the nth coordinate of that vector. Remember, there are dimensions in space. I am actually using only 2 dimensions for this.
So we're only looking at a certain dimension of A.
Simplistic analysis. So
1 or 2.
m is either 1 or 2. You choose which one you want it to be. And we take another vector B and we'll take the nth coordinate. That can be 1 or 2. You choose. And we say that the
it could be 1, 1, 1, 2, 2, 1, 2, 2.
combination of the two becomes a tensor of rank 2, which we indicate by saying that it has those 2 coordinates, m, or 2 indices, m and n, equals the vector A with the coordinate or the dimension m, and vector B with the nth dimension. So obviously,
so there's a bunch of, so TMN is either A11, A12, but if there's 3, it's A11, A12, A13. If there's 4, A11, A12, A13, A14, and then for 2 and for 3 and for 4, so there's 8. For 4 dimensions, I think there's 16. 4 times 4.
if I'm talking about 2-dimensional space where m can be either 1 or 2.
2 dimensions is 1, 2, 1, 1, 1, 2. Oh, but you only care for the ones that are the same.
And n can be 1 or 2. Then T and n, there can be 4 versions of that tensor, where m and n each have values 1.
So I guess you want all of them, okay.
1 and 2. If you've got 3 dimensions of space, m and n can each have values 1 to 3, and so T and n has 9.
9? 3 times 3, yeah.
9 different versions. If there are 4 dimensions of space-time,
16?
1 time 3 dimensions, T and n will have 16 different values. Well, now I'm going to use equation 3 that we derived earlier and which should be showing on the screen to take the vectors A and B. So we're going to take AM in the...
Okay, so this is the equation of the vectors, which is, okay, we already have the vectors. So A, and now we're going to do transformation of the vector, this vector combination, which he's not explaining the reason why we have a vector combination. No reason, just, keep keep going without any explanation.
The Y frame of reference, and
I'm surprised I was speaking. I don't remember Totoro. He's not even an expert in quantum mechanics or GR or SR. He's not an expert. So why is he so violent?
Bn in the Y frame of reference. And we're going to try and see what they are in the X frame of reference using equation 3, where you can see that we've just got to replace.
So we're taking AB just like before, but this time we also want to apply coordinate transformation. That should be straightforward. So I wish I could debate these people and talk to them, but it's futile. These people they're gone. And all they want to do is hurt your feelings. Like they feel like they're accomplishing something by hurting your feelings. When they hurt your feelings, so it's like the antithesis of a proper debate. Like they came to the conclusion that they're not going to convince you, so they might as well hurt your feelings. It's like Discord is supposed to be this place where people meet to talk and exchange ideas. No. As soon as they realize that they lose a debate, they go into vile mode. They throw a tantrum. Talk to them at this point. They know they lost. Anyway, this is straightforward. So this is AMY, and you have VYN. So this thing, just replace, right? Instead of V, you have A. Instead of N, you have M. Instead of Y, you have Y. So that doesn't change. So you have the equation. But instead of V, you say A. Instead of M stays here. X stays here. Instead of Y is good. Instead of N, whatever. It's straightforward. So this thing is going to be this thing. And then you're going to do the same for B and Y. It's going to be B and Y. This time N stays. And you have a Y. So it's the sum over M. dy n dx m b mx, and I guess it's multiplication.
V in equation 3 by A and then B. So let's do A first of all. We need a sum term. I can't use M anymore because that's already been used here. So I'll just introduce a value R. Remember, this is a summation term. It's called a dummy variable. It doesn't know what you put. And that's going to be dym by dx R times A in the X frame of reference R. That does the vector A. And now we need to do the vector B in the X frame of reference.
You're not putting a dot for multiplication?
Which again, from equation 3 comes, I now need another summation term. Let's call it S. And that's going to be dyn by dx S times B in the X frame of reference S. So you sum over the R terms and you sum over the S terms, but M and N are chosen. They're the values you happen to choose for this particular equation. Well, let's look and see what this reduces to. Firstly, AMBN, well, that's just the tensor, TMN, in the Y frame of reference, because that's what we selected here. And that is going to be equal to the sum over R and S. That's not quite the right way to do it, but essentially you've got two sum terms here, which I'm just going to simplify here. Multiplied by dym by dxr, and then you've got a dyn dxs, times AXR BXS. That's that term and that term. But what is this? Well, if you look at this term up here, you'll see that it's...
Wait, what? Wait, move your pencil.
Just another...
So, okay, this is the tensor. In the Y dimension, in the Y frame of reference, of dimension M. Wait, what? Well, the definition of vector A in M dimension times vector B in the N direction is a tensor in the M dimension to N dimension. So this is just the definition. So this goes into this. That's fine. Now you're summing, I'm assuming that you're summing this and you're multiplying by this summation. So it's one summation? I don't get it. I don't know. The summation Now I don't know what he means. What I never seen this thing that this notation. You have the summation over R of this thing times the summation over S, right? Are you multiplying? I don't know what you're doing here. Are you multiplying two vectors? I don't know what you're doing. If you have two vectors, I don't like what is going on here?
Doesn't matter what it is for these purposes. We're going to take vector A and we're going to take the nth coordinate of that vector. Remember, there are dimensions in space. I am actually using only 2 dimensions for this simplistic analysis. So m is either 1 or 2. You choose which one you want it to be. And we take another vector B and we'll take.
Are you multiplying them? What are you doing?
The nth coordinate, that can be 1 or 2, you choose. And we say that the combination of the two becomes a tensor of rank 2, which we indicate.
What is the combination of the two? You're just putting the two vectors next to each other? What are you doing?
By saying that it has those two coordinates, m, or two indices, m and n, equals the vector A with the coordinate or the dimension m, and vector B with the nth dimension. So obviously, if
let's look at what he's saying. And vector B, and just you end
coordinate or the dimension m, and vector B with the nth dimension. So obviously, if I'm talking about two-dimensional space where m can be either 1 or 2 and n can be 1 or 2, then T and n, there can be 4 versions of that tensor, where m and n each have values 1 and 2. If you've got 3 dimensions of space, m and n can each have values 1 to 3, and so T and n has 9 different versions.
I'm just assuming you're putting them next to each other?
If there are 4 dimensions of space-time, 1 time, 3 dimensions, T and n will have 16 different values. Well, now I'm going to use equation 3 that we derived earlier, and which should be showing on the screen, to take the vectors A and B. So we're going to take AM in the Y frame of reference and BN in the Y frame of reference. And we're going to try and see what they are in the X frame of reference using equation 3. Well, you can see that
it's just, I'm taking this vector and this vector, and I guess placing them next to each other. I don't know.
we just got to replace V in equation 3 by A and then B. So let's do A first of all. We need a sum term. I can't use M anymore because Y, the vector A. So
this was easy.
Well, let's look and see what this reduces to. Firstly, AMBN, well, that's just the tensor, TMN, in the Y frame of reference, because that's what we selected here. And that is going to be equal to the sum over R and S. That's not quite the right way to do it.
That's not quite what you do with it, but I'm going to do what with it?
Frame of reference, because that's what we selected here. And that is going to be equal to the sum over R and S. That's not quite the right way to do it, but essentially you've got 2 sum terms here, which I'm just going to simplify here, multiplied by dy.
Multiplied by dy?
R and S, that's not quite the right way to do it, but essentially you've got 2 sum terms here, which I'm just going to simplify here. Multiplied by dy m by dx.
Multiplied? The sum term? What? Anyway, you put these two vectors next to each other. So this is just one vector. So this is the m over r.
XR, and then you've got a dyn dxs times AXR BXS. That's that term and that term.
Times? You multiply? What is going on here? What is he talking about? Now you're multiplying?
But what is this? Well, if you look at this term up here, you'll see that it's just another tensor. In this case, it's the tensor in the X frame of reference, but its indices are R and S. And that I'm going to call equation 4. And I'll put a block around that because
he's not multiplying. This is not multiplication. This is just putting things next to each other. But this was multiplied. What the heck is going on?
because we may need that in the future. And that is called, it gets a technical term, it's called the contravariant transformation. It's the transformation from the Y frame of reference to the X frame of reference for tensors. There is an equivalent form of tensor transformation.
What is a tensor? This is the worst explanation I've ever heard. Every time I get to tensors, no matter in whose course, I don't understand it. This is like, why are tensors so impossible to explain? What is a tensor? I know what a tensor is in engineering. What is a tensor? Just tell me what a tensor.
This giant crashed to the floor.
Is it illegal to hide your face in school? Billy, take it off. You know you can't wear that. Well, it's actually a lot more complicated than you think. Complicated? No, it's not. He just needs to take the darn thing off. I'm not so sure about that either. In fact, it actually came down to the Supreme Court. Oh, great, a history lesson. Yeah, this is history class. In the 1960s, a school in Des Moines, Iowa, suspended students for wearing armbands in protest of the Vietnam War. And history is about to repeat itself. Suspended!
Yeah, this guy's the leftist. UK integration. UK integration? What is he talking about?
Where is this? Hey, this is pretty fucking wild, guys. My Discord's been going absolutely fucking insane for the last half hour because people are getting their notifications on their siren apps, getting all the alerts. There are sirens like everywhere in Israel right now. Iran has fired their, I guess, response to the incursions into Lebanon. They fired at least 100 ballistic missiles. There are interceptors like flying all over the sky. There have been what sounds like a lot of landings. There's been at least, I think, 2 shootings as well in Jaffa. There were Jaffa and a synagogue. There were, I don't know who they were, but guys with automatic weapons going around a train station area and around bus stops shooting people. Like, at least 2 or 3 people are dead.
This is from like 2 days ago or something. Yeah, Israel is fully concentrated on Lebanon right now because Lebanon is urgent. Because as long as Lebanon, missiles from Lebanon, there's no time to react to. So Israel needs to wipe out Lebanon quickly. What's this?
Verdict of the jury is count 1. We, the jury, find the defendant, Carly Madison Gregg, guilty of first-degree murder as charged in the indictment. Count 2. We, the jury, find the defendant, Carly Madison Gregg, guilty of attempted murder as charged in the indictment.
She killed her daughter?
Count 3. We, the jury, find the defendant, Carly Madison Gregg, guilty of tampering with evidence as charged in the indictment. Please be seated, Ms. Gregg. Ladies and gentlemen, the jury is custom for the court to poll the jury. I have to do it each time. And for each count, I'm not being rude. The quickest way for me to get through this is to simply point at you and you answer out loud. As to count 1, we, the jury, find the defendant, Carly Madison Gregg, guilty of first-degree murder as charged in the indictment. Beginning on the first row, ma'am, is that your verdict? Sir, is that your verdict? Yes, sir. Ma'am, is that your verdict? Sir, is that your verdict? Ma'am, is that your verdict?
How does he know their genders?
You got to answer out loud, ma'am. I'm sorry. Yes. On the back row, sir, is that your verdict? Ma'am, is that your verdict? Ma'am, is that your verdict? Sir, is that your verdict? Ma'am, is that your verdict? Ma'am, is that your verdict? Verdict of the jury is count 1. We, the jury, find the defendant, Carly Madison.
This iPhone was dropped in the ocean and it shows absolutely no signs of life. My customer called another company.
That laptop might as. A man is washing his electric.
I sincerely hope that whatever it was you wanted.
Oh. Will Carly Gregg get a new trial? Deadly daughter murder trial.
We all heard Carly screaming when you walked into the garage, from the garage into the kitchen on March 19th. How did Carly appear to you when you walked in?
I said my initial thoughts were she was terrified, scared out of her mind. I still to this day don't think she ever even recognized me. Something was wrong there. I don't know what, but something was off.
Carly Gregg's stepfather, Heath Smiley, testifying at her murder trial. She also shot him. He survived. And his testimony, incredibly sympathetic to his stepdaughter. Amazingly so. Heath Smiley, Carly Gregg, Ashley Smiley, they all lived together. They were.
Yeah, stepdaughters are very dangerous. I think stepchildren are dangerous. It's unfortunately just dangerous.
Her family, but she's dead because Carly shot and killed her mother, shot her stepfather. He survived, and he is standing 100% behind her.
So she shot her step parents.
I want to go back and remind you of the compelling arguments and the dramatic verdict.
She murdered her mom, her adopting mom.
In this case, and a lot of it had to do with the age of this defendant, who was just 14 at the time she shot and killed her mother.
Why did she do it?
Ladies and gentlemen, there's no doubt that Carly Madison Gregg is the one who killed her mom, Ashley Smiley. There's no doubt that she attempted to kill Pete Smiley when she aimed a gun right at his head and shot and hit him in the shoulder. And there's no doubt that she's the one who hid the camera, thus tampering with evidence in the refrigerator. And we would ask you that you go back there and you find her guilty of all three, because she was not insane at the time that this happened. She knew exactly what she was doing, and she knew the difference between right and wrong.
Yeah, but why did she do it? Just because, like...
We've heard the testimony of Carly's stepfather, who has no reason to defend this child. It's not his biological child. He was very much in love with his wife. They were still in the honeymoon phase. You heard him on that 911 call. That was a man in shock and grief and in pain. You heard his testimony about feeling intimidated regarding his testimony in this case. But despite all of that, he has continued to tell the truth consistently from March 19th until his testimony in this courtroom today, and he continues to stand by Carly to this day and support her. And he said, yeah, I've noticed that Carly was experiencing memory lapses in the fall of 2023. It was bizarre. And while she was having a state of psychosis in an episode of acute stress on March 19th, she lost herself in what was the perfect storm. I am asking you, for those reasons, to please find Carly Gregg not guilty by reason of insanity and finally quell this storm for Carly and her family.
When he arrived home, opens the door, and gets shot at. He took the stand. He tells you to this day.
I mean, such a pretty girl. What did she go through? I mean, the fact that she's adopted, she probably, maybe she's like traumatized.
That wasn't Carly. The person that was shooting at him was not Carly. It's real important. He's the last person that's seeing her right there as it's happening. This is the person who knows. This is the person that sees her every day, that knows Carly. And yet, he's saying she's shooting at him. If there's anybody that has a reason to...
A teenager in Mississippi on trial for murder, accused of shooting her stepfather and murdering her mother.
I need something. What is your somewhere? He was in jeans and a gray t-shirt. She got short, brownish hair. So jeans, a gray t-shirt, short brown hair. She ran into the backyard. I tried to follow her. She shot me in the neck.
Carly Gregg was just 14 years old when she was charged with murder, attempted
Jesus Christ.
murder and tampering with evidence. Prosecutors say in March of this year, the teenager shot her mother, Ashley Smiley, in the neck, killing her. After killing her mother, Carly allegedly texted her friend, asking her to come over to see her mother's lifeless body. And when her stepfather, Heath Smiley, arrived home, he tried to wrestle the gun away from the teen, but was shot in the shoulder. Months after her mother's horrific death, now 15 years old, Carly Gregg went on trial after turning down a plea deal that would have sent her to prison for 40 years. During the state's opening statement, State Attorney Catherine White Newman told jurors Carly killed her mother after her mom was made aware of the secrets Carly kept hidden.
We're here because on March the 19th, 2024, Carly rode to school with her mother that day. Ashley was a school teacher at Northwest Rankin, taught geometry. Carly was in the 10th grade. You'll hear that morning, she got in a little altercation with one of her friends, cussed him out. But what you'll hear, ladies and gentlemen, from the testimony of this friend is that he was so worried about Carly's use of smoking marijuana, and so worried about her being high, and so worried about her having these burner phones that her mom didn't know about, that he felt compelled to tell Miss Ashley Smiley that day. Ladies and gentlemen, after the incident with Carly that morning, you'll hear that he gets in touch with another friend, and he's like,
yeah, school is terrible. The drug war is terrible. Parenting is usually terrible. So, and she was young and confused. The system is terrible. You know, the system can create these spikes, these cases, these edge cases. That's the nature of the beast.
hey, you got to keep her distracted so I can go tell Miss Smiley what's going on. Ladies and gentlemen, this friend cared about Carly. He was like, I got to intervene. I got to tell her. I'm afraid of what's happening. You'll hear from him that he did in fact tell Miss Smiley. But after 4 o'clock that day, he goes and he tells Miss Smiley, hey, Carly has got these vapes. She's got this phone. Ladies and gentlemen, you'll hear then that Carly Gregg
How is it anyone's business what she's doing with her life?
rides in the car home with her mother from school to their house. They leave school.
School is nothing but a jail system. And this is terrible.
Sometime after 3:30, they get home a little before 4. You'll hear that when they get inside the house, it's only their 2 dogs, Ashley Smiley and Carly Gregg. Immediately, Carly goes and lets the dogs out. You'll hear testimony that Ashley then goes into Carly's room. You'll hear that while Ashley is in her room, that Carly's still outside. At some point, Ashley finds what law enforcement believed to be the 4 boxes that contain vape pens. Testimony will be that we believe she carried them from Carly's room to her bedroom, went back to searching Carly's room. The evidence will show that almost immediately, upon Carly coming inside the house,
Yeah, terrible. So what is a 14-year-old killer distorts bipolar 2.
Oh, this is Dr. Grande. Today's question is, can I offer an update on the case of Carly Gregg? Just a reminder, I'm not diagnosing anybody in this video, only speculating about what could be happening in a situation like this. If you enjoy this video, please like it, subscribe to my channel, and consider supporting me on Patreon. Carly Madison Gregg was born on April 23, 2009, and lived in Brandon, Mississippi. This town is 13 miles east of Jackson. Initially, she lived with her mother, Ashley Smiley, and her father, Kevin Gregg. But the couple divorced, and her mother married a man named Heath Smiley. Carly lived with her mother and stepfather in a 3-bedroom house on the 200 block of Ashton Way.
Oh, it's her mom and stepdad. Okay.
When Carly was in 7th grade, she brought a knife to school and was sent to an alternative school for 1 semester. A psychotherapist who treated Carly believed the situation was blown out of proportion, and Carly was not a danger. She was returned to a traditional school. Carly performed well in high school and had been both the student of the month and the student of the year. She attended the same high school where her mother worked as a math teacher. For many years, Carly had struggled with a variety of mental health symptoms. When she was 4 years old, she had a sister who died. This may have led to symptoms of
Jesus Christ.
Post-traumatic stress. Carly would later report that she had experienced symptoms of depression when she was 9 years old. During the summer of
Jesus Christ.
2023, Carly experienced insomnia. In January 2024, her mother, Ashley, connected Carly with mental health services. Carly received psychotherapy on a weekly basis and was prescribed 25 milligrams of Zoloft. This is an SSRI, often used to treat depression. Carly was diagnosed with major depressive disorder and adjustment disorder. In February 2024, Carly's dose of Zoloft was changed to 50 milligrams, and she started using marijuana. On March 12, she reported that she felt like a
So marijuana is good for her.
zombie. She was put on a different SSRI called Lexapro. She received 5 milligrams. Carly was supposed to decrease her dosage of Zoloft slowly, but she stopped that drug immediately. Now moving to the timeline of the crime. On March 9,
Jesus Christ. So her life was a living nightmare since her sister died.
2024, not long after 5 p.m., 39-year-old Heath Smiley placed a 911 call and told the operator that his 14-year-old stepdaughter, Carly Gregg, shot him. When the police arrived, they encountered Heath wounded on the front porch of his house. Inside the house, they found 40-year-old Ashley Smiley dead from 3 gunshot wounds to the head. Carly Gregg was found about a half mile away and taken into custody. Here's what the police found during the course of their investigation. Earlier that afternoon, Carly and her mother Ashley arrived home from school. The house was equipped with a surveillance camera inside the kitchen and a camera in the garage that pointed outside. When Carly took the family dogs out, her mother Ashley searched Carly's bedroom, probably for marijuana. After Carly brought the dogs back in the house, she looked in her bedroom and saw what her mother was doing. In response,
Why do you care? Why do parents care? It doesn't matter. She was a model student, student of the month, student of the year. That's all that's important. Why do you care that who cares? Oh no, she's smoking drugs. Oh no. None of your business.
Carly walked to her mother's bedroom and retrieved a Taurus 357 Magnum revolver loaded with
The kid is falling apart and all you care for is that she's doing drugs?
38 special cartridges. As she walked from her mother's bedroom back to her own bedroom, Carly kept her hands behind her back to conceal the weapon from the camera in the kitchen. At 4:14 p.m., Carly entered her bedroom, pointed the revolver at her mother, and discharged the weapon 2 times. Ashley was struck in the face by both bullets. Carly
Okay, I mean, the kid was obviously this makes no sense. I mean, why did she murder her mom? Why would she do it? I mean, it makes no sense. There's no motive. What's the motive?
then walked up to her mother and shot her a 3rd time under the chin. After killing her mother, Carly exited the bedroom, entered the kitchen, and retrieved her mother's cell phone from the counter. Impersonating her mother, she sent text messages to her stepfather Heath, trying to figure out what time he was coming home. Carly wrote, "When will you be home, honey?" At this point, Carly texted a 16-year-old female classmate identified in court only with the initials BW. Carly told BW it was an emergency and she needed to come over to her house. BW's father drove her to Carly's house. When BW entered the house, Carly asked her if she had ever seen a dead body. When BW responded no, Carly showed BW Ashley's body. Carly also...
Look, obviously, she is messed up. I mean, that's not normal. There's no motive. Obviously, she's going bananas. She's losing her mind. There's no motive. There's no crime. This is just losing your... This is what it looks like when you lose your mind.
also showed her the revolver she had used to kill her mother, indicating that she had discharged the weapon 3 times. She still had 3 cartridges available, which she intended to use to kill her stepfather. Carly was going to shoot him 2 times in the head and 1 time in the chest. Carly asked BW if she wanted to wait outside, which is what BW did. About 15 minutes after the shooting, Heath Smiley arrived home. As soon as he walked into the house, he saw Carly standing in the kitchen with a revolver. Carly shot Heath 1 time in the shoulder before he was able to take the revolver away from her. After the shooting, Carly screamed and ran out of the back of the house. Her friend BW had been waiting outside. Both girls jumped over the fence and ran away. As I mentioned, Carly was found a half mile away and taken into custody. Carly Gregg was charged as an adult with first-degree murder, attempted murder, and tampering with physical evidence. The state offered Carly a very good plea deal. If she pleaded guilty to the murder charge, the other 2 charges would be dropped, and she would serve 40 years in prison. She rejected the state's offer and decided to take her chances at trial. There was no doubt that Carly conducted the shooting, which killed her mother and wounded her stepfather, but her defense argued that she was not guilty by reason of insanity. As it turned
Obviously, this is reasons of insanity. I don't know how to fix her, but you can't. There's no crime because There's no motive. What's the motive? Why kill?
Turns out rejecting the plea deal for 40 years in prison was a disastrous
So you want to punish her for rejecting the plea deal?
miscalculation. On September 20, 2024, in Santa Fe, as it turns out, rejecting the plea deal for 40 years in prison was a disastrous miscalculation.
Why?
On September 20, 2024, Carly Gregg was found guilty on all 3 charges. She was given 2 terms of life in prison without the possibility of parole for murder and attempted murder, and 10 years in prison for tampering with evidence. All the terms are to be served concurrently. Now moving to my analysis. When I initially reviewed this case, there was not a lot of information available about Carly's mental health symptoms. The plan of the defense to prove legal insanity was not clear. During the trial, of course, a lot of information about Carly's mental health was revealed from multiple sources, including mental health clinicians who had assessed her. The defense argued that Carly had bipolar II disorder, which is characterized by episodes of depression and hypomania. Hypomania is a less severe form of mania. The defense argued that Carly experienced psychosis and dissociation and did not know the difference between right and wrong. This brings me to the question, now with all the evidence available, was Carly guilty of murder? Let's take a look at the evidence both for and against the idea that she was guilty, starting with the inculpatory factors.
Well, nonsensical defense. Obviously, he doesn't like her. He's going to go against her. I disagree with him.
Not long before the killing, Carly started smoking marijuana. She knew this was illegal, and her mother did not approve.
Many things are illegal. The United States is illegal. This planet is illegal. That doesn't mean anything.
Carly shot and killed her mother as her mother was searching Carly.
This guy's like, oh, they did drugs. Drugs are illegal. Therefore, who cares? Who cares? This guy's like Mr. Perfect. Oh, I'm Mr. Perfect. I don't do anything illegal. Really? You want us to check? You want us to look into your life? Go up and down with a magnifying lens? Maybe we'll find something? We might. You want to take a chance? You waive your Fifth Amendment?
Carly's bedroom for marijuana. After the killing, Carly impersonated her mother, called a friend to show off the body, stated that she intended to kill her stepfather, and removed the surveillance camera from the kitchen and
What's the motive? There's no crime if there's no motive.
put it in the refrigerator. After shooting her stepfather, Carly fled the scene. All these actions indicate that Carly knew what she was doing and understood her behavior
What do you mean? What's her motive?
was wrong. She was acting with a purpose to accomplish a defined goal. Carly
What's the motive?
was not disorganized, out of control, responding to internal stimuli, or maintaining a fixed false belief. A mental health clinician for the state testified that Carly had a few traits of psychopathy. He did not believe she had bipolar I or bipolar II disorder. Carly knew the nature, quality, and wrongfulness of her actions on the day of the attack.
What was her motive?
The mental health counselor, who Carly met with 9 times in the months leading up to the killing, testified that Carly denied
Look, I'm not saying release her back into general population, into the streets. I'm just saying there's no crime. There's no motive. You need motive. The definition of a crime is you need motive. What did she gain? She destroyed her life. There was nothing to be gained. There's nothing to be gained. There's no motive imaginable. There's no crime. What's the crime? That's not murder.
hearing voices. This is important because Carly's defense was based on the idea that she was psychotic. Hearing voices is a symptom of psychosis, find the quality and wrongfulness of her actions on the day of the attack. The mental health counselor, who Carly met with 9 times in the months leading up to the killing, testified that Carly denied hearing voices. This is important because Carly's defense was based on the idea that she was psychotic. Hearing voices is a symptom of psychosis, auditory hallucinations. Carly told the counselor that she planned on reading Crime and Punishment, a book that features a character who comes to believe he is entitled to kill other people for the good of society. Carly kept a journal which contained themes of nihilism, narcissism, death, and being evil. The journal contained a list
Okay, so she was losing her mind. What do you want?
of her beliefs, which included writing your own
And you're not talking about the fact that she lost her sister. That probably drove her over the edge into insanity.
destiny, loving yourself, don't need a family. It's okay.
And her mom threatened her if she would have discovered the cannabis. Her mom would have flipped out, and the kid, this child, was confused, was being threatened. And she's taking drugs, and her sister died, and everything is collapsing in her universe. She's not seeing straight, so she did crazy things.
to be evil. Sometimes you must jump into the dark and see the light, and death is inevitable. Carly also wrote, quote, I choose fire. It is powerful, beautiful, and deadly. These are the traits I desire, so I choose fire, unquote. A critical aspect of Carly's defense is that, at the time of the shooting, she was not only psychotic, but also experiencing memory loss. Bipolar II disorder can lead to psychosis when the person is depressed, but hypomania does not lead to psychosis.
Okay, so the defense, as you said, is nonsensical. That's fine.
Disorder is not associated with dissociation or memory loss. Psychosis
The defense tried their best. It's not a good idea. I don't believe in that approach.
and memory loss are separate conditions. Psychosis does not inherently cause significant memory loss, and memory loss does not cause psychosis. On occasion, psychosis can interfere with memory, but it is typically not associated with complete memory loss, like a blackout.
amnesia, and blackouts are usually connected to substance use, head trauma, or dissociative disorders. Carly did not have significant substance use, and there was no report of head trauma. For Carly's defense to be valid, she would have needed to experience a psychotic episode and a dissociative episode simultaneously, just through coincidence, a terrible and lethal confluence of unlikely circumstances. Moving to the exculpatory factors, even though the mental health counselor noted that Carly denied hearing voices, Carly did report intrusive and destructive thoughts, being easily angered, and having insomnia. She may have had a fear about transforming into her father, who the defense claimed had bipolar disorder and schizophrenia. As a side note, this is a curious appraisal because when a person meets the full criteria for both of these disorders, they should be diagnosed with schizoaffective disorder. That disorder is a combination of bipolar and schizophrenia. A mental health clinician who testified for the defense diagnosed Carly with bipolar 2 disorder. She had reported to this clinician that she started hearing voices sometime between the ages of 6 and 9. The voices told her that she was better than other people. She also reported symptoms consistent with dissociation, like feelings of being in a dream, being distant from the world, and being in a fog. This clinician believed that Carly did not understand the difference between right and wrong at the time of the killing.
This kid is messed up. What? I don't know. I mean, she's messed up. This is not there's no crime.
The Lexapro combined with mental health symptoms caused Carly to experience psychosis and to have dissociative symptoms. In a journal entry made a week before the killing, Carly wrote, "Oh, I think I had a psychotic break earlier. The whole ordeal is quite silly. I actually spoke with one of the voices in my head," unquote. On rare occasions.
There you go. Congratulations. She's losing her mind. Plus, her father lost his mind.
Like less than 1% of the time. SSRIs have been known to trigger manic or depressive episodes in people who have bipolar disorder. It is not out of the realm
Jesus Christ.
a possibility that the Lexapro caused Carly to become psychotic. When considering all the evidence in this case, do I believe that Carly was guilty of murder? Yes, in my opinion, she was guilty beyond a reasonable doubt. What do I think happened in this case? This is just a theory, my opinion. Carly was self-centered, impulsive, irresponsible, intelligent, cold.
Self-centered. Okay, that's just her nature. So that's not a bad thing.
Callous, arrogant, nihilistic, grandiose, falsely believed she was special, and had a sense of entitlement.
Yeah. Well, what do you want? Okay, that's a given. She didn't choose to be that.
Herself to be superior to other people. The voices telling her she was better than other
So
people
punish her for the way she was born. Congratulations.
were not hallucinations. Rather, this was her voice. She needed to believe in her superiority. When Carly discovered that her mother was attempting to seize her marijuana, she had a sense of entitlement. She considered herself to be superior to other people. The voices telling her she was better than other people were not hallucinations. Rather, this was her voice. She needed to believe.
Well, did she hear these voices or not?
In her superiority. When Carly discovered that her mother was attempting to seize her marijuana, the information was filtered through Carly's cold and calculating nature. She killed her mother to solve the problem without thinking about the consequences.
Oh, without thinking. Okay. Yeah, this guy is disgusting.
Vague references to psychosis that Carly had made were twisted into an ineffective defense strategy, and Carly was convicted. The same arrogance and lack of empathy that facilitated the crime led to Carly rejecting the plea deal. This sealed her fate and protected society at the same time. Those are my thoughts in the case of Carly Gregg. Please put any opinions and thoughts in the comment section. They consistently generate an interesting dialogue. As always, I hope you found my analysis of this topic to be informative. Thanks for watching.
Yeah, I disagree with you thoroughly. Anyway, I gotta go. I'm gonna do this tomorrow. What is a tensor? What is a tensor? Because I cannot for the life of me understand. This tensor is easy. We're gonna have to watch a bunch of tensors, as many tensors as it takes until I start getting the feeling for what a tensor is. All right, everybody. Thank you very much. Today was a very long day. All right. Bye-bye.